All right, we're going to go ahead and get started. So, I am Jules White. I'm a professor in computer science, and I'm the senior advisor to the chancellor on generative AI in enterprise and education. So I'm really excited to talk today because basically everything that we've done for decades in computer science, in computing, and software is officially dead. And it's like one of the most exciting times in my career to know that everything that I've done throughout my career is officially obsolete and old. But it's exciting because the future of computer science, the future of software, is something that is much more creative, much more humane, and much more accessible to everyone. So I'm going to try to give you a picture and a window into what that looks like, the end of computer science and the birth of the new computer science. And that is really going to be based on agents. So I teach a number of Coursera courses. I have about 600,000 students in my classes, and over 1,000 companies have paid for their employees to go through. And so I'm going to be talking about the big picture things that I'm seeing across these organizations that are really impacting the way that we do computing. Now, one of the first things I like to start with when thinking about this is this thing that we kind of miss a lot of times and don't appreciate when we're using these models, and that's this idea that they were built and really tested originally on translation, translating one human language into another. It just turns out that they're way better at translation than we ever could have imagined, and this is one of the foundational pillars for this transformation and death of computer science and the rebirth. So we're going to take a quick look at what this translation looks like. So I went into ChatGPT and I put in this prompt: imagine a language based on the stacking of rocks. Now translate the phrase "clinical research data drives the world forward" into this language. Draw the stacks of rocks at the end in ASCII art. Now if you think about the complexity of that task, I'm asking it to imagine a language, translate into that language, and then translate its translation into a picture. That is a profoundly complicated translation task, and it does just fine. Clinical research data, a solid foundation, multiple balanced stones representing structured data. Drives, a forward-leaning stack showing movement. The world, a large balanced formation representing stability and inclusiveness. Forward, a sharp peak symbolizing progress. And then the full phrase representation. The representation uses size, balance, and directional tilt of the stones to visually convey structured knowledge, motion, stability, and future progress. The computer science of the past could not do this. This translation task was way beyond anything we had, but it's also going to be the foundation of the computing of the future. And I want to sort of, how do we get from the stacking of rocks to that future? Well, the other foundation of the future of computing is conversation. And when you put conversation and translation together, some really magical things begin to happen. And so let's start taking a look at some examples of this. So I want to start off by introducing the future of computer science with some old sushi from my fridge. So I took this sushi out of my fridge, and I said, give me step-by-step plan to make this. And it comes back, and it gives me a complete list of ingredients like sushi rice and cream cheese and nori seaweed sheets. And then it gives me a complete list of steps. So what did it do? Well, we had a conversation and it translated, I want to make this, into the actions I need to take in order to make it. Now, where it gets really interesting and we start seeing a hint at AI agents is if I follow up and I go and take one of the actions that it told me to take. I go and I collect the ingredients, and I say, here are the ingredients that I got. And I purposely get them wrong. So rather than cream cheese, I get Cabernet Sauvignon cheddar cheese spread. Rather than sushi rice, I get yellow rice. And rather than nori sheets, I get seaweed snacks. And I say, here's what I bought. And I give it feedback on the action it asked me to take. And it says, that's great, idiot. You bought Cabernet Sauvignon and cheddar cheese spread instead of cream cheese. Soy sauce was right, but yellow rice instead of sushi rice, and roasted seaweed snacks instead of nori sheets. So it's not just that it can translate what I'm trying to do into a series of actions I take, but when I take one of those actions and I tell it what happened, it can adapt and decide and translate that into what the next action should be. And that's the foundation of agents, is this ability to go and translate human tasks and goals and ideas into actions to take. And then as those actions are taken, to translate the results of those actions into what the next step should be. So let's actually see this in practice. And we're going to look at it with the most commonly used AI agent on the planet, which is ChatGPT. Everybody thinks of it as just a large language model. It is not. It is an AI agent and has been for probably a year and a half or more. So this is the Vanderbilt Instructional and Enrollment Report. And it's like a 17-page PDF of these tables. So I'm going to upload it to ChatGPT. And I'm going to start off with a really simple task. Now this is the older interface to ChatGPT, the older UI, which I liked better for some reasons I'll show you in a minute. And I'm going to ask it to do something really simple. Please extract each page of this PDF as plain text. And it goes and it runs, and it rips the PDF apart and gives me links to download each individual page. Now, what did it do? It translated my goal, what I wanted to achieve, into action or into computation. So it took action and created a computation to achieve my goal. And then let's do something more complex. So I follow up in the conversation, and I say, turn it into Excel. And it goes and does a bunch of work, and then it gives me a link to an Excel file that I can download. So it's translated my goal into computation. How do I get this PDF into Excel? Now, if we think about the world today, this is one of the most significant tasks that we do with software. We go and take one software tool that doesn't quite do what we want, and then we try to figure out how do we get the data from that software tool to this other one that has the capability. And we have this mess of software tools where we're just doing that all the time. And this is beginning to hint at the ability to overcome that major problem. But it's going to overcome it in a way that's sort of unexpected. And that is, it's going to allow us to let the tools fall away and just start having conversations about our goals and what we're trying to achieve and translate it into computation. So rather than taking this out into Excel, all I have to do is just follow up in the conversation and say something like this: display 4 interesting visualizations of this data, and it'll come back and generate the visualizations. And so throughout this conversation, it's taking my goals and ideas and it's translating them into computation and taking action on my behalf. And then if I want to tell it to make them black and gold or filter them some way or whatever I want it to do, it will go and do it. But it's also doing things like interesting visualizations. It's translating that into computation. So the translation doesn't have to be super explicit like this computer science of the past where we say step by step how to do something. It can be high level. And that's a transformative thing. And then if I want to turn it into PowerPoint, I just follow up in the conversation. I upload my PowerPoint template, save each visualization as an image, insert each of these images as separate slides, and I tell it how to lay it out. And it goes and creates the PowerPoint presentation, and then I can download it and open it in PowerPoint. Now, all throughout this, I'm having a conversation, and my ideas, my goals, in human language are being translated into computation. And this is something that we could not do with the computer science of the past. We could not do this with the computing of the past. And because of that, when you wanted to do something, you had to go and hire a software engineer. You want the tool to do something different, hire a software engineer or a team of them probably, and wait weeks, months, years to realize it. Something absolutely incredible happened in this conversation that I want to circle back to. When I went and I said, go in, create these visualizations, and then save each one as PowerPoint, something amazing happened. And I always use the analogy of, imagine going into your back of your yard, and you pick up a shovel, and you're about to dig a hole, and right before you dig the hole, your shovel looks down, sees a rock, jumps out of your hands, builds itself a pickaxe, breaks up the rock, and then jumps back into your hands, and you continue digging. That is, your tool goes and builds itself a tool in order to overcome an obstacle that it foresees. And that's exactly what happened here. And the reason I like the older interface is it made it more obvious. They hide this more and more over time. Used to, this big gray box would pop up, and that was ChatGPT building itself a tool. And if you clicked on the gray box, it would show you the tool it built, and the tool it built was software. And so on demand, as I said, go and do this task, create this PowerPoint for me with these visualizations, it wrote the software to make it happen. We didn't have to go hire a team of software engineers. On demand, it wrote the software. It executed its own software. It used its own tool because it doesn't want to expose you to the messy details of the software. It checked if the answer was right or not. If it wasn't, it went and iterated on its own software because it adapted, just like we did with the sushi, and can go and fix problems with its code. And then finally, it handed back to me the PowerPoint presentation. And this capability is the ability to build tools. And I just am floored that we're not talking about this all the time. Like when chimpanzees use blades of grass to extract termites from termite mounds, we're freaking out. But we have software that can build software tools on its own in response to our goals and dreams and computation, and now it's real. So two things are happening in computing that are going to be the death of the computer science of old and the rebirth of computer science and software in a really interesting way. So one is it has totally unique computational capabilities. The ability to say, show me interesting visualizations, and then it can dream it up. The ability to go and look at that sushi and tell me how to make it, which, by the way, if that's all that generative AI was tell me an approximation of how to make anything on the planet from a photograph, that would have been the most world-changing innovation of our lifetimes, and yet it's one of sort of like an infinite number of things that it can do. But the second thing is that it creates a totally new interface to computing that is based on conversation and translation, where I go and I talk to it about what I'm trying to accomplish, and it figures out how to translate what I want to do into computation. I don't have to go and figure out 10 different tools that don't work together and learn each individual one and wait for them to update the UI and break everything I know. I just go have a conversation and it figures it out. Now, where this gets really exciting is in how it's going to change innovation in computing and software. I think the software industry as we know it is dead, it just hasn't realized it yet. And the software of the future is going to look very different. So I'm going to give you an example of this from my household. So my son is 11 now, and throughout his lifetime, he has been a collector. When he was little, he collected rocks and sticks and put them into the car because he wanted to bring them home. He got older and he collected Pokemon cards from the grocery store. Now he's older in middle school, so he's collecting shoes. And I looked at him one day and I was like, buddy, you know what you need? And he's like, what, Dad? And I was like, inventory management. And he's like, ChatGPT again. And so we built inventory management in a single prompt one morning. So here is inventory management. Whenever I give you a photo, create an inventory of what I gave you with approximate price. Keep the inventory up to date as I add pictures. And he looked at it, he knew immediately what to do with it. He went and took a picture of his Air Jordans, and it extracts the inventory item. Air Jordan basketball shoes, description, red colorway with iconic Jumpman logo, condition used with visible wear and slight, whatever. And then he goes and takes a picture of his old Vans, and it updates the inventory, and now we have Air Jordan basketball shoes. Now we have item Vans skate shoes with approximate price and everything. And in one prompt, we built an inventory management system that's one of the most advanced inventory management systems on the planet because it has a database of probably the largest database of products, ability to recognize products, ability to recognize condition, approximate price, all of this knowledge, all from photographs. And if I had to go and build this, it would be a team of software engineers and years to build something that's probably not even going to ever approach this level of sophistication that we can get in one prompt. But it also means that now, in his future, he gets to be the one who starts thinking, well, I have a problem, I want to solve it, I can go and prompt and start thinking about conversation to build new types of systems. Let's look at another example from Vanderbilt. This is the Vanderbilt Travel and Business Expense Policy. It's a 20-page PDF. If I wanted to build an automated system in the computer science of the past to audit receipts and determine if they are in compliance, it's going to be a team of software engineers. It is going to be years, and it is going to be extraordinarily difficult. So let's upload the policy to ChatGPT. And this was like a year and a half ago. It's better now. Please read the provided document so you can answer questions about it. And he goes and reads it. And then I upload a rental car receipt to it. And I say, please analyze the attached receipt and let me know if it complies. And it comes back, and this highlighted portion at the bottom, collision damage waiver. For domestic travel, the CDW should be declined as rental vehicles are fully insured through Vanderbilt's insurance portfolio. The receipt shows a charge for CDW, which may not comply if this is domestic travel. So I gave it the policy, and I said, now apply it to this receipt and audit it. And that creates a software system that can audit a receipt. To replicate that with software engineering and computer science of the past is teams of people. And we would not be able to build something probably as flexible, as good as that. But it means there's going to be a world where you can be on the fly, say, I need inventory management, and this is what I want it to look like so it works for me the way that I want it. Or you can say, these are our policies for our organization. We need to turn them into systems that can analyze processes or receipts or whatever it is, and it's going to be as simple as taking it and uploading it, prompting for it, having a conversation, and it's going to change how quickly we can innovate in software. So I think I've been fast enough that I get to do the demo in a second. So Amplify is our on-campus platform for generative AI, where we give you vendor-independent access to models from OpenAI, Anthropic, many others, and you can go and chat and have conversations to solve problems. We have about 6,000 users in Amplify. There's about 40 other institutions that are in some stages of deploying or using Amplify. We're doing about roughly 1 million prompts a month from the users, and every one of those prompts could be, writing a letter of recommendation, adapting your CV so it fits the FAR format that you're about to turn in, whatever it is. Now, our goal with Amplify is to help realize this world where end users are able to innovate with computation. We want people to be able to go and build these new software systems. And so what we're doing, and you're going to see over the next few months, is the ability to go and access all of the APIs through Amplify to be able to do things like access your calendar and email or Box and all the other systems on campus, so you have a place to go where you can talk about the problems that you need solved, and it has access to the things that you need. So I'm going to give you a demo of what is coming, and I'm going to start off by solving a problem that I have all the time that I hate, and it's the emails that look like this, and so I'll pick on Alan. So Alan sent me this email, and it says, hey, Jules, we need to get a meeting on the books, and it has a whole bunch of meeting times for me and dates, and now I'm like, man, I got to go look at my calendar and try to figure out how to respond to this. So I'm going to solve that problem. I'm going to build myself an AI agent in Amplify to solve it. So I'm going to go and create a new agent. I hate meeting scheduling. It's going to be my agent. Now, I cheated because I don't want to type all this out from scratch given time constraints, and I'll just read to you what I've got. So please help me respond to emails about availability requests. I am Jules White. When I give you an email, stop and think step by step, just a little bit of prompt engineering. Check my free time slots, determine which time slots fit the requested times, compose a draft email reply for me with my availability, and make sure and add a funny joke about Vanderbilt Commodores at the end of the email. And then I'm just going to go in and select a couple options here. But we have hundreds of APIs now integrated from like G Suite and Office 365 and different things. But I'm going to just grab 2 of them, get free time slots, and compose draft or email draft. Save this. And now I'm going to go back in. I'm going to take Alan's email, because I don't want to check my calendar anymore. Moment of truth in the demo. Paste it in. Of course, it's always awesome when it runs as slow as possible during the live demo. So it's going to go think about it for a minute, take a look at my email, and this agent's going to begin running in the background and checking my calendar, figuring out when I'm free, and then composing a draft reply for me that I can go and use. So it's looking at my calendar right now, looking for free time slots. And then in a second, it'll probably draft an email. So this is calling out to my Google Calendar at the moment. Composing an email draft for me. And once it decides to wrap up. So I proposed the email draft. It looked at my calendar, found out time slots that intersected with that I was available out in April. drafted the reply email, which if I go and, I don't know if it'll have shown up in my drafts yet, but let's see if we can get there. Where are my drafts? Yeah, so I think this is it. So I went and dropped it into my draft email now, checked my calendar, did everything. And what did I do to build this to solve my pain point? I went in and said, this is what I want you to do. Here's access to my calendar to check my free time slots. Here's access to my email to compose a draft. And so what we want to do is to be able to enable people to think about what would I like it to be able to do for me. Now, right now, I'm manually selecting here are the APIs. Part of what we're going to be releasing over the next few months is one where you go in and you talk about the challenges you're facing, and it knows what access to computing at Vanderbilt it has, and it automatically selects for you behind the scenes. But we are getting ready to begin releasing this over the next few months and give you access to some exciting things. I'm excited about this new world of software. I think it is a much more humane, approachable world of software. The software of the past is you use some software that somebody else designed based on what they thought was the right thing, and you don't get to adapt it to the way that you work or think or what you want to do, or if you want something new, it takes forever to get it. And I think of these as living software systems that are meant to adapt and work with us and fit our needs and fit our ways of working. And I think it's a really, really exciting time. If you would like to be part of the Vanderbilt AI meeting scheduling pilot, which will be going live in a few weeks, you can scan this and it'll take you to a Google form to sign up. The other thing I didn't show you, which I'll show you in 1 second before I wrap up, is that this is all accessible via email too. So I'll show you what that means in a minute. If you would like to be able to build your own AI agents using all the APIs and be part of that pilot, you can scan this one. And also you can email amplify@vanderbilt.edu if you would like to get access to any of these things. I'll give everybody a second on that as I see some pictures taken. And now I'll show you really quickly the other thing that you can do when you build an assistant. If I can find Alan's email, is we are also making it so that you can create assistants that are accessible and emailable. So I have that assistant. I can email it at jules.white+scheduling, and I can just forward it at emails. And in the background, I don't have to go into Amplify. I can just be in my email box, forward, schedule this, and it will go off and run in the background, check calendar, schedule, drop the draft in, and then I can come back and just go through my draft emails and say, yep, happy, I'll tweak this one, etc. Now, it could directly reply for you, but I tend to be a little bit conservative on, like, when it comes language out of my mouth, I'd prefer if I actually said it as well. So let me just wrap up here. Please take my classes. Thank you so much. So I think I've got like 3 minutes for questions if anybody has any questions. Yeah? If you are on the Medical Center Network, no. There have been many tickets submitted. Please keep submitting tickets asking Vanderbilt.ai not to be blocked on the Medical Center side. Nobody's succeeded so far, and I think there's been dozens of tickets submitted, supposedly. So maybe one day, but if you're in a Vanderbilt building, you can access it with a VUNet ID. What is SPI?
Private information. Secure private information.
Yeah, so you can use it for up to level 3 on Vanderbilt's campus. You can't use it for certain things like, export control data. I think we don't allow HIPAA data, but other stuff you can use. Any other questions? All right. Oh.
At some point, I received a message asking for cost centers to be submitted, but then it kind of went away. And then sometimes
it says that I've reached my quota, and then sometimes it doesn't. So I guess I'm just wondering, what are the next steps about cost management? Will I eventually have to like submit a cost center, or once I want to use it for like production or stuff like that?
So if it's chat through Amplify, right now it's covered, you don't have to pay anything. So if you go into the Amplify interface and you're chatting just manually, it's covered. If you want to create an API key, you can go and mint an API key just like you can with OpenAI. And the model is the same with like OpenAI, where if you create an API key, you pay per request. So when you create the API key, you have to put in a COA string or a cost center basically to charge the expenses or the costs that get accrued from that API key too. The reason for this is because you can run up much larger bills through the API than you can through manually chatting. There is cost accounting behind the scenes. We generally don't have any limits, but we do have some rate limits, kind of similar to Claude and the other ones. Like if you really go high, you may hit a rate limit. It's pretty high, if I remember correctly. But in general, the chat interface is free. The API keys you have to pay for.
Thank you.
Great. All right, thank you.
Totoro. All right, let's see if I can move. Yep, there we go. And full screen. Okay. Well, all right, we'll just have to deal with not full screen this time, but I think that's okay. Thank you for your patience. All right, well, hello everyone. I am Miranda Shirk. I am a senior data scientist, gotta stand by the mic. I'm a senior data scientist and a lecturer at Vanderbilt University Data Science Institute. I'm really happy to be here today to talk to you about what I think needs to be talked about more, honestly, is the energy cost of AI. What actually goes into powering these kinds of models, and what considerations do we need to make? So a little bit of my background before we get started is before I was at Vanderbilt, I was a data scientist at NOAA, the National Oceanic and Atmospheric Administration. Been in the news recently. Yes, thank you. So I'm very concerned with environmental impacts, but also environmental impacts as it relates to our economy and how it affects our research work. So I am a data scientist. I love AI. I love using it and innovating with it, but I also want to consider what is the cost of this AI and how can we make it more sustainable for us. So you maybe have seen just a ton of articles in the news. I mean, I was gathering sources on this presentation this week because more and more stuff were coming out. I mean, from places like Nature Journal, NPR, MIT, Scientific American, and these are coming out now. They've been coming out for a while, but it's really become this giant debate. We've got alarmists on one end that first came out and said, oh, every time you use ChatGPT, you're killing an ocean or something, right? And then we have other people who reacted to that and said, oh, it's not a big deal. You know, driving to work every day is worse than using ChatGPT a couple times. And I think the truth is somewhere in the middle, right? As it often is, we have a lot on either side of the debate. And I think obfuscating this with propaganda and with ads and with money is just going to create more confusion and less clarity for us all. And then this is still ongoing. So this was a recent article, Meta building a $10 billion AI data center in Louisiana. They're planning for that. They're clearing land for it. It's going to be 4 miles long data center to house computers, right? While Elon Musk is expanding his Tennessee AI facility. How many of you knew that Elon Musk had an AI facility in Tennessee? Okay, a couple. I'm surprised because I think most people don't know that. It's outside of Memphis. It's pretty incredible, and this is impacting us. Whether you are coming here as a visitor to Nashville or you live in our state, these things and these energy concerns impact all of us, no matter where we are. There is probably a data center near you that's using resources that you need, right? So, all right, so let's go over our agenda today. I want to lay out some expectations. When I went into this presentation and I said, oh, I'm going to make this presentation, I thought it would be a lot easier than it was. I thought the data would be there and I would have great sources to cite and we could all have a very educated discussion about the energy cost of AI. And then I found that it's a mess. So I am framing this as more of a discussion. Let's discuss it because we have to discuss it before we can learn from it, right? The data is all over the place. So here's our agenda for today. First, we're going to talk about the energy cost breakdown. What am I talking about? We say energy, what are we talking about? What is actually being affected here and where does it come from? We're also going to talk about the data. What data do we have? Where does it come from? What can we say about where it comes from? How reliable is it? Comparisons between models, between companies, like how can we use data from this company to compare from data for this other company? Are there independent third-party reviewers? We'll see. And then we'll find that the data is too confusing and we don't know what to do with it. And all of our questions and answers just bring up more questions. We'll all be mad, and then we'll just be left with more questions. So please come with me on this journey and let's all do it together, because what I really want to discuss after we're all pulling our hair out is, what does this mean, right? We're all here gathered because we're interested in AI. So I'm assuming that you're wanting some sort of solutions, you want to use it, maybe you're concerned about it, maybe you're not concerned about it. Let's talk about it, right? Let's talk about it and see what we can do about this and what we need to do to make sure that our endeavors can succeed in the future as well as right now. So I have a timer so that I keep myself honest and we can have time for questions and discussion. Like I said, welcome to comments, and I'll open it up at the end. So ready to get started. All right, so when we talk about the energy or resource cost of models, a lot of times we're saying energy and we mean a couple of different things, so I just wanted to lay that out. So first of all, I'll be talking about power consumption, so literally electricity most of the time, right? The actual use that's associated with the use and maintenance of the models. So when OpenAI is training ChatGPT, when the people at DeepSeek are training DeepSeek, right? What is the power consumption of that? How many watts are they pulling through? But also the data centers, because these models live somewhere, right? They are in a facility that's in our state, right? So what is the actual cost of maintaining these in their data centers? CO2 emissions, right? Sorry for this badly formatted CO2. I didn't notice that till now. I was a chemist, so it does bother me a little bit. But anyway, CO2, carbon dioxide emissions, right? We're concerned about that. It's something that we take into account, and a lot of institutions, such as Vanderbilt, have carbon commitments, right? We have these sustainability statements that we may or may not meet by 2030 or whatever those deadlines are. But if we're going to use this to fuel our research innovation, we need to know what its actual CO2 emissions are, what that impact is. So actual carbon output from model use, and again, also the data centers. And then water. This one I find that most people are not considering. These models use a startling amount of water, on the order of literal tons, millions of liters of water is consumed by these models. They're required for both manufacturing the parts needed to construct GPUs, computers, and a lot of water is also required for maintenance. Water is used to largely cool computers. So if you have ever built a PC, I know we had some gamers in the room the other day, if you've built your PC, you know that you need a cooling system inside of that PC, right? And sometimes that's some sort of liquid or there's different methods and stuff, right? Data centers need a huge amount of water to cool their computers because they generate so much heat when they are running. If you've ever run your laptop for a long time and then your thighs got really hot, right? Where you had your laptop. Sorry, that was weird. But you had here, when you're running your computer for a long time and then your laptop gets too hot, right? That's what we have to do, right? The OpenAI's computers do the same thing. They use water to cool it down, which I don't think enough people talk about. Okay. So we talked about these resources, right? Here's all the resources, here's the energy that we're consuming. But what actually contributes to that? I've talked a little bit about it. So when you consider the cost of using an AI model, I'm not talking about money today really, but it relates to money. You're considering many factors, right? You're considering the software. This is what most of us will be interacting with, right? If you're interacting with ChatGPT, Perplexity is another one that has recently become pretty useful. Anything that is something that you're interacting with, a user interface of some sort, that's our software. That has its own impacts on how the software is built. How is your software running? How is ChatGPT running? Is it efficient? I don't know. As well as the inference, right? So that's training and inference. So you're training a model. How are you training it? Are you using efficient methods to train it? We have a bunch of different methods to train, right? We have parameter efficient fine tuning. We have LoRa. We have Dora. We have rope. All of these things, right? Those have different energy costs. Inference has different energy costs when they're just using the model. So inference here, I'm referring to just typing into ChatGPT or typing into your model, getting an answer back. That's inference. We also have to consider the hardware because these models didn't just come out of nowhere. There's the models is a software component, right? But running the model is a hardware component. We have GPUs. Often you hear about NVIDIA GPUs, right? Those had to be manufactured. There's a high demand for the chips that go into GPUs. Maybe you have heard about them in supply chain news, for instance. They had to be manufactured. They also have to be maintained and then eventually replaced, right? Like, are we using the same GPUs that we used 5 years ago? No, we're not. That means we're making new GPUs about every year, right? I mean, NVIDIA comes out with a new flagship GPU about every year. And everyone wants the latest, greatest one, right? So what does that actually mean when we say, oh, well, it costs this much to manufacture this GPU? But that's not just once, we're doing it every single year, multiple times a year. And then finally, another thing that gets overlooked here is location. Where is your cloud cluster located? Are you running AWS out of the Netherlands, where it is largely renewable resource run, or are you running it out of California, where we rely on fossil fuels, right? Where is that energy coming from? That has different impacts. You can choose the region that you use on AWS, on cloud computing, stuff like that, mostly. Sometimes there's some restrictions, right? But you actually can sometimes see that location when you're running a computer that's not located where you are. And then resource availability. As I said, they use energy, they use water, they use oil. Where are these resources coming from? Where are they being pulled from? When we have an AI data center in Tennessee, how much resources do we have to be able to contribute to that? For instance, a lot of data centers are located in Arizona and in California, where it is very prone to drought. I mean, we've seen that. We've seen wildfires, we've seen drought. We've seen water loss. And if a data center is pulling in millions of liters of water, what does that mean for what the community can use? These are all shared resources, right? So let's look at that as well. So these are the factors that I have outlined that I believe contribute toward this energy cost. You may think of more, but this is, I think, more of a holistic picture than just saying, oh, well, how much electricity do I use when I ask ChatGPT to write a 100-word email for me, right? Okay, and a little bit about, just a little more detail about what uses this energy and approximately how much is it, just based on a verbal overview, right? So training, this is teaching the model. When we're talking about training, we're talking about teaching the model. This includes fine-tuning as well, a little bit. Training is the one task that uses the most power as far as we're concerned, usually. I'm not really considering manufacturing and maintenance here. I'm talking about software. Training is the most power intensive. This is millions of hours of compute time, right? So how they calculate this is they usually have many computers running in parallel for many, many hours, and then they count how many computers ran in parallel, how many hours did they run, multiply those two together, and that's called compute time, or GPU hours, right? And a lot of models are on like the tens of millions of GPU hours. That's as if you ran your computer for 10 million hours. Which would take you years. So if you just did that with one computer. So like, what does that mean? That definitely uses energy, but how much, I don't know. Well, I guess we'll figure it out. Inference as well, that's actually using the model. Usually this is when people are saying, oh, it's harmless. It's not doing anything. That's such a small amount compared to training. So there's kind of this debate of, do we worry about inference or do we worry about training, right? Maintenance, like I said, upkeep and storage of the models, they have to live somewhere in a warehouse that is prone to, maybe weather disasters or water shortages or electricity shortages, power outages, stuff like that. Actual storing these machines somewhere safe. And like I said, manufacturing, actually building the hardware that these models need to run on. Okay, so let's get into it then. I'm a data scientist, I like the data. Let's look at it. Okay, so first let's look at some of the data sources, because this is where it gets a little messy. We have data self-reported from AI companies themselves sometimes. What they choose to tell us, right? So OpenAI, for instance, we have some information about the energy cost of training GPT-3. Almost nothing on GPT-4. And they get to choose that, right? They get to choose how much information they tell us. And you can also imagine how far we should take that, right? Like how much, if they tell me that their model took this many watts of energy, of electricity, right? Am I going to take that and say, is it that, or is it more, or is it less? It's probably not less. Let's be honest, right? Probably not less. But so we have self-reported data from AI companies. Do what you will with that. Meta, OpenAI, DeepSeek, and so on. We have a few publications analyzing these models. So Hugging Face, for instance, a team at Hugging Face, which is where a lot of models are hosted, this is where a lot of open source models are, they have put out a paper comparing different models by parameter size and then how much energy and CO2 they consume or produce based on the model parameter size. So we do have some third-party reviewers, but it's basically it. There's this one paper from Hugging Face, and there's a couple other papers from people running their own experiments, right? You can imagine, are these experiments very controlled? As much as they can be, right? But new models are coming out every day. We can't possibly keep up with all of the models. So for instance, I haven't seen any papers come out about DeepSeek, about independent reviewers of DeepSeek and how much energy that costs to run. Another consideration with third-party reviewers is that they may not have the resources to run and track how much energy these models consume, because I don't know about you, but I can't run a 120 billion parameter model on my laptop, right? And then analyze how much I needed to charge my laptop to make that happen, right? So, and then I wanted to bring this up because this is a quick fact that I often see cited in almost everything that I've looked at, is this idea of comparing it to Google. Because before we had ChatGPT, we had Google, and this is what we used. And Google had some metrics that came out, I think maybe 5 years ago, don't quote me on that, but several years ago on how much wattage it took to run one Google query. And it came out to about 0.3 watt hours per query. A watt hour is just basically how many watts in 1 hour, right? It's a time and electricity duration. I'm not an electrician. But anyway, Google, what we see thrown around is that Google is 0.3 watt hours, and then ChatGPT is about 10 times that. So ChatGPT is about 3 watt hours per query. there's some things to say about this fact, and I'm highlighting it because I see it quoted a lot. That was several years ago for Google. Google now employs AI for one, right? Google now employs AI, and it has a little AI summary that's kind of annoying, honestly, and like tries to answer your questions for you and tell you to eat rocks. But then that was my favorite thing ever. And then we have, ChatGPT, and it's like, oh, we're consuming this much. I don't think we should be making comparisons like that. They're useful to look at. But we're using ChatGPT in a different way that we're using Google for. Some of those things overlap, right? But I don't think we need to say, oh, it's equal to this much driving of my car. Those are all separate things, and you're implying that one of them needs to go away, right? I don't think any of this is going away. So you can keep that in mind, but you'll see that pretty often. So just to kind of get through this, hopefully you can see this graph here. This is the one by Hugging Face that I wanted to outline. A little small, I suppose. But basically, this is saying that on the y-axis here, we have model emissions, which is grams of CO2. And then on the x-axis, we have model size or number of parameters. One thing I want you to notice is that the x-axis only goes to 10 billion. And ChatGPT, like the state-of-the-art models that we're using, ChatGPT and Llama 3 and all of that are like 70 billion to 100 billion parameters, right? So they weren't even able to assess those just because of how much compute power it took. Like I said, this is a small team of scientists. But you can see that relationship, right? As the number of parameters go up, you're largely you're consuming more or producing more carbon dioxide. And then they also have this kind of color-coded to category of the model. So is this an image, a text-to-image model? Those seem to produce way more CO2 and use much more energy as opposed to text-to-text, for instance. So this is just an interesting analysis. I don't want to focus on it too long. Here's probably what you're interested in. And take these numbers with a grain of salt. Like I said, the data is absolutely all over the place. So let's talk about it real quick, what I have here. All right, let's talk about it a little bit. So I scoured all of the sources, right? I looked at OpenAI, Meta, and DeepSeek's publications, talking about how much energy it took to consume them. Some of them, like I said, OpenAI has some statistics out for GPT-3, more for GPT-3 than GPT-4. So I have tried to outline when I'm talking about 3 or 4 because you don't have information for the other one. So for instance, training GPT-3 took 1 million kilowatt hours. So when I talked about Google before, that was watt hours. Now we are kilo, right? Kilometers. So now we are at kilowatt hours. So training GPT took 1 million kilowatt hours of a computer to run, right? And then 5.4 million liters of water just to train, right? That's basically cooling the computers while you're training it. Compared to Meta, Llama 3, which is open source, this was a little harder. Meta and DeepSeek, it was a little harder, and you can see I've extrapolated some stuff here. Please correct me if you know more about this, or I just have my estimates here. But according to Meta, training Llama 3, 70 billion, took 30 million GPU hours. They have also told us which GPUs they used. So I was able to look up the specs of the GPU and then how many GPU hours it took, and I approximated that to be 21 million kilowatt hours. There's my timer, so I got to go faster. But I don't know if that's correct, right? That was just me trying to do some calculations. Like I said, I'm a data scientist, but not this kind of data scientist. And so I don't know. DeepSeek was 2.78 million GPU hours. Notice that is a 10 times reduction in GPU hours, which is what DeepSeek got very famous for. Everyone was amazed by it, right? And then about 800,000 kilowatt hours is kind of what I calculated based on the hardware that they were using. That may not be pay attention to the GPU hours in this case and not so much on the kilowatt hours because that just comes from me. And then as far as if we're looking at inference, we've got 0.14 kilowatt hours, so that's the 10-fold increase from Google, inferencing on Google versus inferencing on GPT-4 in this case. And then 16.9 milliliters of water. That's a US average. We'll talk about what that means in a second. And then we've got inference power for some of these other models as well. This is what's out there from the models and then from articles that are analyzing these models, right? It's messy, okay? That's not the whole story, though, because because all of this, like I said, depends on the data center location. This study came out that found that the water usage depends on where ChatGPT is running your query. So if ChatGPT is running your query in Washington, you're using 1.5 liters of water for one query and I think it's based on generating a 100-word email. That's a pretty short amount of text, to be honest, compared to what else we're generating, versus something like Texas, which uses 235 milliliters of water. That's a huge difference. Does OpenAI tell us where they're running their queries? Not that I can find. If they told you, let me know. I could not get any information on which data center I'm accessing when I'm accessing GPT, right? So this is just to show you that all these data centers have different usage demands. This really impacts like the energy cost of it, and it just adds to, so when I say the US average, this is taking all of the data centers and averaging them. And then data center usage demands. Like I said, there's a debate between is inference the problem or is training the problem? I don't know, it's hard to say. Training uses a ton of power, but as you'll see in some of these statistics, AWS says that inference accounts for 80 to 90% of their cloud compute demand. Just inference is about 80 to 90% of that. So you have to do some comparisons there. They use this much compute on training, but then they're saying that 80 to 90% of their demand is actually for inference and not training. Meta similarly says that inference is 33%, just inference, just asking questions to an AI is 33% of their carbon emissions, whereas data management is the remaining 67%. And then Google has said that inference is 60% of its energy use, so I believe they're talking about electricity here. Inference is 60% of that energy use versus training is 40%. So these, you can think what you want about them, like I said. But this seems to imply that although inference has a very low single cost compared to training, it seems to be so in demand that we are spending much more energy, much more money on inferencing than we are on training. So what do we need to focus on, right? I don't know, but it seems like inference is important here. What else you'll notice here is that, Miranda, you said cloud compute demand, you said carbon emissions, you said energy use. Those are not all the same metrics. No, they're not. This is the information that they're putting out, right? There's no standard, we're going to put out this report. This is, we felt obligated to do an energy report because people asked us for it, and here you go, right? Here's some information. So we don't know here. And then let's look at some of these data centers like I mentioned before. And I'll try to go quick so that we can discuss, but also feel free to find me later. So for instance, I pulled out two stories that caught my attention. One is that OpenAI, Microsoft, had a data center in Des Moines, Iowa, or outside of it, and it used 6% of the district's water just in July 2022. Just in July. What do you think they were doing? Right, they were training GPT. They used 6% just in July. That's wild. If something in Nashville used 6% of our water in 1 month, I would be very concerned, right? Obviously we want to see how useful that is, but that would be alarming. And then this other one, a Google data center in the Dalles, Oregon, this is outside of Portland, Oregon, used 25% of all water in this town. It was reported to find, and actually the townspeople had to fight to learn this. Google was not reporting how much public water it was using, and then they had to have a whole court battle over this becoming public record. So now it's public record how much water Google is using in the Dalles, Oregon, not necessarily in other places, but they had to fight to find out that a quarter of their water was going to a data center, right? This is, whether you agree with it or not, I think we should be able to consent to something like this. We're sharing this water, and especially in a dry place over on the west, we need to know about stuff like this. We need to prepare for those kinds of risks, right? Okay, and then if the environment doesn't concern you, supply chain should, right? In a survey by WTW, they found that of all of these global semiconductor companies, they surveyed some of them and found that 73% of them cited natural resources posing the greatest risk to their supply chain. So these are chip producers. So what we need to make the GPUs, to train the GPUs, and then to make GPT, for instance, we need this. And they are saying, 73% of them are saying that natural resources are the greatest risk to their supply chain. So that means that if someone uses too much water, if someone uses too much energy, if we run out of whatever, then we have no chips, and then all of this is disrupted, right? It's just going to go down the line here. That is very concerning, right? We need to have plans in place for this so that our economy doesn't get disastrously uprooted. Okay, so that was a fast track through all of the messy information that's out there, right? I hope you feel the frustration that I feel on the data that's out there and then the murkiness of it. So let's talk about some implications. There's a lot of tools that have come out, for instance, on tracking your own model's energy cost. I think this is super cool. I want there to be more of this. For instance, there's a Python library to track energy and resource use during model training. They actually published this as a new framework for publishing models. They said, hey, when you publish a model, like GPT, for instance, and when you publish a model and you say, hey, it does this, it has this accuracy, it does this, it uses this much carbon and this much electricity and this much water. I think that would be fabulous for us to report on that so we have the knowledge. So they published that as a new framework for publishing the models. It's actually pretty cool. It takes into account where your data center is located and then some other factors such as that. And it's just a plug and play. You add a couple lines of code to your already existing code. There are energy calculators for data centers. So if you happen to know where your data center is located, you can go to 1billiontrees.org and find out what the energy cost is at that data center. And then there's also a machine learning energy leaderboard that is being updated with new models. It has Gemma, for instance, on there. It doesn't have DeepSeek yet, but people are starting to pay attention to this and to bring it to everyone else's attention. And then Microsoft, so at Vanderbilt we have Microsoft Azure, right? And Microsoft has their own emissions dashboard. What I will say about this is great, and I'm glad that they have that, but it is produced by Microsoft for using Microsoft Cloud products. So they're incentivized to make you feel good about what you're doing, right? I'm not saying that they're lying. I'm saying that they are incentivized. Like, there's no third party reviewing this, right? So look at this, but take it with a grain of salt. So that's some of the stuff we have. What do we need? We need transparency in model training and inference, right? We deserve to know the actual cost of using a model. If this is using our community's water, our community's electricity, our Earth's resources, we deserve to know that actual cost because we're the ones that are affected by it. We also need external evaluations. This is not just a problem in AI, right? It's a problem in a lot of things. We need third-party reviewers looking at this and saying, we reviewed this data, it is correct, or we came up with this alternate report, right? I think we also need higher societal awareness of just technology resources and their costs. Before talking about this with people, I had never once heard anyone ask, how much energy does it take to run a Google query? Never. I've never heard anyone ask that. And I think that's really cool and a turning point in how we're thinking about this. Running a Zoom call, responding to an email. All your emails are hosted on a computer somewhere, right? All of this that we do every day, having a phone call, watching Netflix, has an impact. It's housed in a computer somewhere that's using water and using electricity, and we just don't think about it, right? Because it's just on our phones. So I think a higher societal awareness of just that our actions have these real-world impacts, even though to us they just seem all digital. And then finally, we need funding for the sciences, right? Like, the people that are reviewing this are the scientists that are, frankly, in trouble. And if we want to excel in AI research and innovation, and we want to have a top spot in the world as this hub for AI and for science, we need to support the scientists that are doing this work, or else they cannot continue it. So, all right, I went a little bit over time, but I think we can answer a few questions and then get coffee. Feel free to email me. Feel free to talk to me about this afterwards. Like I said, you may not agree with me. It's a lot of information. I'd love to discuss it. So anyone questions? Yes?
Hi, Miranda. Great job, first of all. We talked a little bit about this yesterday. So we're both in risk functions. You're thinking about a risk. We're thinking about the risk. And one more thing that I think it's more of a comment for your last slide is we're actually asking for governance, right? The governance. We're not trying to scare you. It is scary, but we're not trying to scare you. Just ask you to consider, think about it, and maybe we can't get humankind to agree saying, hey, we need the governance as a humankind, but maybe not your country, maybe not higher education industry, maybe not even Vanderbilt, but in your lab, personal responsibility. So that's some of the things that we're asking. So just great job.
Yeah, thank you. I really appreciate that. Yeah, I think it's amazing when you have programmers asking for someone to double check them and to govern them, right? Like, we all joke about IT and, like, oh, I have to do this IT admin. So we're asking for it, right? We're asking for it. I think that's amazing. Go ahead.
I'm just curious, what do you recommend? How do we proceed forward? The data's there, or maybe the data's not there. So I guess the first thing is, right, getting the data, but what steps can we take to encourage the transparency that it sounds like you're asking for?
Yeah, I mean, if anyone needs a PhD project, come find me, because I think this could take it up, right, if we have any just extra grad students lying around. I mean, obviously, we always say, like, contact your policy people, right? Get involved in stuff like that. But also, like, when we have stuff like this happening, dashboards, leaderboards, when we have Python libraries that are tracking out, like, just use those, get the word out. I mean, I don't have a good answer for, like, how we solve all those things, except just we need this sort of transparency. I think more talks help, more discussions with other people help, and just getting this on conferences, right? I haven't seen stuff like this in a lot of conferences where we're talking about this kind of implication. Right, go ahead.
Yeah, thanks, Miranda. So the question I have is, so you just talked about in general about energy consumption using AI and stuff like that. So I have two questions specifically. The first question is that what is that Vanderbilt taking the steps in terms of sustainability? The second question I have you considered looking into IBM tool, which is called NVZ tool? I'm going to get in touch with you. They'll talk about ESG suite and things like that. So these are the two questions. And also, you did mention about some of the metrics you're capturing using the cloud solutions which you have. So I just want to hear your thought about the sustainability model which you're looking up in the Vanderbilt.
Yeah. What was that tool you asked if I was using?
IBM NVZ.
NVZ. Can you explain?
ENVIZI.
Okay. So, I'm sorry, I'm not familiar.
It's an ESG tool.
Okay.
So, yeah.
Okay, yeah. So the first question was, what is Vanderbilt doing about this? I don't know, right? Vanderbilt has I believe, a sustainability policy. A lot of universities do. I don't think it takes into account this, right? We have a lot of AI tools now, and we're building them, but I don't think we're taking into account like data centers and all of that and the use in that. I think we should. I think we should bring this to Vanderbilt's attention and talk about it. So Vanderbilt does have sustainability goals. I don't think it currently includes this. I think that it should. As far as other tools, I have not widely explored a lot of different tools. Like I said, at Vanderbilt, we typically have Microsoft Azure. We have our own Acre data center, which is great. I think it would be amazing if we did some sort of experiment on it, right? Like, we have Acre, we have all these collaborators and people already training models. If you are training a model and you want to find out how much energy it takes to train your model, come find me. I'll insert this code, right, and we'll figure it out. And we'll figure it out with Acre. We've got great people over there, right? So I think that would be amazing, an amazing next step also to help continue work like this and get more transparency on stuff like this, is to do it ourselves. Yeah, and I'm sure there's other tools out there. I'd love to hear about other tools that, that can help bring about this type of work. Mm-hmm.
So partnerships is what I'm really thinking of to solve your data need. There are industry partnerships that are out there, and there are other nonprofits like Electri. They do a lot of the electrical data for the industry. They're a resource. NECA, National Electrical Contractors Association. Those are places that I would imagine, as you explore your research, would probably help you out a lot, because they're going to be partners who are already doing this kind of work.
That's amazing. I may talk to you afterwards to make sure that I write that down. That's perfect. So I'm going to go ahead and cut us off so that you can all get coffee and snacks and go on to your next talk. But thank you so much for joining me today. And please grab me and talk about this further. So great to see you all. Thank you.
Okay. Hi, everyone. I'm Abby Petulante. I am a postdoc at Vanderbilt's Data Science Institute. And today I'm going to be talking to you all about a particular class of LLM that people kind of call a distinct class of LLM, despite there being a wide variety of architectures in this class, and that is small models. Because small models really do have some of their own special considerations, and we think about them in particular ways, sort of thanks to their size. And they really are able to do some incredible things despite being so tiny. So I think this talk is very well timed after Miranda's, where we just heard about sort of what at times seems like the absolutely catastrophic impact of large models. It is not necessarily the case that there is always a small model for your solution, but there may be a small model for your solution, and I think that's important to consider. So I found this plot online. This was made by Epoch AI, and it covers basically the rise of size in models as far back as something that you could consider an AI model, so all the way back to the 1950s. And in general, it has been the trend and also sort of the assumption that the larger you make a model, simply the better it will be. And this assumption was kind of true for a long time. Like, people didn't get it out of nowhere, particularly in this early deep learning era, in the big rise of CNNs. It sort of was the case that straightforwardly, the larger you made your convolutional neural network, the better you were going to perform on this classic image data set. And so for a really long time, that sort of was all people were trying to do, was just make their models bigger. Bigger models were always, always better. But I want to zoom in on really just the last recent timeline, the last 5 years basically, and only talk about LLMs, because there has been an interesting trend there where, although the biggest models do continue to get bigger, and up there in the top, those are really estimates. Like, a lot of these big models, they don't tell us how big they are. They want to keep that secret. They want to keep it secret because it's proprietary, but I also think knowing the total number of parameters in a model is a weird metric to not want anyone to know. But even though large models do continue to get bigger, you'll notice this trend of small models that are existing to the lower right of this graph, right? So as we've kind of increased in time, the disparity in size between our models has greatly increased. And that's because small models technologies and the ability to make our small models better have gotten better, and that means that little models can compete in a lot of ways with bigger models, where before we didn't have the understanding of architecture or the ability to make small models as good. I want to just be clear about how small models have to do with compute needs. So very straightforwardly, big models need more compute, quite obviously. And typically these big models that you're interacting with, like in a chat on a website, these require data centers with huge numbers of GPUs, and this is all just for inferencing. But as we get into this range of smaller models, inferencing becomes possible on a laptop with just one good GPU, and for the smallest models, like even on a phone sometimes. There's really incredible power in having a small model in terms of being able to run it on your own on not that much compute. Of course, compute needs for training, and this is even training largely kind of in a sense of, even if you're talking about like fine tuning in a parameter efficient type of way, is much more costly. You're probably not fine tuning on a phone, but maybe even on the tiniest models, you could do some fine tuning on CPU. You're probably still needing GPUs though to train these things, because when we say small, we of course don't mean like really, really small. We just mean small for an LLM. I just want to define small also, because I think that a lot of people have their own definition of small, like small models. Sometimes people call like, you know, like a Llama 70B a small model because it's smaller than like a GPT-4. And I think that's really not the case. I think when we talk about small, really we're probably in the region of 10 billion parameters or fewer. And then people also will refer to these really small models as tiny. Tiny models, let's say they're 1 billion or fewer. Tiny models weren't really a thing. Like, you can see actually that it's not until recently, the Qwen 2.5, the Llama 3.2 examples there, that we really had models that fell into the tiny class. Previously, like, tiny models were, you know, these earlier models that nobody uses anymore because they don't perform very well. So we're finally just kind of getting into this realm of talking about these truly, truly tiny models. And for the purposes of this talk, small is going to mean both small and tiny. Everything in that, you know, roughly under 10 billion parameters range, things that you could run, at least inference, maybe even train on a local device, maybe inference on a phone. We're talking about that kind of scope of compute. One more thing that I want to point out about small models on this graph is that if instead we color these dots by whether the models are open source or closed source, it becomes clear that a lot of models that are small are open source. And so this is also very fortunate for when you're talking about you doing personalized training or inferencing on a model, that it is possible to do so on these small models. So the push to smaller models isn't just small models for the sake of it, it's small models for you to use. It's small models for the people to be able to grab an LLM and do with it what they want, right? Both because it has compute needs that are reasonable to an everyday person, but also because it's made open source and publicly available to you. Okay, so everything that I've just talked about can basically be summarized in this chart. And I think this chart is maybe sort of obvious. Like, if I told you that small models use less compute and can run faster and they're more energy efficient, like all of those things I think very obviously follow. So of course small models have the benefit of being more computationally efficient. The question maybe then that we really have is, are they performant? I mean, if you can just make a model smaller so that you can run it, and then it doesn't give you any of the responses that you need, then what is really the point of it? So let's talk about the performance of these models and sort of things that we've done to actually make sure that these models are quite performant and quite useful. So we're going to take a little bit of an aside before we sort of formally talk about the performance to motivate the technology that makes small models so great. Because if there's really anything that I want you to take away from this, it's that small models are not merely small, large models. There are fundamental architecture differences, fundamental strategies that are implemented that make it so that our small models can match, sometimes exceed, the performance of larger models. And so there's a number of innovations that went into this. I made this little comic. You can maybe think about a large model as a big clunky stack of paper, and yes, there is so much information in there, and so it can sort of take on this clunky shape, whereas this small model is this beautiful, elegantly crafted little paper crane. Like, every single fold in it is meaningful. And with small models, there's really that intense amount of thought put into their architectures. So let's cover some of the most common techniques in reducing model size that you will find in modern small models. The first is knowledge distillation. The basic idea here is that if you have a large model that already does what you want, just train a small model to mimic the large model's behavior. So you have a teacher and a student, and the student is learning directly from the teacher's knowledge, not from the same data set that the teacher learned from, but from the teacher directly. Newton did not say this quote about AI, but I think it's very fitting. Small models are standing on the shoulders of giants of larger models. So you have a larger model and you take advantage of the fact that that large model exists to help your small model. In practice, what this looks like is that you start with some trained large model. You already have that. You assume you already have that. And then you create a data set from that large model's responses, and inside of that data set will now already be contained the way that the large model likes to respond to things. And then you simply use that data set to train your smaller model. And so the smaller model is learning to mimic the behavior of the large model. It's not learning the same task as the large model. The large model distilled the task already for it, and it simply learns from the distilled task. And then you can confirm, of course, that the small model is closely matching the performance of the larger model and ensure that you're doing all of this well. An example in focus of this that is very pertinent is the DeepSeek R1 distills. So DeepSeek R1 is this huge reasoning model, but when they released that, they also released a whole bunch of these smaller models that they trained on a data set that they built out of R1. And so they did knowledge distillation on a number of small open source models, and they found that these models performed great. I mean, they hand-selected these benchmarks to be things that reasoning models would be good at, and then compared them to big models that aren't reasoning models, because of course you advertise your product that way. But still, they found amazing results and were able to teach little models reasoning through this distillation process, through this sort of indirect learning process. Another sort of huge technique that's done to make models smaller is to approach efficient architectures and do smarter attention. This is the literal architecture of the model, the weights and parameters of the model. We're trying to approach that in a way that shrinks them basically the best that we can. And so attention in particular is a pretty costly operation, but it's fundamental, it's core to transformer models. And so for instance, where in standard attention, all parameters of a model have to connect to every other parameter in that attention calculation, and that is expensive because that's a lot of cross-compute you're doing. In efficient attention, you perhaps just chop some of those off. You try to identify which of those connections actually don't need to know about each other, and then you don't calculate them, because that's compute that's costing you, and you don't want to do compute that you don't need, is really the takeaway of what small models are trying to do. They never want to do compute they don't have to do. An example and focus of this is Mistral 7 billion. So this uses grouped query attention as a particular flavor of this way of doing attention. And that particular innovation meant that Mistral at 7 billion parameters beat Llama 2, the 13 billion parameter version, so a 2 times the size model. Mistral beat on every single benchmark that they tested. So simply by applying faster, scrappier attention, they were able to get the exact same performance way faster, half the model size. Okay, and then the final sort of overarching strategy that I want to talk to you about is parameter reduction techniques. So the idea here is, again, to not do compute that you don't need to do, but by editing at the parameter level. So models are made up, when we say 10B, 1B, that's billions of numbers that define this thing. And the idea behind parameter reduction is, what if we just chop off the ends of some of those numbers so we round them and their precision is less, and that means the calculation is less costly? Or what if we just chop off some of those parameters entirely? We don't need to worry about going down that path through the model's internal states because we know it's not important. We just won't do it. So again, looking for these ways that you can just chop off compute that actually wasn't super important to you. My little comic is, if you take off the weights, they're easier to lift. And so that's sort of what the model's trying to do. It's trying to drop some of its weights, and then the whole thing is easier to lift. So for instance, and I mean, this is an extremely simplified version of maybe a path you'd take through an LLM, but they're made up of series of numbers. Maybe you have to go through a bunch of these series of numbers to get at your results. When you quantize, you maybe just chop off the ends of those numbers. You say, who cares about 5.2? It's just 5. It's basically the same thing. Or you prune. You say, I don't even want to look at that path and where it leads. I know it's not as important. I can get rid of it. It's not doing anything. Okay, so an example and focus for this is Llama 2. Llama 2 released different versions. There was Llama 2 70 billion that was sort of at its full, this is quantization, so at its full size of all the numbers of the model, and then they quantized it down to 4-bit. So 4-bit, they chopped off the ends of all the numbers, and they said, let's lower the precision way down. 4 times less memory needed when you chop off the ends of all your numbers, because the longer your number, the more digits you go out to, the more space it takes up in memory when you store it. And despite the 4 times reduction in memory by chopping off the ends of all their numbers, they found nearly identical performance. So it turns out it didn't matter for Llama 2 70 billion that you kept the 0.52 whatever. You could just get rid of that, and you would get the same thing out in the end. Okay, so again, the takeaways that I really want you to get from this part is that the small models being performant is like there's so much that they're doing to make small models performant and to make small models small while not sacrificing performance. So there's a lot going on under the hood when you are given a small model that has been trained to do super well. And that, of course, shrinking a large model would naturally lead to degraded performance, but if instead you take a small model and you've designed it really intelligently, you don't necessarily get that degradation in performance. And these are some of the fundamental innovations that we just talked about. I do want to be careful about time, so I'm going to try to go a little faster. Okay, so if you have ever looked at the Hugging Face model card, the press release, the paper for a small model, the Wikipedia page, you will probably find a line that looks something like this, which is, this new model, wow, brand new, outperforms some giant model, and it's super surprising. It's supposed to be that it outperforms it, and you're supposed to be like, whoa, so cool. Is this true? And the answer is that it depends. I'm not saying it's not true, but I think that the thing about when smaller is better is that small models are really task-specific learners, and large models are general-purpose learners. So, I mean, they sort of serve different functions. I mean, they literally do the same thing. They're LLMs, right? But I think it's important to sort of thinking about them as serving different functions. Whereas maybe a general-purpose learner, large model, is like the Swiss Army knife that has like 1 trillion little functions in it already built into the thing. A small model is like, you have to intentionally pick up which exact tool you want. They are like individualized little tools that know a specific task really well. And so you just have to be kind of careful about which one you pick to approach your problem. This is kind of the way that I like to think about it, is like, knowledge is water, and I'm trying to dump it into 2 different containers. And a large model is like an ocean. You can dump and dump and dump the knowledge, and it'll be able to take it all in. It'll fit it all into its internal states, no problem. Versus a small model is maybe more like a little cup, and the more knowledge you pour in, maybe some of it starts to spill over. It can only handle so much in it. And so you have to be not necessarily careful about the knowledge you put in, but more that the knowledge that it's able to hold is more of a concise thing, right? It doesn't take this like infinite knowledge the way that a large model kind of seems to. And I'm going to extend the analogy a little bit more and say that if the red water that you're adding is a task that you're trying to learn, this is also an advantage of small models, right? It's not just that they can hold a task, it's that they hold a task really well. So if you have a small model and you add to it some task you want it to do, it's able to pick up. The red water you add will color the whole pool to that task. Versus if you try to add in a task into a large model, it's maybe a little bit harder for it to adopt it, right? Anything you add is more easily lost in the ocean. And so small models also pick up on their tasks much better and can more easily be fine-tuned to specific behaviors. Okay, so I basically already said this, but I do want to just put it up formally into a slide, which is that large models are really great at general purpose, small models absorb new information well. One thing that I do want to highlight is just the final bullet point on this slide about catastrophic forgetting, because that is kind of the one real risk to small models, sort of like dumping in water until the cup spills over. You need to make sure that what's spilling over is not stuff that you needed. It's really easy with a small model to dump knowledge and force out other knowledge. And so there's a trade-off with a small model when you're packing in any task and any new knowledge, that you don't lose something that was fundamental, some behavior that you wanted and needed in the small model. You have to balance what gets pushed out. And that's the concept of catastrophic forgetting. Okay. And then one quick note that I want to make just really quickly about this is that it also has implications for prompting sometimes. So I'm not saying prompting is not important for a smaller model, but for a large model, sometimes you will get extreme response to prompting. Like for a lot of large models, if you had a good enough prompt, you could basically get what you wanted. For small models, that's not necessarily going to be the case, just because sometimes the information is simply not in there. So it's important to choose the small model, not just assume that you can prompt the behavior you want blanketly. Of course, adding in context, so like information, documents, adding the knowledge you want into the prompt is going to be very useful for both of these things. Just making your prompt a little more complex and a little more detailed may or may not work for a small model, depending on what's already baked into it. Okay, so the takeaway that you might be thinking is, well, if they have to learn specific tasks, does that mean I'd have to train my own small LLM on a task because I can't prompt it into what I want and it has to know some specific thing? And the answer is no. Small models, are getting better generally, but also a lot of them are already trained on tasks. It's just important to know which one you're choosing. And they're usually transparent about this, right? The R1 Distill models, they were trained for reasoning. So if the task you need needs a reasoning model, then they're a great fit. Some small models are trained to be excellent coders. So if you're gonna write some code and you wanna use a small model, make sure you grab yourself a coding small model. But there's a lot of transparency usually with small models, especially because they're open source. They will tell you how they were trained. They will tell you what benchmarks they were run on. So you usually do have access to this. And thankfully, you can usually run them locally and try them out, right? They're small enough that they're not so giant that you have to get like 10 different subscriptions to try them out, right? You can just download them and try them and see if they fit your task. But I would suggest to you that if you have ever grabbed a small model and like tried to talk to it and been like, small models don't know anything, maybe just try a different one. Maybe a different one does know the thing that you want. Okay. This is just a summary of everything that we've talked. There's no new information here. This is just everything we talked about neatly in a table. So hitting on where you can run it, the compute, and also the performance and the general knowledge that we just talked about. So I have like literally 1 minute for questions. So I want to say thank you. I could probably take one question, and if not, feel free to email me or just find me, and we could talk more about small models. So thanks. Are there one quick question? Yes.
Do you have any benchmark for the small models in Vanderbilt?
For Vanderbilt small mod, or like that we ran at Vanderbilt? I don't know that we have benchmarked any small models ourselves. Usually the small models in their report, like they have a lot of benchmarks that they self-report on, that they've run on like the R1 Distills, that was like, here's our data set and here's the performance, here's a different data set. So I don't know that at Vanderbilt we've ever felt the need to specifically. I think maybe just because the reporting is so good. If you want to talk about benchmarking compute, that's of course goes back to Miranda's point that she was making about how I think there's a lot that we should do there. And it would be great to know like the compute needed of a whole suite of small models if that helped people motivate what size to pick. And you also had a question.
Yeah, how do you distinguish between like small model and fine tuning? Because like if you look at that list of the R1, how do I know what tools those accomplish versus the need to do like to fine tune weights on modules?
Yeah, so in general, like these will try to, each of these is a different particular data set, and so the performance that they're noting here is how well it performed on this very specific task. So you can look at the data set that the benchmark is created from and then ask if the task that you're wanting to solve is similar to that data set, and also see how other models that perform really highly on that data set might do on your task. So there's hints like that that can help motivate selecting one. In terms of choosing like which of the small models that we're all trained on, reasoning, so these models were all trained in the same way, but they differ in size and architecture. Llama's different in architecture than Quen. That choice is probably more motivated by what compute you have access to. So like, can your computer run a 7 billion, or does it have to be a 1.5? Is usually where you'd probably make decisions at that level. Okay. Well, thank you so much, everybody, for listening to me talk.
Good morning. So thank you, Jesse, for inviting us over. And Jesse have tasked us to actually give you a little bit of perspective on the infrastructure and how actually we build infrastructure at scale for AI. I'll correlate that with some of the infrastructure that is actually very available for you guys here at Vanderbilt, some infrastructure that we have actually built together with Jesse and part of the Acres team. And I probably have some numbers that are probably very interesting for some other folks around power and cooling on some of the very large solutions and comparisons on those. So I'll tell you, I know several people know me. I'll tell you a little bit about myself and my team. My team is actually composed of multiple scientists and engineers. I'm actually a chemist by background, but we have several different people on my team that are either physicists, computational chemists, applied mathematicians. And essentially what we do, we have a lot of background in research computing. We've been in academia, as well as we actually have built very large machines for folks. So it's a combination of both. So we kind of joke that our machines actually do science. They're not a science project. So you can actually judge that. I'll tell you a little bit about our company as well. We've been NVIDIA's partner of the year in higher education for 4 years in a row. We're a 33-year-old company. So we're very well established in the research community. I'm responsible for higher education, commercial, and federal. So we also kind of transcend that level where we can actually help higher education institutions, have collaborations with other levels. So I wanted to restrict it to 2 slides from the marketing people, so we'll go real quick on those. So let's talk about what we actually were tasked with. And we'll focus this conversation around what we call the NVIDIA DGX SuperPod and how is that structure. And the reason why we picked that building block is because actually Vanderbilt have a 4-node pod that we installed. So this is actually something that relates to you guys and infrastructure that you can actually use. And this timeline actually depicts what NVIDIA have actually engineered from starting from DGX1 to what is called today an NVL72 SuperPod, and kind of the decision on what instruments to use to do science, if you kind of think about it. And the core of what NVIDIA did this is NVIDIA essentially started in the old days building GPUs, and part of my team on those days was actually working with radiologists to do image segmentation and image classification with those GPUs, and they were mainly gamer GPUs, yeah? So to try to scale, AI and machine learning and training and inference at scale, NVIDIA decided to say, I'm going to build a machine that is purposely built as an architecture from the beginning that have the appropriate GPUs on it, have the appropriate I/O on it, have connectivity that allows you to actually do training and inference, and even traditional HPC workloads at scale. One of the scientists on my team Chris Fowler have actually utilized machines like Hypergator at University of Florida in Gainesville, that is one of the super pods, and actually have scaled computational fluid dynamic workloads, traditional HPC workloads across the machine. So you can build a machine, and we have proved this many times, that can do both AI and HPC, and some of the things are actually translate from one another. But it's very important that you fulfill the AI requirements, because if you use traditional HPC resources to do AI, you're gonna hit a break wall in between. So, I mean, we can, my slides will be available if any of you guys are interested. And I put this slide here just to give you a little bit of representation of what our these systems are today. You guys here have a DGX A100. Current DGXs is DGX H200. We also have DGXs Blackwell 200s that are coming, and we have this thing called GB200 MVL72. And it's a very big differentiation between the science these machines can do. So these machines essentially have coherent memory on the GPUs. So the ones that you have today allows you guys to have 640 gigabytes of coherent memory on one DGX. You guys probably know that. DGX H100 doubles that. But again, take a look at power consumption. DGX H100 is around 10.2 kilowatts. Yeah. So as we grow in newer GPUs, if we do that same 8-way machine in the DGX H200, now we touch 14.3 kilowatts. And we actually are implementing a super pod that actually contains, in one of our customers, 6 of the GB200 MVL72s. So the atomic unit of that at the GPU is a rack. It's not just a DGX machine. So that's a liquid cooled machine only. I think there were some discussions, where we're talking about how some of the systems are cool at scale. That is a liquid cooled solution, and that's 120 kilowatts in one rack. Yeah, it's actually 120 kilowatts that needs to be cooled with water, but there's also another 17 kilowatts that need to be air cooled and other components to actually make the machine run. And imagine that times 6 or 12. So just to give you a little bit of perspective, so understanding how your infrastructure run is important if you want to train a model or do inference appropriately. And I will be remiss, I don't want you guys to think, oh, Jose came over here and he told me I need a DGX to do AI. No, I mean, many of you guys, we have had several discussions about smaller models that are very viable. What do you need to actually fine-tune the models or train? So I figured out, let me put a slide on some of the benchmarks that are in, and this benchmarks, we can give you all the details on the benchmarks, but they're more related for you to see that there are other GPUs and other resources, like an L40S as an example, that, and this benchmark is actually run on an 8-way machine, so it's a DGX compared to 8 L40Ss on one machine. But that gives you a little bit of perspective. So depending on time of run, parameters that you want to do, you can actually do very viable science on smaller, or a congregation of different GPUs. Doesn't need to be a DGX superpod. In the same situation with PCIe GPUs, and we have other tricks that we can help you there. But just want to give you those as an example so you don't think that I'm only talking about very big machines. But let's talk about the superpod. And there's some nomenclature that I want you guys to understand here. So when we build a machine as a superpod, there's this scalable unit that is a unit that you actually build. So people, some of our customers, we have to be careful which ones we name, but some of the larger customers that actually do training at scale have multiple scalable units. So there are superpods that contain multiple scalable units all the way to 16, 32, and even bigger. But that's the building block. That's the atomic building block. So if we go deeper on the one scalable unit, that one scalable unit it is essentially 32 of these DGXs machines. So here at Vanderbilt, you actually guys have currently 4 of them. So think about one rack of this, 6-rack scenario. And there's other stuff that you actually use to control the system. So there's also other 2 racks of InfiniBand equipment. There's Kubernetes in there, there's Slurm, there's other components that you actually use to control the cluster. to our previous presentation, there's a lot of untouched or unmetric power and cooling that is also adjacent to the unit besides just the GPU itself. But why this architecture is different and what we're talking about SuperPod and how we compare it with HPC, yeah? So a traditional HPC that we have built for a long time, and when I was, on grad school, we didn't have GPUs, so, that have been an evolution of our society, but we always have built systems that do that can run large parallel workloads, and essentially, a lot of the workloads and science that we have done, multiple matrix multiplications and things like that. Typically, a unit or a building block is a server that is connected with a high throughput interconnect or an RDMA interconnect, being InfiniBand or Rocky, to multiple units, and that's your HPC cluster. But it's typically one rail, so people put accelerators on those, and now I said, okay, now I want to run a workload that instead of running on the CPU is accelerated on the GPU, and I can run my GROMACS or NAND, molecular modeling on the GPUs instead of running on just CPUs. And the workload runs quicker, but that infrastructure is make of that building block. When we build the SuperPod, we use multiple networks. So instead of one network that is an RDMA network that is shared to actually bring your data into the cluster and run your workload, when we do a SuperPod, there's a distinction of networks here. And this is very important because this is a very different characteristic from standard HPC workloads. And what are those? So we have essentially what we call a compute network, or NVIDIA called this reference architecture, or NVIDIA calls compute network, which is the ability to actually align all the GPUs together. So it's a rail-optimized configuration, and essentially what we do in there, and your DGXs here are actually configured like that. GPU 0 of each DGX is actually aligned on a rail, so it's very low latency when you actually train a model about multiple GPUs if you're going to do more than one. There's a storage network that allows you to do things like GPU direct storage, Magnum IO, have the ability to actually load data into those GPU very quickly, so that should be separate to that. And of course, there's an in-band and out-of-band management network, and the out-of-band management network is very familiar for the HPC folks on the team. We need a way to connect to the servers so their actual networks are not connected to it. The in-band management network in here is the one that controls things like Slurm. You guys familiar with submitting, submitting a workload to Acres, so you use Slurm for that. There's other workload managers and other components on that in-band management network, also provisioning for the units and things like that. So those networks is a very, very different architecture than normal HPC. And I'll show you some slides here because it's better to show you than actually talk about it. This is an example of the compute fabric and how the compute fabric is aligned. And as you see here, a representation from one scalable unit to 4. And again, the idea here is that each GPU knows what the other GPUs on the other machines are with very low latency. In that big machine that we call an NVL72, if you guys saw that slide, it has aggregated or coherent memory across the whole rack, yeah? So that machine have actually a specific connectivity called NVLink, like you have inside this DGXs, but across all the nodes in that rack. So that's why I need to be water cooled and adjacent to it, or so it's a different architecture. This is a depiction of the same, but actually more of a block generic depiction. But you can see that depending on the number of SUs is the number of switches that now I need just for that architecture. So a lot more demanding from a cost perspective than your normal HPC infrastructure. And not to scare people, but this is actually an actual representation of one of our clusters, which is actually 4 scalable units. So you can give you a little bit of perspective of how the complexity of tying all these GPUs together, can get to. Storage fabric is very important because if I cannot feed the GPUs appropriately and I have a very large scale computer doing training and mainly doing training actually, and even for inference, if I cannot feed it appropriately, I'm wasting my time. It's a lot more wall clock time. So having a storage network that actually allows us to have an RDMA and doesn't need to be essentially a parallel file system like we use for HPC, for example, and traditional HPC, I should say. but there are parallel file systems that we utilize for AI as well. So there are things that we can extrapolate from existing things that we do on HPC to what we do on AI from an infrastructure perspective. So storage fabric is very important. Here you see a depiction of it because storage fabric allows us now to have that fast interconnect between our storage system and our GPU system. And there's a set of file systems that actually do better in this scenario. We'll have a slide on it. Same slide as before, but in a more generic way. So here's detailing more connectivity between the units, but I'll go a little bit faster. I put a lot of depictions here because it's a lot better for you guys to see it than to me kind of talk about it. The in-band management network, like we were mentioning earlier, essentially contains your ability to have Slurm, to have the scheduler. If you're running Kubernetes, if you're running any other components, or those two racks that you kind of saw other stuff, that actually get interconnected with your in-band management network, and that actually connects with your Vanderbilt network, so you can actually access this resource from your labs, or if you are home coming remotely via VPN, et cetera. Again, I did more a generic depiction here, the same component as well. And the out-of-band management, will go very quickly on that. That's really just for management of your infrastructure people, so pretty much any device that we have that if we lost networking connectivity internally, we need to connect to the device to do service or other things. That's a pretty normal component. Same component there. So there are some file systems that are better for AI. This doesn't mean that I cannot use other file systems. This doesn't mean that, but these file systems are actually SuperPod certified. So what that means is they allows you to actually have Magnum IO and other connectivity to your GPUs that other file systems do not allow you to do on a very easy manner. We have several of this and multiple customers. You guys have DDN here originally. My team does actually a lot of pretty much all of them, but we do a lot with our IBM partners on the spectrum scale as well. But any of those are viable for you guys to actually achieve high throughput connectivity to the GPUs. Software is very important. And one of the things to actually build this infrastructure is that you guys as a customer can actually do several or utilize several software branches, more stable or less stable branches. So you're probably going to see that some of this long-term support branches we have on our commercial customers that are doing AI at scale, yeah? So they definitely need a less feature-rich, but more stable software stack. Any of those are transferable, so that's the advantage of using the software architecture that NVIDIA actually wraps around the DGX SuperPod and all that allows you to actually choose those. This is just a depiction of the one machine, so you guys can actually see what the one unit is. But there's specific software on the machine that actually allows you to actually bring software from NVIDIA very easily. So when you guys, let's say I'm just going to use PyTorch and I'm going to grab a container and I'm actually going to do a specific workload on the machine, or I'm going to do the same thing if I'm a genomics person, I do Parabricks, if I want to do AlphaFold, yeah? So having that ability to actually bring those containers and that multi-tenancy is a very easy environment when you're actually running that on base NVIDIA DGX OS. And your machines here are actually built that way. There's other components here, like NVIDIA AI Enterprise, and this is very important for the folks that are actually doing work with training models using inference, because there's a set of NIM microservices, so you could probably understand from NVIDIA side that you are actually part of AI Enterprise. So again, all the software components together, allows you to do an easier interaction from the research side. So if you want to do AI and machine learning, and I can provide this list for you guys, but these are the latest NIM microservices that are actually supported for NVIDIA AI Enterprise as of October of last year. I need to refresh that a little bit. There's several that have been added to it. Going back from a software perspective, just want to give you a layer side of it. So for the people who are actually administrating this systems as well, want to make their life easier. So Base Command Manager is that software stack that allows them to actually deliver the machines to you, either if you want to do not only Slurm as a cluster manager, if you want to use other cluster managers, if you don't want to change to a Kubernetes, pure Kubernetes environment. If you want to deploy a machine died on me, something happened to the machine, I need to rebuild it and reimage it for you. Well, this allows you to actually keep images in the system and do this in a very fast and easier manner from the folks that are actually managing your infrastructure. This also allows you, the software also allows you to have a better view of your resource utilization for your GPUs. And this is actually important for you guys if you're trying to actually optimize the model, just do training, or just to see, hey, I want to see how good of use of my GPU resources I have. And I'm running, X out of the shelf software, and I can see that I think I'm actually using 4 GPUs and I'm actually using 80% of 4 GPUs or 40% of another. So this GPU profiling tools are very important as part of your journey, either if you're doing training or inference or a combination of both, even for HPC workloads. And I'll go sort of quick here so we can have time for questions. Also, like I was mentioning, not to go into dramatic level of detail, rat holes here, but this software will allow you to actually change if you want to do, Kubernetes deployment. The NVIDIA-based command manager allows you to actually change the way of how that DGX pod is actually presented to the users. Yeah, kind of having the ability of like speaking 2 languages if you haven't, actually changing from that fairly quickly. Also integration with Jupyter Notebooks, which is very important for higher education and research. And like I said, we can go with full disclosure there on how Jupyter integration goes to Base Command Manager. But you can actually use it either if you're interactive mode, SSH into the machine, or actually many other levels. Run AI, will mention it. It's a different scheduler. You guys use Slurm. Run AI is actually Kubernetes native scheduler, so if you change to Kubernetes, you have the ability to actually run AI as a scheduler. Same functionality, actually I shouldn't say that. Same idea as Slurm, but different functionality. Also, I wanted to bring this very quickly because you guys also have here Grace Hopper devices. So you were part of the initial seed program for Grace Hopper. And I don't know how familiar are you guys with the Grace Hopper architecture, but it's a different architecture that is a x86 and a GPU, yeah? So as you guys know, in NVLink, we have the ability to do memory coherency across multiple GPUs. But in order to get all that GPU memory, I need multiple GPUs. So that machine costs me more, yeah? Because I cannot, in order to share it, I need to buy 8 GPUs in the machine. In the Grace Hopper, Grace Blackwell architecture, essentially breaks all those bottlenecks, and you have that NVLink connectivity between the Grace CPU and the Hopper or Blackwell GPU. So you can actually do memory coherency between them and caching, and we can be talking about that for a long time. If you guys are interested, we can give you, there's several things that you can do with memory copying between the two, or allocating space in the other device. But the point is that, allows you to have, kill all those bottlenecks created by extender x86 architecture and PCIe. And I don't know if you guys have heard, probably have you seen Jansen, talking about this, but this is the NVIDIA DigX project. And essentially, I don't think some of you guys are not, I'm old, so I remember DGX1. So this is essentially a miniature DGX1. Jansen was very interested in doing that. And essentially brings you a different Grace Blackwell CPU as a desktop device. This will be a very powerful machine that now you can have in the labs. A lot of the folks, and we do a lot of work with folks that have larger instruments, NIH, CDC, and others, and when you have larger cryo-EMs or a combination of them, or either light sheet microscopes, so devices that actually create a lot of data, And essentially, you need to analyze some of that data locally before you run samples and things like that. We actually had to build this, big kind of purpose-built, workstations for them. Everybody's looking forward that, a machine like Digits will allow you to do that in a shorter period of time and will be like more benign, not only for easier to actually move from location to location, but also better with power and cooling. That's all I have. Any questions, anything that you guys are interested at? We're also going to be on the break, so all questions are valid.
Thank you very much. I'm curious about looking ahead to quantum. How would quantum qubits feed into the bits that we're using in AI, supposedly in a superpod?
Yeah. So we do a lot of work with a lot of the manufacturers, including IBM, Cray, and others. And yes, so a quantum computer today, as you probably know, have other challenges on power and cooling, yeah? And you need to have liquid nitrogen and other components to it. There is a lot of work in software-wise that NVIDIA and others have been doing, other researchers at other universities, actually in the UK, about trying to do or trying to mimic and do workloads that you could do a quantum with the newer GPUs and see what you can advance there without being too offensive, yeah? But this is a challenge that we have, like today, and several presentations that you heard. I mean, it's not only an air-cooled machine. Now you need water to cool the machine. Now I need water to cool that machine at scale. Now I need a lot of power to actually power the one rack only. So when we're talking about putting constraints like that in a data center that was never intended, is kind of not normal, yeah? We have several customers that there's another method of cooling machines that is immersion cooling. And these machines that are in places that are not normal, either places that are very dry, deserted, you can probably get the gist, yeah? Places that are actually, we're doing research or other federal entities are doing work, you have the ability to actually do immersion cooling on it. Actually, our friends at Clemson have wanted this. It was mainly for research. A lot of these other methods are kind of messy, yeah? So the actual ongoing work on those and keeping those in a data center environment is very demanding. Hopefully I answer your question, but if not, we can talk about more detail on that, for sure. You have a question? Awesome. Thank you, guys.
And you're going to see all the tools and components. Very quickly go over them. First, you have error analysis, which is showing you how error is distributed across different cohorts in your data set. So, you know,
Good morning. Hi, my name is Alicia Moniz, and thank you for having me here today. I'm with Microsoft. I'm a data and AI specialist. Before joining Microsoft, I was a 3-time Microsoft AI MVP, which means I did this job for free. I traveled with many of my friends, speaking at different Microsoft events, such as SQL Pass, and have a lot of hands-on practical pushing code into development experience. So it's fantastic for me to kind of share some of my experiences and talk about not just the tools, but also the people and the processes that go into building AI systems and building them responsibly. So thank you definitely for having me here today. So I'd like to start off by getting to know we're tasked with building data science models. And raise your hand if you're on the business side, where you're using the outcomes of these models to either influence decision making or automate a process. So usually the room is going to be 50-50, where we have technologists on one side and businesses on the other side. But at the end of the day, we all need some type of processes available to us so that we can go ahead and analyze the work that we've done against the models and reflect on how the data sets are uniquely influencing each of the models. And maybe best case scenario is generate a report that we can share with people that we work with who are also non-technical, so that we can have conversations about how our models are influencing the outcomes for these experimentations. So at Microsoft, we have 6 principles that define our view on what responsible AI is. So within the framework, we have fairness, where we believe that AI systems should treat everyone equally. So they should provide the same recommendations to all individuals, and this should help prevent discrimination based on personal characteristics. Reliability and safety. AI systems must operate reliably, safely, and consistently under various conditions to help build trust. Privacy and security. AI systems should respect privacy and maintain security by protecting private and confidential information. Inclusiveness. So AI systems should empower and engage everyone. So this potentially avoids barriers in delivering our products and services. Transparency, where AI systems should be transparent and understandable, where we should have an ability to understand how decisions are impacting users on the individual level. And accountability. So AI systems and their developers should be accountable and answerable to the potential impacts of these AI systems. Now, this is all part of a framework. So we have a set of in Microsoft's Responsible AI Toolbox. So I'd like to talk a little bit about the tools that are available as part of this framework. So the Responsible AI Toolbox is a collection of, and I wish Miranda was here, because I heard her earlier advocating for more reporting against insights as far as what our models are doing under the covers. And this is exactly what the Responsible AI Toolkit can help us with, is gaining those additional insights as to how our data is uniquely influencing the models. And it's not just one model, it's every iteration and every version of a model. So what's generally in this for you as a data scientist? So we've gotten to the point where we've increased accuracy of a data model to that 89 to 90% range, and we're good for the day. So how can responsible AI practices help us to improve the performance of the model? And usually what we do is we add more data to the training data set, or we'll go ahead and throw additional compute so that iterations run a little faster. But what we're doing here is we're influencing the outcome of the model at an aggregated level versus looking at how we can dig into the individual cohorts within the model analysis and improve our efficiency against the individual cohorts. So what we can see here is there's probably some underserved groups within our cohort where we can absolutely look at what can we do as data scientists to improve and better serve that population within the group. So some of the reasons why a particular cohort might underperform includes subsets of data that are mislabeled, bias in the data collection, and of course, incomplete data sets for cohorts. So what we can do is we can take an always learning approach. So the model is at 89, 90%. So it's not a bad model. We can still use it. We can still optimize, but we can use it knowing that for a certain subset of the population, they are getting less than best intended results out of our model. So how do we fix that? How do we deliver better insights for that cohort? And how do we take an iterative approach so that as we're making progress against that, we're able to continue to analyze and to continue to report against that progress? So the Responsible AI dashboard provides the tooling necessary to identify some of these unfair incidences within our cohort, and it helps us to diagnose and mitigate these unfairnesses within our models. So the error analysis package is going to let us identify cohorts with high error rate versus the benchmark. So if we're looking at potentially demographic-based analysis and looking at underserved populations and particular zip codes, maybe there's some data augmentation that we need to do in particular to get a better story out of that cohort. It also lets us visualize how the error rates are distributed. So visually, we can toggle through and we can really quickly, via heat map analysis, identify those cohorts versus looking at things in a textual format. With the fairness assessment, we can aggregate a variety of fairness assessment metrics and, again, show the model prediction distributions. And a common example of that is when we're collecting data and maybe the people who are responding to the questionnaire or the sample providers are predominantly either in a geographical region or say we happen to interview mostly adult males in their 50s or 60s, and they have a different perspective than college males who are between the 18 to 35 range. So how we're going in and collecting the data definitely affects how our model is able to reason over the data. With interpretability, we can identify key factors that are influencing model predictions. So say we have a preconceived notion that 10 variables are needed to come to an easy determination about whether an event will occur. But in actuality, we have 4 to 6 key driving factors that heavily weight the outcome of that decision, and maybe the effort spent in getting cleaner data around those 6 variables is a better way to spend our time than to chase down augmented data for the other 4 variables. And then we have counterfactual analysis. So this is where we can perform experimentations on what-if scenarios. So if we had a different range of variables for variables 6 through 10, how would that change the outcomes of our models, and what population would that affect? So at the end of the day, we can create an understanding of the causal impact of the model features on real-world outcomes. So if we are able to change our data collection process and we are able to supplement the data sets that we're feeding into our data models, then what part of our population of customers that we serve are we now able to provide better services to, because that cohort now has a higher level of matching for the model. Now, adding responsible AI reporting as an extra step in the process of experimentation is easy peasy in the machine learning studio. So for those of you who use the machine learning studio, you know it's a drag and drop interface. So this is a task that you can drop after you've trained your model and had some type of result. And we have a really quick demo here. I do have a trait today, so we're getting to that. And for my programmer friends who prefer to get hands-on with coding, these capabilities are also available programmatically via YAML-powered workflow. So you can specify which responsible AI components you want generated, and you can also call this via Python scripting. Now, each component has the ability to generate a shareable PDF, and this will contain the key summaries of the responsible AI insights and can be shared with the technical and non-technical stakeholders as well. So when we get to the point where, and I do see this coming very quickly, we have a lot of policy coming out as far as transparency into how we're using AI and what populations are being affected by our AI systems. So this sense of urgency is on its way as far as, you know, are you able to provide information about what data you're using to feed into your AI systems, and how is that AI system impacting the users of your AI system and your products. So this is, even if you don't use the Microsoft products, being aware of how different products are working and their different features and their different functionality will help you internally to kind of put together an internal plan for reporting, because responsible AI isn't just a technology problem. It's a people, process, technology conversation where if we have that conversation early, we can go ahead and put together that plan. And if we do have either a high-risk situation or a very impactful need to report against what we're doing, we're aware of our different options for filling that need. Now, I do have a trait, and he might be watching. So, Seth, this is for you. And he's not here, but Seth would be the first one to say, did you know that I went to college with Alicia Moniz? So, quick shout out to Seth, and he's one of our principal program managers for the AI platform. He's host of the AI show. He is the most fantastically wonderful human being. I do have a quick demo here that I would like to share, and it showcases Minsu Thigpen, and she is one of the product managers for the AI product team. So let me go ahead and get this kicked off, hopefully.
And you're going to see all the tools and components that you've created.
And just to give a little bit of backstory, what they're doing is they're doing an analysis of a data set of data science users. And what they're trying to do is put together a ranking system. So it's an automated ranking system to determine who should be approved for access. And it's a prioritized system based on a list of different demographic variables that have been supplied. And of course, this is fake data, so.
For your responsible AI dashboard. So there's a lot of stuff here, and I'll very quickly go over them. First, you have error analysis, which is showing you how error is distributed across different cohorts in your data set. So in model training, we oftentimes have aggregate metrics that doesn't tell you the whole picture. And so we have an intuitive, tree-like map that shows you where exactly your errors live, right? And then we also have a heat map for showing you across multiple features where your errors live. And so you can evaluate errors in your model this way. Secondly, we have the model overview, which actually is going to show you some, fairness metrics here as well. Fairness metrics are essentially nothing more than showing you some disparity or some other definition of fairness as how your model is treating different cohorts in your data set. So here you can see an overview of the different cohorts in your data, as well as fairness, difference, and ratio of the metrics that you're looking at. In this case, you have the mean absolute error, squared error, and prediction. And you also have a handy visualization tool at the bottom to help you visualize this table form as well. Thirdly, we have data analysis. Because when you're looking at the performance and output of your data, your model, the data story is really important in understanding, over or under representation that might affect how you've trained your model. And so we have aggregate plots, we have individual plots, scatter plots, and you can actually really key this into different cohorts of your data that you're interested in. Maybe I'm only interested in seeing the distribution of error across people who live in Antarctica. Then we have your classic feature importances, which shows you overall and at an individual level what actually is impacting the prediction that your model makes. So in this case, we see that style is the highest impacting feature for your model predictions. And you can see a breakdown of those as well. Then we have counterfactual what ifs, which actually, this is like a really cool tool that generates these diverse set of data points that are going to show you what are the minimal changes required to flip the classification or get your desired outcome within a certain range. And then we also have this awesome feature here where you can actually manually perturb the specific features you care about and see a real-time update in your prediction. Then last but not least, we have causal analysis, which is going to show you what is the causal effect of certain features that you're interested in, like number of GitHub repos someone has or years of experience they have on their desired outcome, which in this case is a programmer score, right? The programmer score is what enables them to get GTP2 model. And you can see it for overall, all of your data points, for individual people, what exactly needs to be changed, as well as a recommended treatment policy for each feature. So if the treatment feature, we want to understand how to have a policy around increasing or decreasing this number to have a real world effect on the score, then we have this really awesome set of tools here and visualizations that's going to show you how to actually impact the real world outcome of the score through a recommended policy and how it impacts the gain in your score, as well as if you don't have the resources, top 10 people to target here. So that's really brief, but
and I encourage you to catch the rest of that episode on the AI show. And that was Seth. He is amazing.
And you're going to see all the tools and components that.
Now you can easily get started and access the components of the Responsible AI Toolkit via GitHub. So all of these capabilities are available open source. And there's a plethora of documentation and sample Python scripting with sample data sets. So what you can do is you can go ahead and step through the code and get a general gist of what type of insights and reporting is available. And then you can go ahead and apply it to your own data science project. Now, the Responsible AI Toolkit is just one of the ways we help you mitigate risk here at Microsoft. So we also have a AI impact assessment template. So by involving your stakeholders early in the process, you're able to identify both potential benefits and potential harms related to the AI system. By having a plan in place, we can go ahead and have our stakeholders, we can help them with creating a transparent path forward when it comes to addressing questions about how we're using our AI and our systems. We also have available an AI impact assessment guide. So this may be helpful for you in having those conversations. And we also work with our partners within the industry. So some of the partners like Accenture and Avanade and Deloitte and folks, where they can come in and they can, from an industry perspective, have those conversations with you specifically related to where your data is coming from. So if you have a research project going on and a partnership with somebody in the commercial space, whether it's manufacturing or operations, and they have certain guidelines around their AI usage within their industry, we're very happy to partner with our partners so that we can bring all perspectives to the table. And lastly, we do have available transparency notes for all of our generally available AI products. So if you're wondering exactly what the capabilities are and some of the limitations and some of the covered use cases, that's a good place to start when you're looking at building your risk portfolio and looking at kind of some considerations up front on which set of tools apply to your situation given your regulations. So thank you for having us here. We've had such a fantastic time these first 2 days. Just starting from the keynote with Jesse, I think our whole account team was just all smiles. So this is my first time to Vandy, right? So now I know it's Vandy. So I'm learning slowly, but we've had a wonderful experience. It's always so satisfying to meet with people who share an interest and excitement in what you're doing, and I wish everybody success in building your AI systems. So thank you. And I do have a couple of minutes for questions, but we're here throughout the day, and I'd like to introduce the rest of my team here. And again, so Candace, thank you for encouraging me to participate in today's activities, and Jacob, Vivian, Chuck. And Heather will be giving a fireside chat shortly. So thank you, everyone, for supporting me today.
Good morning. Good morning. Okay, it's about 11:30, so I will get started. What a great talk to follow. I think we'll build on each other really nicely. My name is Sarah Burris, and I'm an AI ethics and education researcher with the National Science Foundation Engage AI Institute, and also this semester an instructor of AI ethics at the Data Science Institute here at Vandy. In my work, I think a lot about how we teach young people the digital literacy practices and ethical habits they'll need to flourish in our AI-infused world. First, a little bit about Engage AI. We're a multi-institutional research and development center with researchers, students, and staff at Indiana University, Digital Promise, NC State, UNC, and Vanderbilt. There are about 80 of us working together to research and design learning tools, environments, and curriculum that's powered by and engages with AI. Engage AI is built on a model that centers interdisciplinary work, bridging core AI techniques and research with educational applications. Part of the mission of the Institute is to design and develop AI-powered, narrative-centered learning environments that, 1, incorporate cutting-edge AI, and 2, value ethical practices in their design and application in classrooms and other learning environments. So among other things, we make narrative environments like this one, currently in development, where middle school students act as agents, investigating AI for the Virtual Tech Assessment Laboratory, or VITAL. Along with that adorable helper bot there, they engage in virtual ethics explorations and evaluate potential harms and risks of emerging technology. So why are we making these games and investigating ways to teach about AI ethics? Why put so much effort towards ethical exploration of and education about AI at all levels of education? I'm going to share with you my answer to this question, though there are many. Before moving here to Nashville and getting my PhD, I worked a block away from the Charleston Emmanuel AME Church called Mother Emanuel. This church was famous in our community and beyond for being a vibrant congregation with historical importance as one of the oldest AME, or African Methodist Episcopalian, congregations in the South, founded in 1817. Unfortunately, it's now also famous for another reason. It was the site of a mass shooting in June of 2015. One of my colleagues, librarian Cynthia Hurd, was among those murdered in the massacre. Cynthia and 8 of her fellow worshipers were killed by Dylan Roof, a self-avowed white supremacist at Bible study. Although Cynthia and I had not been close, we worked at different branches in the library system, I admired her like everybody did. She was fine, she was funny and kind, and a really wonderful librarian. I had actually been in a meeting with her, filling in for my supervisor, the morning of the day she was killed, and I have this memory of her sitting across from me in a sunlit conference room, laughing with those friends she'd made over her decades of working at CCPL. But here's the thing, I thought that this was a terrible human tragedy. I didn't at the time make the connections to the design of algorithms and the architecture of our online information systems. It wasn't until later, when I was reading Safia Noble's amazing Algorithms of Oppression, after I had started my PhD studies, that I was confronted with Roof again and saw the tragedy in a new light. Roof had written a manifesto where he connects his radicalization directly to a Google search for, quote, black on white crime, saying he was, quote, never the same since that day. PageRank algorithms had directed Roof to a white supremacist website called Council of Conservative Citizens. Noble analyzed the role of Google search and search ranking in Roof's ideological development. She writes, quote, a straight line cannot be drawn between search results and murder, but we cannot ignore the ways that a murderer such as Dylan Roof, allegedly in his own words, reported that his racial awareness was cultivated online by searching on a concept or phrase that led him to very narrow, hostile, and racist views. In her analysis, Noble connects the underlying profit motive and the implicit epistemology of page ranking and search results to what happened with Roof. She writes, quote, search results are not tied to a multiplicity of perspectives, and the epistemology of ranking from 1 to 1 million or more sites suggests that what is listed first is likely to be the most credible and trustworthy information available. So by seeing the Council of Conservative Citizens front and center, top ranked, Roof was involved in a complex socio-technical web that perhaps nudged him towards radicalization. This realization has driven my research and teaching ever since. I wonder, how did machine processes guide or constrain Roof's choices? Knowing how crucial the design of our algorithmic systems is, how might we make them in ways that, instead of advancing hate and misinformation, might help us work toward greater equity, understanding, and human flourishing? Noble said that, quote, "a straight line cannot be drawn between search results and murder." So yes, the line's not straight, but it's tangled in a web of socio-technical factors: Ruth's childhood and adolescence, permissive gun laws, including the Charleston loophole, a national history of racism, a search result. But what if that line got tangled or cut by any number of intervening factors? A caring adult, a critical teacher, an effective law, a nurturing community? And this question that both haunts me and impels me to do this kind of work: what if you or I could be or could build the intervention there? So I told this story on the first day of teaching the amazing master's students here at the Data Science Institute this year, as a way to show how I know that this is so important, and as a way to think about how something so seemingly innocent as PageRank is way more than just a number. The data we generate and analyze is important. How we collect it, how we build those data sets, train models, interpret predictions, design hardware and software to collect and use these data, how we package and present information, all of these have real-world impact. This is true even when, or perhaps especially when, we cannot see who we're affecting, when users and victims are abstractions rather than Dylans and beloved Cynthias. So I hope that this is enough to at least convince you a little bit that AI ethics and AI literacy are vital. But if not, never fear, I've still got a few more minutes. So now we're going to shift a little bit to my area of scholarly expertise and the work that I've been doing since that realization, excuse me, and talk about what AI ethics has to do with school. AI is, as no doubt you've seen and heard over the past 2 days in all of these wonderful sessions, it's all around us. It's in our pockets, helping us navigate home, at our banks, determining our loan worthiness, of course, dictating what's on our screens. It's also in our schools, from things like grade and dropout risk prediction to surveillance systems. The latter is one that has become especially, also unfortunately, relevant for our community here in Nashville. This slide is one that I actually made back in 2023, where I noted that MMPS, Metro Nashville Public Schools, our large school district here, had signed on with a company called OmniAlert to the tune of $1 million to put surveillance hardware and AI gun detection software into local high schools. I, over the years, kept searching the news for updates, but I just had to assume that the systems were indeed operational around November of 2023 and didn't hear much about it until, fast forward to a few weeks ago, and the system is back in the news alongside the tragic description of yet another school shooting, with headlines like, quote, "AI weapon detection system at Antioch High School failed to detect gun in Nashville shooting," and another, "MMPS passes rollout of a new weapons detection system across Nashville's high schools." But how should we understand and learn from these events? How can AI ethics help us? Scholars for years have wondered, do we know that these systems really work? Moreover, is there evidence that they do more good than harm? AI ethics praxis gives us perspectives, theories, cases, and tools to explore these critical questions. How might we build or redesign these systems with safety and privacy in mind? And what about those other mainstays of, AI ethics work, like accountability, like transparency, and fairness? I think that asking these kinds of questions and seeking the perspectives of developers, designers, students, educators will help us not only build better AI, but a better world with AI. When we see AI ethics as inclusive of both social and technical factors, as a rigorous and worthy pursuit best done in conversation with lots of people, with lots of experiences, viewpoints, and areas of expertise, I think we can achieve these complementary goals of better technology and better humanity. And that's the way I conceive of ethics in my scholarly work and as a theoretical foundation for my own teaching. But there are a lot of entry points for doing this work, as I bet many of you are familiar with. For example, from a philosophical perspective, borrowing from the Markula Center for Applied Ethics, ethics can mean, quote, standards and practices that tell us how human beings ought to act in the many situations in which they find themselves. It's concerned with our character. It requires knowledge, skills, and habits. But ethics are not the same as feelings, religion, following the law, following culturally accepted norms, or science. Often when people refer to AI ethics, they have in mind a set of principles and practices, or the process of creating those in mind. Take the example here of the long-lived ethical thought experiment of the trolley car problem. Here we see a screenshot of MIT's moral machine experiment. Has anybody done this online? Oh, it's interesting. Where you can check it out if you're interested. It's still up. Where they tested out various permutations of the trolley problem, where people decide what action to take or not take to spare or sacrifice someone's life, with scenarios involving autonomous vehicles. This is one ethical practice, engaging in thought experiments to figure out what ought to be done, to perhaps establish a set of rules or policies for real-life ethical issues. But in addition to a philosophical entry point, we might also take a mathematical one, finding methods to quantify fairness and mitigate bias. Or we might pursue a legal one. As we know from basically all of human history where we've had laws, laws are not always ethical, and what's ethical is not always law either. A legal entry point might mean trying to align our laws with our ethics. A sociological one may look like what my Vanderbilt colleague Jenny Davis is doing, working on moving from fairness towards algorithmic reparation. So there are a lot of ways to think about ethics in general, and AI ethics in particular, and here are a few examples of some governmental and non-governmental organizations that have produced frameworks and guidance for how we might think about this in various fields. On the right, you'll see a document outlining policy suggestions for developing and using AI with kids, published through an office of UNICEF. We've also got the more technical AI risk management framework from NIST, the National Institutes of Standards and Technology. Finally, we'll talk next in more depth about the blueprint for an AI Bill of Rights from the White House, from Biden's White House. But all these guidelines and frameworks share common themes, touching on important issues of safety, responsibility, fairness and bias, privacy, transparency, and explainability. So Biden's White House published the blueprint for an AI Bill of Rights, which is now archived along with Biden's other whitehouse.gov materials. It seemed back in 2022 like a great place to start, and an important text for students and educators to think with. The blueprint outlines 5 key principles that you'll see here. First, AI should be safe and effective. It shouldn't harm you, and it should work properly. AI should not discriminate unjustly and perpetuate bias. Data privacy and security should be protected. You should be given notice and explanation of when AI is used and how it affects you. And finally, you should be able to opt out of using an AI and have the opportunity to interact with a person if you need it. Using it in the classroom, though, we realized that, of course, this document was designed for adults, with sometimes complicated technical language and with vanishingly few examples that were relevant to those young people's lives. So over the next few years, I worked with a variety of really incredible students in grades 7 to 12 to reimagine what a student-centered AI Bill of Rights might say and what it might look like, showcasing their artwork in publications and in a virtual gallery that they can navigate online. So they made a bunch of beautiful posters, digital and with other media. They also made spectacular and truly hilarious video public service announcements. And if students should have a say, we thought, what about their teachers? Engage AI, the NSF institute that I work with, also has an amazing board of practitioner advisors, including these beautiful folks you see here on the screen. And these are a set of practitioners from across the country, and they're in a wide range of different educational roles, from classroom teacher to district policy leaders. And so we've been working together the past few years to think about what educators need to implement ethical AI. Together, we drafted a version of an AI Bill of Rights for and by educators that attends to the particular needs and strengths of those in classrooms every day working with our children. As we were working, we realized that educators may not have access to clear information about what AI tools might help them assess, or whether their students' rights would be protected if they use them. So we got to work again. With these same practitioners that you saw on the last slide, I'm currently working on evaluation and documentation processes and tools for ethical AI for education, translating this classic idea of a model card as a documentation tool into an AI compass for educators, which describes an iterative, collaborative education evaluation process. So this is the current version of our website, which I just presented to some educators last week in Anaheim, and hopefully will get taken up into various districts across the country. So this site, the compass, the process, and the set of tools that go along with it is designed to guide school leaders in making sure an AI tool is safe, effective, and appropriate for the particular learners in their context. But it doesn't end there. Importantly, we're building out a process where evaluation doesn't stop once the ed tech contract is signed or the site is whitelisted by the IT department or district officials. Rather, ethical AI is a demanding client, not to be left to its own devices, so we encourage educators to continue collecting feedback from community members, students, teachers, and administrators as the tool is being used, addressing any grievances that these stakeholders may have, and continuing the ethical evaluation process iteratively. So I'm going to wrap up my brief talk here with my answer to this rather blunt but crucial question, so what? I think all of this AI ethics stuff, whether you enter it from a philosophical, a legal, sociological, or applied entry point, in the right hands, which is to say in all of our hands, in everyone's hands, can really change the world. It can't bring Cynthia Hurd or Diana Correa back, but we can honor their memories by continuing the work, pushing for better AI literacy through AI ethics education and practice, and for better AI itself. Thank you. And we do have some time for questions too, or a discussion. I'll get down from here and maybe put on the mic if anybody wants to. I get to show my Ted Lasso GIF here. Is this on? Yeah, okay. All right. What does everybody think? Anyone have kids in K-12? Anybody in Nashville schools? Comments or questions? We have a few minutes. Yeah.
This is very interesting. You actually have a Bill of Rights also you shared. So the question I have specifically is that, are you following any industry standards, globally? Are you applying it only locally to the Tennessee, or are you looking at global-wise? How are we going to get this AI, standards adopted in education system? That's my basic question. Then the second question I have is that, let's say how we adopt AI and then also tailor, our education system. What did you include in the Bill of Rights, especially in the United States? What is that you have actually included in the Bill of Rights?
Thank you for those questions. I'll move back to the Bill of Rights slide. But to answer your first question about global standards, I think my answer to that is that it's kind of to borrow from improv friends, oops, I went too far, a yes and kind of a situation. So I think that we need globally applicable standards, but I also think it's really important to consider the local context. So for example, if we are, like we are at Engage AI, developing affect detection and response systems for students in online learning environments that don't work, for example, with the kinds of faces that we have in our classrooms with children of particular demographic makeups, we have to know that. And so we can have this overarching standard that says, okay, we have to make sure that our tools are trained and tested for the particular students that are in our context. But then we also have to actually do that and know to apply it in that way. So I think it's the kind of thing where we can have global conversations while still being attentive to local concerns. And for that, we need to have a certain amount of AI literacy education for educators at all levels, so that they can make good decisions too, in addition to that top-down kind of policy. So that's my response to that. I also am excited to, hopefully, we're applying for a few grants to work with folks in Hong Kong and Singapore and other places to start international dialogues around AI policy for education. This work is nascent. We're thinking about it. We're making partnerships. We're collaborating with others to try and figure out what those international standards might be, and then how we might apply them at local and be attentive to local needs and populations. And for your second question, our educators' version of the Bill of Rights includes 6 basic rights that fit into the acronym SAFE AI. Those include support for using AI tools, including appropriate infrastructure, hardware, software, policies, and training. So it's not enough to say to a teacher, hey, here's Magic School AI, you gotta use it, but they have to have the Wi-Fi access. They have to have devices that are powerful enough for their students to use whatever AI tool or feature they're working with. The second is agency and pedagogy, specifically the ability to make choices about whether, when, and how to use AI based, importantly, on learning goals. So in these processes, the learning goals are the central piece. It's not like, here's a technology, let's find a use case for it, but here's a problem of practice that then we can locate a tool that might help us solve this problem, this human problem of teaching practice. And that lets teachers use their pedagogical judgment too. So increasingly, we have seen a trend in distrust of teacher judgment, in the increase of heavily scripted classroom materials that don't allow teachers to make changes to what happens in their classrooms. And so it's important, we think, especially as tools become more globally scaled, that teachers still have in how they want to apply these tools. The third F is fairness in implementation of AI, including adoption of AI systems to empower educators and use of AI that has been proven to minimize harmful bias. So we want those tools that have been proven to work with the students who are sitting in our classrooms. Then we have equitable access to high quality AI tools for students and educators. So we want to minimize those gaps of function and quality between free and ad supported and costly technology. I think also this increasingly is related to a privacy access gap, where if you have the means, your student can opt out of school surveillance, for example. So there are 2 examples that I like to think about in relation to that. One is that a lot of our students here in Nashville have on their school-issued laptops surveillance software that means that teachers, principals can look at whatever they're doing on their screen at any time and wherever they are if they're using their device. So say you have a student who doesn't have the means to purchase their own laptop. They're using the school laptop, they're using it at home. I had a student once tell me that they were homesick from school one day and the teacher called them out in class for watching YouTube while they were at home sick watching in their house. So, you know, we have a gap here in who can access privacy, who can afford privacy. And I think that also goes for school-sponsored tools, where, you know, if you can't afford your own ChatGPT, if you can't or don't want to buy your own ChatGPT subscription, does the school-sponsored one have access to the data that you're putting in there? So we have that kind of access gap, privacy gap. Next, we have advocacy for and by educators of best practices with AI, including being involved in selecting, adapting, or resisting AI tools in learning environments. So we think teachers should have a meaningful say in how these things get selected and have built that into our evaluation tools. And finally, we believe that teachers have a right to information about AI, communicated clearly and openly, including details about data privacy, who created the tool and for what purpose, environmental impact, and evidence from research on safety and efficacy of models in their applications in classroom settings, which is often shockingly unavailable to educators. So those are what we have been working with as our educator rights, and increasingly we're working with students to reimagine what this might look like for them as well. Did that answer your questions? Okay. I think actually we have time for one more if anybody.
Thank you. My question concerns, so I guess on a national level and a local level. On a national level, do you work at all with U.S. Department of Education? If, in fact, the U.S. Department of Education is dismantled, what openness on a local level is for what you're advocating, the Bill of Rights? And if at a local level, that is, maybe there isn't a willingness and openness to adopt some of these measures, is the private sector even open to this idea? So I guess, yeah, I'm just curious as where this goes. If at a national level we're not interested, at a local level we can't, is the private sector willing to engage further in this?
Okay, that is such a great question on this day of when they have predicted that an executive order is going to be signed to dismantle the Department of Education. The truth is, though, that already our education policy is so localized that I don't think that is going to have deep impact for civil rights for students. Because they administer a lot of the programs that ensure that students who have individualized education plans can access the services they need, all sorts of stuff like that. But I think on an AI policy level, that particular thing is not the death knell. But the question about private companies is also a good one, because I think we just don't have adequate, this is my opinion, I think we don't have adequate safety and ethics regulation of AI tools generally in any industry. We do have, for example, FERPA is a privacy law that educators are bound by that protects student data privacy. So in that realm, companies have to show that they're protecting student data in certain ways. But if we're talking about other aspects of ethics, I think it can get really tricky. And I think it's a matter of making sure that we are aligning the ideas of ethical AI with good AI. Like a good AI tool is one that works for the students in your classroom. You're not going to want to buy a tool for your district that doesn't work on Black and brown 12-year-olds, if that's the majority of your population. And so I think part of it is hammering home this idea that ethical AI is also the AI that works for your people. But I think, it's a complicated issue, and also related to trends in how commercialized products are increasingly becoming prevalent in our schools. And that includes not just technology, but also curricula that, are corporate entities that have increasingly guided what our students are doing and seeing and learning at school. So I think that's a really good question, and we'll see. But I remain hopeful, and I also think that what's going to happen today is not the end for a lot of this work. Thank you. Thank you, everybody.
A quick introduction, if we could. So Heather, you are Vice President, U.S. academic, but that covers K through 12 and higher education, and also academic research, healthcare systems. Is that correct?
That's correct, yes.
That's great. But also, you are a member of the Board of Advisors of Syracuse University School of Information Studies. So you sort of have your hand in higher ed in many different ways.
Absolutely. I mean, the excitement of sort of seeing it firsthand and being able to then propel and sort of think about what that means to the industry as a whole, I think is part of my goal of being part of the iSchool board at Syracuse, and seeing firsthand just the students, the faculty, the researchers, and certainly today with Gen AI and agents, what the opportunities are in the future and how to think about the curriculum to support that moving forward is, you know, I get to see it as I travel across the country, certainly. And as we think about what you're doing with this session, like today and yesterday, I think is really bringing that to life. So just super excited to be here. So thank you for having us.
Absolutely. And Hernan, you actually have a background in higher ed. You're currently the Chief Technology and Innovation Strategist for Lenovo.
Correct.
But you were, for a number of years, Barry University Associate Vice President for Technology, Chief Technology Officer, but were also a teacher. You were a professor in teaching computer science as well.
I was. So the background is a little bit diverse. If you think about now being with an industry in a company like Lenovo, and we were having a conversation outside just a little while ago about the fact that I came from what we call the customer background, and so I was in higher ed, and I have not stopped thinking like a higher education person that I was for, and I'm still are, for about 25 years. That's what I was doing prior to originally going to Dell Technologies and now being with Lenovo.
Well, thank you again for bringing your expertise both in industry and also in academia to us today. Heather, I'll start with a question for you, if that's all right. What role do you believe AI plays in personalizing education? And what advancements do you see in this area?
Yeah, I mean, certainly AI is really in education. I think that it's sort of ripe for true innovation and disruption there on the personalization side. So I think about this in three different ways. First is certainly meeting the students where they are with their unique capabilities and with their unique interests. So the way I think about this is, my son was on an IEP when he was younger. He got taken out of the classroom, and it was specifically for reading. The second that he found books that he loved, he became this voracious reader. So, if he'd had that opportunity just sort of sitting in the classroom and being served up stories that excited him and engaged him, to me, that's like, I think about that at the university level in whole new ways. You can go further, faster from a capabilities perspective, really sort of leveraging the personalization aspect of AI in higher ed. And that's with multimodal, from an accessibility perspective. It's not just about this meeting you where you are having to read about something. Is it voice? Is it, depending on somebody's potential accessibility needs, like how they need to hear and see it. So that's in a multimodal way. The second is really on the intervention side. So as we think about data and how we could potentially leverage sort of the institution's overriding data about students, and not in a invasive way, just to make sure that we're sort of seeing the holistic student and making sure we're looking at trends overall, and therefore bringing in personalized ways of, teaching different pathways into that, sort of taking some of the macro data. And then third is just the tools themselves, like in the actual sort of educator's toolbox. How do you bring in tools that are going to help with new stories, new creative ways of actually bringing things to life? So I really see that sort of in different ways, so that, again, sort of the educators can meet the students where they are and engage them in completely new ways that are going to help them sort of unlock potential that they didn't even know that they had in themselves.
Fantastic. So brand new opportunities, also possibly need for upskilling, retraining, and so we know how to take advantage of those as well.
Exactly. Yeah, and I think that the skilling piece too is, sort of from the inside out and the outside in, which to me is there's a, I was listening to a podcast the other day about this idea of downward learning. Like, you can learn as much from sort of people on the ground as you can from like being this SME, so to speak. So, the more that we can think about how do we actually skill up on these technologies in different ways, you have to sort of understand, like, how do you think about what that person is going to need? And the only way you can understand that is if you work with, sort of like pull that into what you're thinking about.
Fantastic.
Jesse, can I add something here? I think Heather brought up multimodality, which is, I think, fantastic. So to recognize that we have been here before. We were dealing with chatbots before, and kind of the same data existed. And chatbots are very clunky, and personalizing education or instruction was not a good experiment. And so here we are in the age of AI, which presents this inflection point, and now the fidelity of the experience is different. And I think that's what's changing the dynamic. And the fidelity changes because of the multimodality of AI that allows this now interaction to be much richer. But on the other side of that, this digital assistants, if we want to call them that, with powered by AI, have memory. So they can assess and they can remember where you are and create a much more rich interaction when it comes to instruction and education. So I think it's a fantastic time for personalized education and instruction.
And you actually bring something funny to mind. Can you imagine 5 years ago, saying to someone from 5 years ago, chatbots are going to change your life. And they just, you'd be a crazy person off the street. You're insane. No, I know what chatbots are, and they're horrible. Yeah. So, Hernan, let me ask you, more specifically about AI, as it continues to evolve, as you're just alluding to, what new job roles do you see? Which ones do you think will emerge, maybe in the tech sector, but even more broadly defined?
Yeah, the job of predicting the future is always very difficult, I think, but we can speculate a little bit about that. Don't hold me to it. I think, so first, let's recognize one thing about AI and employability and what AI really does in the job market. So AI created to help us remove the cognitive load as we do our jobs. So if the job has a heavy load of cognitive requirements, AI in many cases can do that really well. So what we can see is AI going in that direction and us moving in the direction of higher level thinking, perhaps. So anything that relates to higher level thinking jobs will probably emerge as newer things. One of the things that I've seen recently, and recently means probably, let's say 3 or 4 years, is our concern with the impact of AI in society, and so things like responsible AI, ethical AI, responsible use. So ethics become this kind of new frontier for us. And if I have to say this by experience, I'm a computer scientist by training with background in mathematics as well. And I was thinking the other day, I wish I would have done perhaps less math and more sociology. I didn't know I was going to be here, down the road. And that's kind of where I'm going back to now. Not so much the math, but more about the impact of AI in society. So I think those jobs are going to continue to emerge, and definitely a good skill set to have.
So Heather, how do educational institutions then prepare their students for this future where these new skills are going to be needed?
Yeah, I mean, there's obviously a ton of research on what are the skills that are needed. And understanding, I think, how to actually interact with AI is, playing with it. And so the data certainly that bears out like the analytical thinking, the sort of problem solving, AI specifically, but it is also, and we were talking about this earlier, this idea of having a fail fast mentality, and how do you actually teach that in sort of the day-to-day for students, so that when they get into business, because that's something that we deal with on, you have to make trade-offs between like going with one project over another, because there's only so much time in the day. So how do you think about identifying those things really quickly so that you can iterate? It's bringing in some of the, I'd say, almost some of like what you're doing here in terms of the interdisciplinary work that you're doing, is sort of thinking through projects and problems that you can iterate on really quickly and work in collaborative teams. Because that's the other thing that I see obviously on the business side is like, how do you sort of build off of each other in really meaningful ways that then gets you to sort of the, okay, I don't have all the answers, but together we can come up with maybe some solutions, iterate on that, and get to the solution that we're talking about. So I think sort of bringing in some of those skills into some of the project-based work, but then also certainly just some of the simulation thinking, I think is going to be really important. I don't know, I'm sure you at Lenovo are thinking through sort of like how and what kinds of people are you looking for as you bring them in? What would you say are some of the skill sets that you're looking for?
Yeah, no, absolutely. So the skills conversation is very important, I think. So 2 things that I'll probably say subjectively, not so much as a Lenovo employee, but let's say as a citizen or somebody who's been in tech for a while, I think that technical skills are super important because that's what gets you in the door, right? And technical, by that I mean not technology technical, but technical if you're an accountant, technically you should know your accounting. And so that's important. And then you're gonna have the ability to display your the rest of your identity and your humanity through soft skills once you're hired. And I think, Heather mentioned, all the skills that are necessary. One skill that I think is super important is independent thinking. And I think, and let me be clear, I did not say critical thinking, I said independent thinking. Semantics matter, I think. So you don't start from a place of being critical, you start from a place of just thinking about, can I arrive to the same conclusion? And if I do, with my own thinking, and not just what somebody told me, but can I arrive there? I think that's an interesting skill to have. And I don't see that, kind of happening a lot. So I'll say that kind of we at Lenovo, absolutely, we pay a lot of attention to both the technical and the soft skills. And but often, like I said, technical skills at the very beginning are going to be very important.
And I'll just say sort of very tactically, we have a platform called MS Learn, it's a free curriculum that we actually use to learn our own technologies that you can embed into, and we allow customers to embed into, whatever classes they want. So that's besides some AI skills initiatives and cyber skills initiatives that we have sort of at the Microsoft level, where we're looking to embed that into institutions sort of across the world. That's something that anybody can take advantage of. And that's one of the, to your point about the technical skills specifically, that's one of the key ways that we are trying to work directly with our higher ed K-12 institutions, but really anybody can take advantage of it in their skilling program. So sort of to specifically tactically answer the question.
Absolutely. Well, let me shift just a little bit, if I could. In what ways are these AI-driven tools reshaping how your companies work? And Heather, you're in this interesting position where you are providing this.
Yeah,
and
we
yet
call
you're being
this
changed by
customer zero is what we call this.
Zero.
So how do we even in Microsoft, when we launched, M365 Copilot and Azure OpenAI, a couple of years ago at this point, we obviously tried to make sure that we were modeling how we actually used it. So, and we continued to do this. So we went through and, did trainings for everybody. And it is a cultural shift overall. It's not something, because it's natural language, you think this is really easy, but you don't always, people initially, I think, used it like a search engine more than actually like a true AI, Gen AI tool specifically. So certainly, just using it to sort of train us and help us think differently. But for example, our customer support organization, we've actually built in AI tools to help with some of the triaging, and that's the organization that actually, if a customer, their environment in, let's say Windows is having some problems and they need to do some troubleshooting, they'll call us. So we need to be able to route those tickets to the right engineers, and sometimes those engineers specialty across the world. How do you build it into the workflow so they can, send it to the right engineer from the very beginning, and the customers then get the answers that they need right from the very beginning versus getting sort of passed off from one engineer to the other. Now, that's one specific example. How we're doing it, let's say even sort of on the field side is, if we want to prepare for a presentation or a customer meeting, you can go through and do some due diligence on all of the information about a certain customer and have it sort of serve that up and maybe build out a little presentation in a way. So there's different ways of it actually pushing out to you information that, you know, because it's sort of all in a graph, we're looking at different ways that we can, you know, even use agents to help with building out proposals and, you know, building out, you know, you can't even imagine sort of the ideas that people are coming with, but we're also even thinking about like, how do we make sure we're meeting the customers where they are specifically? Right. So if you have a question about one of our solutions, how do we make sure that we're actually like capturing that and getting you that information really quickly so you don't have to call up, you know, some of our folks here. You can actually get that first level response and somebody can follow up with you that's been informed about who you are, what you do, and what your interest is ahead of time. So these are all sort of like different ways that we're thinking about and actually embedding it into the workflow within Microsoft. And that's like just the tip of the iceberg, you know, in terms of sort of what what is going on at the mothership, but also like what we're doing day to day in our work.
Fantastic.
Patient zero. I like that
Patient
terminology.
zero,
I like
great.
it. We used to call it eat your own dog food.
Yes, I use that and people just look at me strangely.
Let's politically
but that
correct.
is a saying, isn't it?
So I kind of like that. So pretty much what Heather mentioned here is kind of what the journey is for any kind of technology company, whether it's an OEM or a software company. So we're dealing kind of with the same cases. What I see is the prevalence of agents now, where there's very specialized workloads related to the interaction between the company, a company like Lenovo, and the customer, and then there's the building of agents that really allow anybody in the company to have a much more fine-tuned interaction with the customer, and whether that is our engineers who are dealing with hardware support, for example, or our sales professionals who are dealing at another level with the customer. For us, one thing that may be a little different is obviously we have hardware, so we have to think about that. So the workloads that are created on the hardware side, let's say for support, and let's say for what a terminology from computer science that we probably are familiar with, self-healing systems. You know, back in the day when I was a computer scientist, I was beginning, that was kind of the nirvana. Self-healing systems. And we didn't have, we have a good theoretical model for that, but we didn't have the technical capabilities to do it, but today we do. Yeah. So a lot of the changes in our industry in a company like Lenovo is embedding AI into systems now to make them quote unquote, not fully yet, but self-healing, and that's been significant in our industry, both for the company, but also for the customer, because it creates a new level of resiliency when they really don't have to depend so much on us initially, but they know that they have a peace of mind with the hardware that we're giving them.
Fantastic. Well, I'd like to open this up a bit for questions. So I invite you, if you do have questions, raise your hand. If you can, make your way to one of the microphones. If you forget, I'll simply repeat your question.
Candace. Hello. Okay, so you can hear me okay, right? Yes. So my question actually is for Lenovo, how are y'all innovating with like AI and how you're bringing your devices to your consumer?
You know, we talked about this before the session, right? I said, don't put me on the spot, and that's the first thing she did.
We're amongst friends here.
Yeah, no, absolutely. So one of the things that is happening, and if you've been here for the past day and a half, so yesterday and today, we've seen Jesse talked about some of these earlier yesterday about this, the way the models are being transformed, right? And so two things are happening in AI, and it's going to be a little bit of a long answer, but I want to contextualize it. So we're getting to the ceiling of what we're doing in terms of Moore's law. So physically, the silicon cannot continue to support this growth in terms of the doubling the number of transistors every 18 months. So it's plateauing, but at the same time, we're seeing advances in software efficiency with the models that are really making running AI at the edge much, much easier. So if we think about 10 years ago, if you said, I want to run AI, everybody thought about this big data center, high performance computing environment, and it was just for a few people. So think about today, we're bringing the models to the edge, and so our computing now can support heavy-duty research at the edge. So it's democratizing the research, right? So it's not just for a few who had access to these massive data centers, but now just about anybody. And if you think about how we measure performance today is different than 5 years ago. We used to talk about how much memory and how much CPU and you know, how many IOPS in your storage system and things like that. Now we talk about TOPS. So if you have 40 TOPS or 50 TOPS or 100 TOPS, right, you know that you can run workloads at the edge without having to have this massive high-performance computing environment. So that's a way that we're transforming. We're democratizing with our hardware, and with the advances in AI, we're democratizing research further and further into the edge. And we believe what's going to happen with this is it's a new era of research. A lot more research is going to happen at the edge at a much economic, you know, from the cost perspective element. And so I hope that you put me on the spot with that, Candice. Thank you.
Yeah, and I think too, what you're also getting to is this idea of we have the, you know, Gen AI, sort of the large language models, which are sort of general in nature that can answer all kinds of questions. But then you have the SLMs, which is a lot more fit for purpose. And how do you think about actually building models that are very specific to, you know, a specific disease, a specific area of study that can really do some, to your point, like you can bring it to the personal devices in really meaningful ways and do the computations and ask it the questions that you're looking for really quickly. And I think that's the excitement, for me at least, around sort of this democratization that we're starting to already see. Like, this isn't something in the future. This is actually something that's here today.
Can I just clarify something? Sure. I did say TOPS, and I just want to make sure. I don't know if everybody knows what that is. Trillions of operations per second. So what we're talking about 40 TOPS, 40 trillion, or 50 TOPS, 50 trillion. That's what I meant when I said
absolutely.
Yeah.
Very, very powerful. Just to translate that.
And we're also seeing...
There's a question.
And we're also seeing, as you're saying with the small language models, them moving down to the place where we can actually work and train them locally, which is really astounding. Just yesterday, QWQ from Alibaba was released while we were talking, and it is the same as DeepSeek R1, but it's 32 billion parameter model. You can run DeepSeek R1 on your laptop. You could train it using parameter efficient fine tuning. And if you all missed the session on a parameter efficient fine tuning that was 1 hour ago, we'll have recordings of it. Your question, please.
Thank you. As we're talking about democratizing AI and bringing this as a more consumer-focused product, both as the hardware developer and as the cloud provider, the data center provider, how are we securing this for users, for lay users, not just for enterprise applications or for large research projects, but for example, when my grandmother gets a Microsoft AI-enabled laptop that now has agentic properties or agentic settings, what are we doing to help make sure that the user is safe from accidentally exposing their data or performing actions they may not intend because they don't understand this technology the same way we do?
Yeah, I feel like this should be a Chuck question. I mean, I think at the macro level, I'll just say, because there's a lot in that question, the way Microsoft approaches that overall is with whether we're talking about our applications or hardware, software, sort of the whole is we make sure that from the beginning, security is embedded. So there's, first and foremost, the guardrails are there. If you're using our applications, it's hard to say when somebody gets a device, like what other things they're going to necessarily download. And that, to your point, I think you just want to make sure that, the systems, and I think even on the hardware side of things, that, we're certainly shipping them with all of the security software to keep them safe. The safeguards are there sort of by design, and it's embedded from the very beginning. But it is something that we need to stay ahead of relative to knowing that nation state actors that are getting much, much more sophisticated. I don't know that they're necessarily going after sort of the consumers the way they're going after institutions necessarily. That's not to say that they won't, but I think that's sort of where their focus has been, broadly speaking, that we're thinking about it at both levels, though, on the enterprise level and on the consumer level from the very beginning. And that's from our operations and how we support, the consumer applications all the way to the enterprise applications, as well as on, with the hardware partners we have, like Lenovo specifically. So I don't know if you wanted to comment on that.
Yeah, I have a comment, an opinion really about this, and that is governance will always lag behind the advance of technology. It's just the cycle. It is what it is. We do have the good lessons to learn, and we've seen this play out with social networks, right? So it's basically the same case. Here is a tool, whether it's AI or a computer or whatever that is. Here is a tool or a platform, and originally social networks did not have controls. So everybody was just doing whatever, and everybody was just pulling the data. And we've seen that evolution, right, through governance. Let's give people more control, and let's teach them a little more. AI is very similar, but AI learned the lessons faster because everything in the AI world happens faster. So we originally had these models, and everybody was just giving the models things, and then people were getting back some private data from the models, and the controls came up really fast. So if you're building, let's say, an agent today, and if you attended Dr. Bell's session yesterday about building agents, we did some practical exercises with her, and we were building agents where we had a lot of control on the models and what was the model doing in that agent that we were building. I think that's going to continue to be the case, and that will be one way in which we can help users be protected, if you will. But we also need to teach people a little bit about not just AI, but how do you feel about your data and your privacy? There's an element of it that belongs to the user, I guess. Some other element is technical. I hope that helps.
Thank you for the question. Next question.
All right, thank you. So I am a professor in the School of Engineering, and I teach leadership skills. And both of you mentioned about strategic skills, right? Emotional intelligence. And both of you hold senior leadership positions in one of the largest tech companies in the world. I'm just curious, your perspective, all the new skills or mentality, qualities that you as senior leaders have to adopt in a time of disruptive technology like AI.
Agility, it's a big one, because things are moving so fast that this idea of resilience and agility is super important in order to, I mentioned before this idea of having a growth mindset and being able to fail fast and learn really quickly. But embedded in that is this agility in sort of how you work through the change curve, so to speak. I mean, things are coming, even within Microsoft, I think it's hard for us to keep up with like all of the announcements that we're making in order to stay ahead, to help all of our customers and our partners stay ahead of like what we're doing and how to keep that and make it as applicable and valuable as possible. So I think what at least I've learned is how do I make sure that I'm sort of thinking about this at both like a macro level and a micro level. And so this ability to be really agile in my thinking and then testing that out along the way so that it's not just an intuitive or sort of a data that I get from a macro level. It's also then working with different people, whether it's customers, partners, or my team specifically on like, does this resonate? Is this, and then being able to make small adjustments along the way, I think personally is something that's really, really important. And it sort of goes to, I think, a lot of what we were talking about earlier in terms of like building those skills. But you have to build the resilience in order to be really agile to begin with. And that I think is, again, a learned skill, because it's something that until you go through a lot of change sort of all at the same time, it's hard to build it in. So you have to do it in, I'll just say like bite-sized chunks along the way and bring people in with you along the way. And that's why I talk about like having the conversations with customers, partners, and our team to understand so you can sort of make the changes. So.
Yeah, and I agree with you, Heather. I think we just remember what just happened here. So Jesse just told us that he was having a session talking about models and talking about the latest model, and at the same time, a new model was coming out, right? So think about that for a second, and in terms of skills, really what it teaches us is that probably adaptability is one of those very important skills for, whether you're beginning or you are at an executive level, because we're not going to be able to keep up with the advances and the evolution and the timing of what's happening with AI. So we can have anxiety about, oh my goodness, I just missed this announcement and something just came out, or we can do what reasoning models do, right? Which is take a moment to think about this. I was in your session yesterday, I learned, and be adaptable. Okay, what should my reaction be to this, as opposed to, right? Yes. I'm gonna answer with whatever needs to come out. So I think adaptability will be one of those very important skills.
Thank you for the question. Next question.
Hi, thank you so much for the speech. And I'm actually a sophomore in college, undergraduate, and I noticed that there's an overwhelming usage of AI among my peers. So in a good side, people like actively use AI to explore its like potential in helping us just learn. But on the other side, I noticed like there's a decrease in like necessary skills like decision making, problem solving, reasoning. Those highly important skills are invaded by AI. So my question are from like two sides. So for student, do you have any suggestion on balancing how to smartly use AI while developing our own learning skills? And for the enterprise side, or like education AI side, how do you envision the future of that interaction mode? Thank you.
I can take probably the first part of the question, and I'm going to refer back to one of the things that I talked about, which was independent thinking. So how smartly can all of us, not somebody like you who is a sophomore or you're doing your undergrad, but anybody, any one of us, how smartly can we use AI today and continue to enhance our own learning ability? So independent thinking is one of those skills that I was just talking about earlier, and that is whether somebody tells you something or AI tells you something, can you pause for a second and think about, would I have arrived to the same conclusion independently if I was to do the work that was required to answer this question? And I think it will allow you to enhance your own learning journey, because you're going to use AI, you're going to learn new things. If you independently take a little bit of time to maybe verify some of the facts, you're going to arrive to the conclusion AI is very positively impactful for you, but you're also enhancing your own learning ability. So I think that'll be a smart way to do that.
Yeah. Well, and I think too, this idea of, let's say you're given a paper to do. How do you do the paper and then use AI to maybe enhance the paper versus doing it for you? And this whole idea of, our solution's called a co-pilot because it's not about like doing it for you. It's about helping you think maybe even more creatively than you would have necessarily the first time, and taking it sort of to that next level. So I think that thinking independently is really important, and using it to actually bring you to the next level or build net new capabilities. The other is, so my son's also in college. He's a sophomore as well. He had a law class, a business law class, and he had to study 50 different law, what's the word I'm looking for? Thank you. 50 different statutes, and he was going to be asked about one of them, and he had to present on one of them. So he used an AI assistant to help him build the rubric. It would have taken him many hours to actually build the rubric itself before he could actually start studying. So he actually used it to really help him sort of get through the drudgery part of it in order to actually, again, sort of build out new capabilities, new learning, new ideas to get to this maybe more creative, or maybe just to understand things in different ways. And that's what I think is really unique about what AI can do, is that not everybody learns the same way. And so how do we use AI to sort of teach us? And I think even our CEO was an electrical engineer, and he talked about a couple of specific areas of electrical engineering that even as the CEO of Microsoft, he never quite understood until literally just recently. He had put the concept into Copilot, and it sort of gave him a whole picture for him to think about it differently. So I think that there's ways that AI can actually not help you necessarily sort of think just about like doing the work for you. It's about really taking you to new depths and new ways to actually learn the concepts in and of themselves. That's one of the ways I would think about it.
Thank you. Great question. Next question.
Hi, how's it going? Thank you for joining us. So Dr. Londonio, earlier today during your talk, you had mentioned that you have a background in computer science and mathematics, but that you wished you had done more in sociology. So I'm an undergraduate freshman. I have some time, and I haven't decided what I'm going to study yet. What would your advice be? Because the world is moving so fast right now, it's kind of intimidating. You don't want to study something that's going to end up changing rapidly.
Fantastic. Thanks for the question. This is awesome. So I was trained as a computer scientist through and through, so from my bachelor's all the way to my PhD. And I think when we begin choosing our disciplines initially, we become really interested on the very technical and tactical elements of the discipline. So computer scientist, I wanted to just program the world and do mathematics. That's what I wanted to do. And I was what we call the winter of AI was when I was a computer science undergrad student, and I was writing, some of you may be familiar with this, I was writing Lisp code for natural language processing systems with a professor that was my mentor. He's Dr. Carlos Sigami. He was with NASA, and he was my professor, and he pulled me into the AI side of things. And I'm going to talk specifically about AI because as I grew into the computer science world and I began to see the advances of AI, I began to be more and more attracted to the impact of AI because I knew others were advancing with the technical side. They kind of didn't need me anymore to do that, but nobody was really worrying about the societal impact of something like AI. So I took 2 courses in sociology when I was an undergrad student. One that I remember specifically is sociology of law, and that course really colored my kind of my approach towards, what are we doing with AI, and I recognized the gap. And it is easy to recognize the gap today, fast forward. At the beginning probably was very difficult, but I'll say project based on your interests and your dreams and even your identity. Project what do you think you're going to be doing in a few years. I know it's difficult, and that will probably guide you in terms of your minor, for example, not necessarily your discipline, your major, but your minor, and then choose to do something like that. I hope that helps. Thank you for the question.
Go ahead, next question, thank you.
Hello, thank you so much for coming. Yeah, as we're on asking for advice, I work with a lot of people in a research lab, and I was wondering if you could have some suggestions, both in terms of the specific format and the specific concepts that you use to train your people on how to use AI, right? Like, sure, there's like this young generation that overuse it, but there's also this kind of like older generation who are sort of resistant to it or don't know how to do it. And yeah, how do I teach my peers? What do you guys do to make your workforce use the same technology that you're developing?
That's a super good question because I think we're constantly trying to figure that out. I mentioned when we first came out with some of these technologies a couple of years ago, we went through literally like boot camps. But part of that was actually, going through a day where we put people in cohorts. Where you build off of each other, so you do a bit of a simulation and sort of talk through like, well, how would you do this? Like you go off and do some exercises, and then you come back, and then you share what you were doing, and that's something that we've found has been really successful. It's sort of this mentality of dripping things along the way, but having cohorts come together to make sure that they're sharing with each other, because I think no one person is going to have the same ideas about the best ways to actually leverage the tools. So I think it's important to be able to build off of each other. But one of the important things that we talk about a lot is just using it, even for your own personal ideas. So for example, trying to plan a trip. In the very beginning, my husband was having a birthday party, and I planned like a scavenger hunt for him, basically. But some people are afraid to actually get started because it seems somewhat intimidating. So we're trying to find different ways to sort of bring people in to try the technology out, get more comfortable, because the innovation is happening everywhere. Like there's never going to be sort of one team that is better than the next. So how do you basically sort of like build off of each other and create what I would consider a group of champions or student ambassadors at all levels of an organization, whether it's like a big institution like Lenovo or Microsoft, or at a place like Vanderbilt, where I think, the learning of, how AI could weave its way into operations, into research, into the curriculum, it's going to come from a lot of different areas, but building on top of each other and having champions that can help others in a group and building cohorts, to me, are like all different ways. We're doing promptathons, office hours, like lots of different ways that we could actually take advantage of that.
Yeah, I'm probably not going to answer your question, but I'm going to go into the topic. And so one of the things that I don't know if you all know, but Japan right now is kind of the country that is doing the most research in terms of emotional intelligence. I'm going to connect the dots for all of you in a second. Do you all know why that is? Do you have an idea what that is? Japan is doing the most amount of research now in terms of emotional intelligence. Okay, so Japan is having a big problem right now, and is that there is a big gap between the elderly population and the young population in Japan. And there is not enough young people, Japan is projecting, to take care of the needs of care for the elderly population. So somebody came up with the idea, or some other things that you may know, Japan really advanced in terms of robotics. So somebody in Japan said, well, why don't we use robots to take care of the elderly population? And everybody said, well, it's very mechanic in terms of the interaction between the robot and the person, and we don't think all people are going to have a really good interaction. So what makes this interaction better? Everybody started thinking about that, and they said, well, it's emotional intelligence. So Japan is right now moving very fast, and they're not using the word robots anymore for these agents that they are creating to take care of the elderly population. They use a new word. Does anybody know what that is? They're not calling them robots because it's kind of very mechanic. They're calling them cobots, collaboration robots, right? So there is already, to your question, I don't know that I'm answering the question really, but to point you in a direction of what we are thinking about these things, even at a nation state level. What do we do with the people that are in the fringes? In this case, you're speaking about, elderly population, but what about the people that are disconnected? What about people that don't have internet access? What about people that don't have devices? How do we democratize tools, use, accessibility? This is a big topic, but in this case, you may want to direct your attention to Japan. They are advancing very fast with the world of cobots.
Thank you.
Well, we are pretty much at time. So I would like to thank you both very much for your time, for answering questions. Thank you all for wonderful questions. Hernan, you're going to be meeting with students in meeting room 3, I believe, following this.
Very good.
Okay, great.
Happy to do that.
So thank you both very much.
Thank you for having us.
Thank you for joining us.
So excited.
Hello? There you go. Right. Hi, I'm Soumya Kannan. I'm the Director for Education Initiatives and Workforce Development at IBM. Glad to be here today. I'll talk a little bit about how faculty and students can leverage Gen AI-related education to prepare for careers coming up. So as we've heard from some of the speakers over the last couple of days, innovation in AI is far-reaching. So for example, L'Oreal is leveraging AI to, at the intersection of beauty, chemistry, and technology. They are working to build a formulation model to formulate better cosmetics using sustainable resources and so on. Any race car drivers for our F1 fans here in the room? Okay, I see a few hands. So as you can imagine, the races are exciting not just for the fact that the cars going at mind-boggling speeds, but there's massive amounts of data that's being generated from each car. And so about 10,000 data points are generated per second from each car. So what that means is that there is massive amounts of data that these companies can use to create digital experiences for their online viewing fans. And so that's what Ferrari is doing with the F1 data that we have. Another example of AI's far-reaching impact is, for example, the Grammys. The last couple of years, the Recording Academy has used AI to generate content related to thousands of celebrities over 100 categories and amplify the reach of those audiences. So as you can imagine, if AI is taking over every industry and problem domain, then that requires not just massive amounts of compute and all of that we saw this morning, but also a good amount of skill set that can work with this AI. And so our surveys, the World Economic Forum survey has shown that 87% of executives expect that jobs will be augmented with AI rather than replaced by AI. And then for the same 47% of executives say that lack of knowledge and skills is a critical blocker for them to realize the full value from AI. Specifically, with respect to AI itself, 91.5% of ICT jobs, so your tech jobs that were, you went through your years of computer science training, those are expected to be transformed. And almost 100% of jobs will require some form of AI literacy, right? So it's critical that, even as the technology landscape itself is changing, we continue to build some of the resilience and adaptability skills that Jesse just talked about with the other panelists here to continue to upskill on AI. So I was in the meeting room 3 this morning talking about how to integrate AI into the classroom. Fascinating discussion, and I see a few familiar faces from that room here in this room. So as faculty, what is your experience incorporating AI into the classroom? Anyone want to speak up?
I use AI to generate formative assessments at the end of every session.
Okay.
So we get a transcript of everything that happens in the classroom.
Yeah.
And then I run a prompt to generate 100 multiple choice questions of the topics that we covered, so that they can take five question quizzes as many times as they want.
Yeah.
It's always going to be likely going to be a new question.
Yeah.
So they can test themselves. So just a little bit of credit for it. It's not huge.
Right.
But students really enjoy having that formative assessment, that low risk formative assessment.
That's an excellent use case for AI. So gets the grunt work out, and so you can actually focus on the real high value teaching. Yep. Yep. So, and again, like well, I've been in the tech industry for over 25 years. I worked for, like, I am at IBM today. I work for Google. I work for AWS, Sun Microsystems in the Java SE group. So, been around the block quite a bit. And one of the things that keeps coming up is like technology is rapidly evolving. We as faculty it's hard to keep pace with the technology, especially in the era of cloud and AI, because your hands-on exercises are out of date almost as soon as you create them, right? And then there's lack of clarity on what resources are relevant, what are, legit resources, so to speak, right? That's hard to sift through as well. As a student, and I have had conversations with a couple of students as well in this room in the last couple of days, the question is this right for me? Can I try? I don't know if I want to commit to a year-long program of study. Can I just sort of like get a feel for what this is? Or there's another group which says, okay, I'm all in. What resources do you have? How do I get into this? Will I be able to connect with subject matter experts, right? Can I network with industry professionals to understand what's going on here? And then how can I build skills to prepare for my career? So I want to introduce what IBM has to offer here to help address some of these challenges for faculty and students. IBM has committed to skilling 30 million people globally by 2030. And specifically, there are 2 million people skilled in AI by 2026. IBM Skills Build is our learning platform for learners with job skill, courses for job skills and credentials and so on. So this free education program has offerings for high school learners, university students and faculty, as well as adult learners. No matter what your stage in life is, where you are with your learning, there's something here for you. And the learning offerings here are not just related to pure technology alone. As we heard earlier, you need a comprehensive skill set in terms of independent thinking, problem solving, design thinking, like how do you ask the how might I question to frame your problem, generate customer empathy, design a prototype, go test it, and we heard again and again, like launch and iterate is my mantra for people who know and work with me. That is critical for success, more so today and has always been. And there you go. So IBM Skills Build has short form courses. So these are like 1-hour courses on various topics related to generative AI that you can use to sort of dip your toes in and see, is this right for me? I am a history major, or I am a writing major. I am a sociology major. How does this relate to me? I am a law student. I am a medicine major. What are the ethics implications of this, right? So you can dip your toes in, get a feel for this, and if you do decide to pursue something beyond that, then we have more. Each of these courses, like there's a fun digital sticker you get, show off on LinkedIn that you've completed something, and it beats FOMO for folks who are still on the fence. Let's say you're committed to this, you want to learn, you're convinced that this is the right thing to do. We have courses with hands-on exercises that you can leverage to build skills, learn how to build solutions and practical applications, and earn industry-recognized credentials. So there was someone I was talking to earlier. The question was, what should I do? What should I learn? Industry-recognized credentials are sort of a signal to employers that you have the skills needed beyond the education that your institution gives you, and so on. And these colors of the stickers that the credentials you see here are different levels in terms of complexity. So what does IBM have to offer here, right? So IBM
Granite is IBM's open, performant, and trusted LLM, right? So we talked about open source LLMs and the value of being able to leverage something that's open as opposed to a closed model where you don't know what's going on under the hood. There are a range of models here, from sub-billion to 34 billion parameters. So fit-for-purpose models for various use cases, all open sourced under the Apache 2 license. There are models for text with reasoning capabilities, vision, code generation, time series, geospatial data, and more. So a large set of models for a large range of problem domains. Choose your pick. And all of these models can be downloaded from Hugging Face and so other destinations. So here is an example of a student, Gianluca. He leveraged Granite LLM and IBM Watson X, and he built a comprehensive project. This is a robotics project that he built. And this is an example of a student's journey going from learning to building projects, working with hands-on mentors, and landing a role in the industry that he cared about, right? So that is really critical, that you not only simply learning for the sake of learning, not just doing small prescriptive exercises, but also going all in and building a hands-on, a comprehensive project. It could be a semester project, could be something that you do as a part of your extracurricular student club or whatever that may be. But please get hands-on, get curious, get interested. See what this technology means for the space that you care about. A few more highlights here of students from Johns Hopkins, a bioengineering student who leveraged some of these resources. Student from Grambling who achieved skill badges and certificates that they could showcase to their potential employer, and faculty leveraging this curriculum in their courses. So again, the concept of the academic freedom came up in the discussion this morning, right? How do I preserve the autonomy of the faculty member? While still providing a meaningful learning experience for students? And the courses in IBM Skills Build are designed such that you could take the whole course, offer it as offer academic credit for and credit transfer pathways for those courses, or you could make it a recommended reading, or you could choose just to incorporate the hands-on exercises alone, right? So do what is relevant for your course and your student body that you're teaching. And finally, I want to call this out. Shout out to Jesse here for enabling this partnership with Vanderbilt. We have partnered with the College of Connected Computing. Students are receiving IBM Cloud credits to work with IBM mentors and build a comprehensive solution. And so we look forward to kicking off that engagement soon. Any questions? So here is a QR code, a couple of them. So the first one is if you want to check out the AI-related courses, go grab that QR code. And the second one is a link to an interest form if you'd like to connect to speak more. Happy to do. Yeah.
So, thank you. What is the future of the classic computer science major? My sense is that I would now advise students, get an Asian studies major, learn some of the Chinese language and culture, and take some of IBM's professional courses.
Yeah.
As a desirable alternative to what we classically teach computer science majors.
Yeah. So, you are the expert, right? So you're the expert in the room in terms of technology, the computer science degree, and the contents of the degree itself. My personal take is that the degree has to evolve, and as you likely pointed out in the meeting earlier this morning, that an undergrad degree in computer science is where you are still teaching them the concepts, you're not using AI as much, and you're really learning the nuts and bolts of how things are built. So that when in advanced courses you are leveraging AI, you are able to apply that critical thinking and vet, is this producing the right result, right? And you're able to use what AI has produced for you without like setting aside your brain and just taking its word, whatever it's giving you, and taking that for granted. Right, so I think it still has a place, but expanding your awareness of what else is possible with AI. Okay. Thank you very much.
Yes. Yeah, sure. Hello, my name is Sanjeev Kumar Mirimikala. So Soumya has actually showcased about the skills builder. She talked about granite models. So I'm an architect actually by profession, enterprise architect. So I wanted to showcase the granite in action. So how many of you in this room knows about IBM granite models and have used it? Thank you. So what you'll see here in this, I have two parts for this. One is explaining about IBM Watson X Assistant using Ask SRE. And then the second part I have is a demo, which actually you will see the demo with the prompts which we have tested and so on and so forth. So we actually, every year we go through this journey. Like we have a Watson X challenge. And we participated, and I was leading the team of 10 members, and we participated in this challenge. And then we won the first place out of 11,500 nominations in track 1, which is an agentic-based, Ask SRE. So for those who doesn't know what SRE is, it's a site reliability engineering concept, which is, I'm going to talk about that in the upcoming slide. Basically, site reliability engineering is an IT discipline that focuses on maintaining and optimizing the performance and reliability of software systems. That's in a nutshell about what SRE is about. The people who are working on SRE are called site reliability engineers. So moving on to the next slide. So this is a concept which you can actually look into it, right? So what do they do? The SREs, basically. Like, if you look into the old way of supporting the systems, they primarily focus on problem solving and so on and so forth. The part of this, also the journey you can look into is automation, which is key, where SRE will get into automation, monitoring like 4 golden signals, which is latency, error mitigation, saturation, and performance. So those are the things like 4 golden signals, they also look into it and so on and so forth. So SRE roles are evolving. You can see in the common digital companies, like, people are actually embracing the SRE roles further, and then you can see it is actually coming in action, specifically in maintaining the reliability of the site. So basically, why did we choose Ask SRE, right? You may ask this question, why we have chosen Ask SRE Assistant, and why did we build? So just to bring into the journey of how we thought about Ask SRE, why would it benefit in IBM community, basically. So I work in CIO organization. We have hybrid cloud environment. We support many internal applications, over 1,000 applications, internal applications, and we have SREs span across multiple regions. So we get the request from application team and also from the support and overall, right? So the request, when it gets to the team, everyone has to consistently answer the response. So for example, if you have a new hire, the response may be different in terms of getting the Slack, going through the documentation and so on and so forth. As you can see, when I get into much more detail, you will see the importance of how this assistant is actually benefited in reducing the context switching. And we can actually get to the numbers later on, and when I get to the next slide. So in the context switching, that is really beneficial, and we have actually tested using 100+ prompts. That is one of the factors that we have consistently delivered. We tested it thoroughly and made sure that the prompts behave in a consistent manner. The problem which we try to solve here is to make sure that we reduce the context switching, and we have a centralized place where we can keep all the knowledge, and we have actually published that in the GitHub pages, and we're extracting that using RAG solution, which is a Granite model behind the scene. And yesterday, Jesse has talked about importance of an enterprise scale model, which is IBM Granite model, which has all the guardians. We have set the guardrails in terms of AI and so on and so forth, like the compliance aspect. So now it is built on the foundation model, Ask IBM, and then we have used a workflow to create the Ask SRE assistant. That's in a nutshell about why we have chosen Ask SRE. Now, when I get into the benefits of Ask SRE, right? So I did talk about that earlier, that we want to eliminate the context switching, address the domain-specific knowledge, right? So the SREs are working in different aspects. We have somebody's working in operating system, somebody's working in middleware, so on and so forth. Like, they have core expertise of knowledge. So we have built a domain-specific knowledge and knowledge repository, and we are actually publishing GitHub pages, and we're extracting that using the RAG solution, which is behind the scene, which is a Granite model we are adopted. So this is what we have looked into it, how we actually developed this assistant. So moving on to the next slide. So this is the highlights. You can see in the demo. I don't want to go much in detail, but you will see in the demo upcoming slide. So where I want to spend time here is the workflow. This workflow, if you can look at this workflow, yesterday Jesse was talking about prompt engineering techniques. So in this workflow, you will clearly see all the 5 elements of the prompt. You see the prompt, you see the user, the role, the context, and the question. All the 5 elements are captured here. So the reason why we have chosen this workflow as a template, so we wanted to use this as a template and build other assistant as a governance. Right? So we can actually see here. The SRE field guide, which we have developed, we have actually grouped into a common area, sections, so that when the question is asked, we are not switching from one context to another context. So we are maintaining in the context premise itself, so that we will reduce the number of tokens. That's the one aspect. And also reduce the hallucinations and number of errors and so on and so forth. That's how we structured this. And then we want to make sure that we reuse this one to other assistants we try to build. So, so moving on to the next slide. So the importance of this assistant is the opportunity, right? So we looked at not only winning or losing was not our goal of the challenge. We want to make sure something we develop and it is very effective and it is reusable. That was our goal when we started putting this together as a team. So we found a lot of opportunity, right? The opportunity is that setting a template, setting a structure, and also expanding this to other assistants. That was the opportunity. The value is that improve productivity, as you can see in the upcoming demo, and then there is a productivity improvement in terms of context switching, reducing the hallucination number of errors, making sure that all the prompts are appropriately executed, and it will providing consistent response. Then the impact is that we wanted to make sure that we want to take it to next level, how we apply this to other areas and so on and so forth. To build this assistant, we took only two weeks. Build, test, execute, now it is in production. So that's a true testimony of Granite model, which we have, the framework which we built and we adopted in our IBM, and using that is a true testimony currently. So moving on to the steps, how we adopted this, what methodology we have adopted, right? So we used Agile, IBM Garage methodology when we started this, because it's only 2-week period. So we used IBM Garage methodology, and we figured out how to approach this and test it, build it, develop a solution, build, test, and execute and deploy. All these things we need to do in that challenge. So you can see this experiment, observe, and improve. So we have about 100 plus prompts. We have tested it. Sometimes when you're doing the testing, you will not see the consistent behavior and so on and so forth, which you will see in the demo, and I can actually explain how we can improve and so on and so forth. So the next one I just wanted to talk about is the hallucinations, how we reduce the hallucinations. So we have a set of people who are actually tested, and then we gave it to some separate group, and then we actually made sure that we are getting the consistent response. We actually track those results and so on and so forth. So the next slide, this is the, this is very important because we wanted to see how we are capturing the current scenario of the different, flow when the request comes to SRE, right? So one is, routine requests which they get through. What are the context switching they can actually perform in the process flow, if it is in the scope of the domain, or if you're moving into the different domain expertise and so on and so forth. So this is the net, findings we have it, and we compared that with the assistant, and then we see the efficiency in there. So this is the calculation, so on and so forth. Now, to summarize this, the time saving for end user, right? You can see this 99.98% time saving in end users. We pretty much eliminated the context switching. You can see that. And then the baseline was 190 requests, user, for SREs and so on and so forth. We tested with 100 plus prompts. On the next slide, you can see some of the results. I just wanted to summarize this one further. We actually took this one further and then encourage our community to adopt this Ask SRE, and then also we encourage them to understand about prompt engineering, prompt elements, so on and so forth within the IBM community, and then we move forward with that. So the next one you can see here is the workflow. This is our internal, through our internal application, you can invoke that workflow for Ask SRE Assistant, and then you can ask the questions you can see in the upcoming demo slide. So moving on to the next steps. So we wanted to, we are actually showcasing this one to other, all the clients and things like that. If anybody is interested, please reach out to me. Then we can actually have a one-on-one session, so on and so forth. But we are taking to the next level, adding more capabilities, and we are making sure that we optimize more and test more with more prompts and so on and so forth. This is the next steps we are looking into it. And then now, let me get to the demo slide. Let me run the demo.
Hello, and welcome to Ask SRE Demo. My name is Sanjeev Kumar Merimikala, STSM Thought Leader. Today, I'll be showcasing Ask SRE Watson X Assistant. I'll start off with a brief introduction, discuss some of the highlights of Ask SRE Watson X Assistant, followed by a brief overview of Ask SRE workflow, and finally, I'll showcase by executing few sample prompts and share the results. By the end of this demo, you will see how Ask SRE Watson Assistant works and how it responds to queries intelligently. Let's start off with what SRE is. SRE stands for Site Reliability Engineering. So let me get into a brief introduction of Ask SRE. Why there is a need for Ask SRE Assistant? Why did we choose Ask SRE Assistant? What are the problems or what are the benefits of Ask SRE, and what are the problems or process we are trying to solve or improve? And where is Ask SRE deployed currently? These are the common questions you probably may have. So let me start off with the introduction. So IBM CIO Hybrid Cloud Platforms team supports the CIO Hybrid Cloud environment. We have SRE supporting both infrastructure and applications. And we receive support, basically the how-to queries and boarding process requests daily. To address this, we have developed the SRE field guide to assist new SREs to get up to speed quickly, and current SREs to keep up with the latest guidance and our customers who are looking for support. The SRE field guide is both exhaustive and detailed. To fetch information from SRE field guide and other reference document requires knowledge of SRE operation process flow. So let's look at Ask SRE highlights. So the Ask SRE is tested with 100+ prompts. Currently, it is in production and it's available under community workflow and provides 99.98% savings in time for end users and provides 99.99% savings in time for context switching, built on Ask IBM as a foundation model using IBM Watson X Assistant. Ask SRE workflow can be used as a template or reference to develop other assistants, which I'm going to talk about in the next slide. Adopted using prompt engineering, prompt tuning techniques in developing Ask SRE, and fine-tune prompts using experiment, observe, improve, and technique. So the Ask SRE workflow is actually built using the prompt engineering elements, right? So this is the prompts which we have, like the user prompt, then we have theme and context. So we took SRE field guide and we broke it down into different themes. If you can look into it, SRE knowledge, basic knowledge area, guidance, process, tools, domain expertise, standards and best practices, security and governance. So now if we look at the horizontal pane, we have the context, and then it follows when the user asks a question using the prompt, and then the question follows the theme and it lines up with the context. Basically, we are making sure we remain in the context, the question remains in the context, and we are not context switching from one prompt to another prompt. So that is basically reducing the number of tokens. So now let's execute some of the prompts, and in all of these domain areas, we pick a few sample prompts for our demo purpose, and obviously we can try much more prompts, but for the sake of this demo, these are the prompts have been chosen for execution. So let me take the first prompt and then and execute this using the assistant, Ask SRE assistant. So let me go back to the w3.ibm.com. Like I said, it is available under Ask IBM under Community Workflow. When I click on Ask IBM, click on Ask SRE. This is a Ask SRE assistant. So I'm going to execute the first prompt. What is the link to SRE technical documentation? I'm going to run this one. So when I execute this one, you can see this is providing the link to the technical documentation. This is an accurate link. Actually, I can show it to you, open it in a new window. So you can see this has been executed and then it is available. Open a new window. And this is the SRE documentation, SRE field guide documentation. Okay, so now let me go back and execute the next prompt. So go back to the next prompt. What are the topics for SRE field guide? So now, as I showed it to you, there are topics available. Let's see if it provides you the accurate results. So now I'm going to go back here and execute the prompt. What are the topics in SRE field guide? Right? So the technical documentation, all of this information, the table of contents of SRE field guide, it's actually providing all of this information out there. So now let me go back and check if this is providing the right results or not. So let me show it to you. These are the table of contents which we have. All of this has been provided from there. So you can get deep dive into that right further. So now let me go back and execute another prompt. Define the role of SRE in CIO, right? This is one of the prompt elements, so I'm going to go and execute this one further and show it to you. This is the define SRE role in CIO organization. The role specifically in CIO organization, which is actually defined in our SRE field guide. So this is all this information it is fetching from our SRE field guide and what exactly the SREs do and things like that. So this is very accurate. So I'm going to give a feedback. There is a mechanism here. You can give a feedback, accurate, comprehensive, complete, concise, easy to understand, and others. So you can always say that, if it deviates from what you're asking for, they can fine tune that further. So let me say it's accurate and submit, provide feedback on that. So the next prompt which I want to execute and show to you is, can you guide me to get the help from SRE teams? This is the common question which is asked. So let me go back and execute this one further and show you the results here. And I take this prompt and executed this. And you can see here, it is providing much more details here. Ask SRE assistant. And it is giving you the link to the publisher page where SREs keep their contact information and so on and so forth. Then also the team Slack information, right? So this Slack URL, I'll open it in a window and show it to you. So it's actually showing you the Slack information, right? So it takes you directly to the Slack. Then the next one I have for the demo purpose is, let me go back and execute. The next prompt, what does the Dynatrace tool do in SRE, right? So let me take this question and then execute this further in the next prompt. So it is giving, so when I execute this, you can see it is providing the details about the Dynatrace tool, what it does, and giving you much more information further, like what cost optimization, integration, so on and so forth. And then if you want, you can further drill down and ask further questions and so on and so forth. So let me go back and execute the other prompt again in the acronym, right? This is in the acronym section, right? What does AAP stand for? So let me take this question and ask this here. When I execute this one, it says AAP, right? It should be give Ansible automation platform. Obviously, it gave me Ansible automation platform. It is in the context, in the CIO, right? CIO organization. So it gave me the accurate results. So let me go back and execute the other one. Here, what does the ChatOps stand for? Again, so this is again coming from the SRE field guide. Let me take this and execute. So when I execute this one, you can see the chat ops definition is giving me, and what is in the context of SRE field guide. You can see this, it is coming from the context of SRE field guide, the tools that we use for chat ops and so on and so forth, right? So that is the chat ops prompt. Now the next prompt I want to try out this is, what are the monitoring tools, right, for AIX and RHEL? There could be many monitoring tools, but in the context of CIO organization, we wanted to see what are the monitoring tools available. So let me go back and execute this one and see what are the monitoring tools available. And it is providing again the information from our SRE field guide, which is the Instana and Donut Trace. So next question, the next prompt which we have is, can you list some of the available CIO chatbots? So let me see what it gives. Let me go back here and run this one again in the assistant and see, let's see what it gives. So it gives us all the CIO chat ops bots available, right? And then we can ask what exactly does these bots, and I do have two prompts and just want to execute and show it to you what it does, right? What is the use of CIO SAT bot? So let me go and execute this one further and see what results it gives. So this is the CIO use of CIO SAT bot, and it gave me the definition what it exactly does and help, and then the purpose of it. So let me go back and execute the other one, other bot, which is the utility bot, and show you some of the results here. So going back to this one and run this against, and it is giving me, so what information I can get from utility bot, right? So this was a question, and these are the details which we can actually, it provides. So this is the net summary of the prompts. Obviously, there are much more prompts you can try. These are the sample prompts we have picked for this demonstration purpose. And then finally, I wanted to wrap up this demo with a brief summary on the key metrics. I just wanted to share that with you. So basically, like I said, 99.98% time savings for end users, tested with 100 plus prompts, and then it provides 99.99% savings in context switching. Like I said, if there's a boarding request for any of the tools, monitoring tools and things like that, where the user, the SRE has to refer the documentation and things like that. So that's where we see a context switching happening, right? So that is where we can see the significant savings. Again, for baseline matrix calculations and things like that, we have used 190 requests per week as a baseline. So
Right. So what you have seen here is like the different sample prompts which you have shown. Specifically, I've chosen these sample prompts so that you can actually see, right? So some of the sample prompts I've shown here, if you ask SRE as such, right, not providing the context, it may go into hallucination, right? So SRE could be anything. There was another example I demonstrated, AAP, right? So Ansible automation platform, which has provided the accurate results in terms of Ask SRE in the CIO context, so you can see that how we reduce the hallucination by using the prompt elements and keeping all the conversation in the context. Like Jesse has mentioned yesterday, how important it is to use the prompt elements and prompt engineering techniques so that we can reduce the hallucination, also reduce the number of tokens. Overall, perspective is to reduce the number of tokens, because if we lead into a conversation and you are not getting the results, the desired results, that means you're utilizing more number of tokens. So that is where we can see a lot of benefit. If you have any questions, please reach out to me. My LinkedIn information is there, my contact information is there. And thank you so much. Thank you, Vanderbilt, and thank you, Jesse and the team, for giving me this opportunity.
That sounds good. Great. Fix myself up. All right, so I think we can go ahead and get started. A question for our audience members, just so we can have the true vibe of a fireside chat. Would you all mind coming into the middle? Sorry to uproot you, but would definitely love to feel the community vibe. Exactly, you have to get the right vibe. It'd be like, dim the lights, make it super hot. No, I'm just kidding. All right, all right. So I am absolutely delighted to introduce Curtis Northcutt, who is joining us. Excited to have him. Just heard some really great, exciting news about him and his participation in our partner conference, Convoy. Maybe Curtis, you want to introduce yourself and tell us a little bit about you.
Great to be here. It's a small group, so we should have some interactive discourse throughout this. I was graduated in 2013. This is one of my faculty and professors. He taught me AI.
Anchor down.
I took some of the lessons learned there, and I went to MIT after 2013. I spent 8 years there. I worked with Isaac Chuang, who's not well known in AI or ML, but he's a pretty interesting guy. He invented the quantum computer. He built the first realization of a working quantum computer on planet Earth when he was at IBM, and then went to MIT, wrote the book on quantum computing. Developed a theory of quantum computing called quantum information theory, wrote the book on that, and then I learned that, and I learned how we can apply that to arbitrary machine learning and AI systems. That's on the technical side. I guess more on the technical side, I worked at Facebook AI Research with Jan LeCun. He's the head of all AI at Facebook for the last decade. I also worked with Richard Newcomb, who's the head of all AI at Oculus, now the head of AI for Oculus Research. They just happened to both end up at Meta when it was all said and done. I worked on Amazon Alexa, one of the first real intelligent systems that you could interact with as if it was your own personal assistant, which was a neat thing. It was like this embodiment of something that maybe is almost like a human. Then went to Google and worked on their Google AI assistant. Every time I went to these places, I was hired to do one thing, and that one thing was take a system that isn't quite good enough and make it better. It's a really hard thing to do. I noticed some patterns and built a company based on those patterns that takes AI systems and takes them from, say, 70% accuracy in terms of their responses with people to like 90, 95% accuracy. I think it's one of the hardest problems in AI. I think it's one of the most important problems in AI, and so I've spent a tremendous amount of time on it, and I've failed a lot. I think every success story is actually a failure story. It's a lot of failure stories and one success story, or it's thousands of failure stories and a few success stories, and I'm very happy to chat about those. And then on the personal side, I'm from rural Kentucky. My dad was a mailman. His dad was a mailman. His dad was a mailman. If I had been a mailman, I'd be a fourth-generation mailman.
It's okay, you're still delivering. Delivering one way or another.
That's right. And my mom works in a call center still today. She lives in a trailer. She remarried someone who spent more time in prison than out of prison. So that's my background. My family is still has health issues and is not so well. I have a Series A company valued at $100 million, and I have a family that barely has enough to feed themselves. That's where my life is today. We'll see where it is in 5 to 10 years. Happy to chat about anything about agents, RAG, personal stuff, how I did what I did, and whatever we want to chat about.
Well, thank you for that amazing introduction, and it's so cool to be on the stage with you because it's like being on stage with just the brilliant person with all of the answers. I am so curious just to know, so I love the way that you were talking about going to these different companies and then seeing that a lot of their challenges were really just intersectional. So you were kind of diagnosing similar things or have an approach for diagnosing in a similar way. So can you tell us about your current company, which does this? So it works on being able to improve this AI system. So can you tell us a little bit more about that and how you go about diagnosing and treating these issues of these AI systems?
Yeah, happy to. So let's be very grounded. So the phrase AI is applied to everything. What is AI? So let's start there. So if you have a camera and it's looking at this crowd and it's detecting faces, that's computer vision, that's AI. If we wanted to predict what the market will do tomorrow, the reality is it's a very hard task, and we most likely couldn't do it, but that would also be AI. You would train on every previous, it's called tabular data, financial record, and then you would predict a future financial record. If you wanted to predict if a patient has cancer or not based on a medical health record, you'd analyze all of their previous text, and then you would analyze millions of others' patients' previous text, see what their cancer, whether or not they had cancer or not, train a model on that, and then for some new patient predict that. That's also AI. If you have a robot that's just trying to walk through a room and it just simply has to figure out what are the steps I need to do in order to get from A to B, that's also AI. I learned that in Doug Fisher's course. If you wanted to, say, have a self-driving car that creates what's called a posterior distribution, a fancy word, but all it is just there's something I believe ahead of time, which is that cars should be on roads, and then there's some things I observe along the way, like there's a person. Then I update my posterior, which is a combination of the two that takes into account where I think I should be and where I need to be based on data. So if there's a person in the road, you probably shouldn't actually be on the road. You should probably dodge them. Otherwise, stay on the road. This is also AI. It's a mixture of computer vision planning and execution. That's Tesla cars. The point of all this is that none of this has anything to do with, for example, like when you use ChatGPT, right? And so let's chat very concretely about what type of problem are we talking about. We're talking about ChatGPT. We're talking about RAG. For those that are familiar, we're talking about agents, something where you just type to it and it goes off and does work, solves the task for you, and comes back. And what we do specifically at Clean Lab is we detect all the responses from those type of systems which send you outputs and they interact with people that are incorrect. So now this begs the question, what is incorrect? So incorrect is something that is a threshold of very low probability of that being the correct response for a given prompt, what you type in, and then context. Context is something that you would bring in that you think is relevant to help you solve the task. And I'll give you an example. Say that I'm at Bank of America and I'm building a customer response agent. Let's do Amazon. Everyone probably uses Amazon. So I send a prompt to Amazon, hey, my package was lost. I want a refund. Now that's going to go into a system. An LLM is going to generate a response to you. But before it does that, it's going to look into a database that says, hey, this is all the times you've asked for that. This is all the times this person in the past has sort of done something they shouldn't have done in our system. Are they a good customer or not? They're going to look up all these things. How much do you spend? If you've spent, say, tens of thousands of dollars, that may influence the response. And then there will be guidelines in the background, too, in the context that are like, oh, if this person has spent tens of thousands of dollars, give them a positive response. Make sure you take good care of them. If they have barely spent a little bit, don't do that. So all these guardrails are in the back end of the system. And that's all context. Then you've got the prompt, which is, hey, can I get a return? And then an LLM will make a decision of, can I automatically take care of this customer, or do I need to send it to a human? That's called escalation. What we do in that process is we'll determine if you have very high likelihood of that response being the right response given that context, how confident is the machine in its decision, and should you escalate? And I can give a concrete example. We did this, this is something that I can talk about, but I can't put branded logos, so we're in a nice spot being able to chat together. We did this with a large, major financial institution, one of the biggest in the world. And they had, just like this, a customer support chatbot. And they had, this is pretty wild, their system today, 90% of the time, when it didn't know the answer, or it retrieved the wrong answer and was going to spew something that was wrong information to a user, it did. When it should have said, hey, look, I'm sorry, I don't know the answer, and it should have then kicked that back to a human and brought a human in the loop. So we were able to cut that down with our system that detects right and wrong answers from 90% to like 30%. When they had another system that was around 65% for another large institution, it's a Fortune 50 company, we cut that down to 20% from 60-something%. And so all we're really doing is we're just saying, look, is this a very high probability of being the right response for the given context and the given prompt? And if it is, then go ahead and let the agent, let this AI system produce the answer. Otherwise, don't produce the answer. Say, hey, look, I actually am not qualified to do that. I'm an agent who can't do that. I screw those things up. If you open up your phone, and we're in a live session and everything, but like you can type into ChatGPT, what's the third month alphabetically? And they will just totally get that wrong. If you order the months alphabetically, the third month is December. it will say something random like April or August or something that starts with an A. If you then type that into chat.cleanlab.ai, it will produce that wrong answer still. It's not like we magically invented AI that's way better than every other company. But at the bottom, it will say, you can't trust this answer. It's extremely unlikely to be correct. Do not automate a system based on this, and give you an explanation. And so that's what you now have, and you can build all the guardrails on top of that. It's an infrastructure layer. And I'm happy to chat about the algorithms about how we actually implement that.
And y'all can feel free to use some of the microphones if you just want to ask a question. We heard a lot of really incredible and interesting description of how these agents are working. I'm so curious to know, so would you say that the majority of agents are currently really doing things more autonomously, or do they have a lot of just direct, like, go retrieve this in this case, retrieve this in this case? Is it closer in industry to like an if-elsey thing, or is it really more the agent has seen that it needs to do something and so it chooses to take an action?
Yeah, it's a hard question because it's different for every enterprise.
Okay.
If you think about ChatGPT, that's not an enterprise, that's for B2C, that's for just users. We should, technically, this is a RAG talk, so let's talk about RAG. RAG is a way for an LLM, which is trained on the corpus of the web and all of public information. It's seen most public information. Like if you use, for example, like O3 Mini or use Anthropic's Claude, if you use these models, if you use 4.0, it's seen most everything on the web. If it hasn't seen it directly, it's seen some summary of it, some variant of the information. If you were to somehow take all information that humankind has ever created and then somehow distill that into like a summary and then distill those summaries into summaries, at least at that level, it has seen all of that. And so that's what an LLM has seen. Now think about a business. Business data is private, right? If you actually think about like what is the value of Apple, Apple's value is like how do we actually make consumers buy our stuff? They don't put that online. Nobody knows that data. Only Apple knows that data. It's very core to their business and it's very private. What are their plans? What's their roadmap for the next 3 years? That's all private data. What are all the details about all the customer purchases? That's all private data. This is the stuff that makes Apple worth multi-trillion-dollar company. Yeah. That stuff is all in documents. So how would you somehow have an LLM that knows all of that stuff? That's RAG. So all RAG is doing is it's just like a human being. I have a brain. The brain has two things in it. It has the ability to process neurologically information and also storage of information. So the brain's like this wonderful thing that has both the model and also the data in it. The brain also has a third thing that's often overlooked, which is search. That's another AI, field of AI. So for example, there are whole companies that just do search, and a big one was Monte Carlo for a while. And all they do is just search data. Then there's new companies like Redis. All Redis do is allow you to have a massive database and very quickly query something. It's basically like if you've used Python, it would be like a dict, D-I-C-T, where you're basically just looking up something based on a keyword. I don't know if that's too detailed, but you can ask a follow-up if it is or isn't. So these companies have all made a tremendous amount of success in just making large data searchable. Now let's think about like what a big business is doing. So a big business has literally billions of documents in some cases. Those documents have to somehow be accessed by an AI for that AI to be able to know enough about that business to be unique and specialized to that business's use case. So say that you're at Apple and you want to build something that can make anybody at the company need a new laptop, they can just talk to the AI, and if it's appropriate, they get a new laptop. Well, that would free up about 10,000 people who work at Apple to work on things that are more critical to Apple's business. Apple's business is not to help their employees get new laptops. So it's not good for Apple to have 10,000 people working on that. It's much better for them to have 10,000 people making wonderful products and a better iPhone. So it's a good thing if we can make that sort of work that is just necessary to operate a business actually be focused on making great products that provide value to people. And that's what we're trying to do, but how do you do that? Because an LLM like ChatGPT doesn't know anything about Apple's business. So the way you do it is RAG. And what you're doing is the concept that's been true for every major innovation in AI, and like as much as I know, and Doug may know others, but I'll give you an example, like Deep Blue. We chatted about that in your class, and what was it? The innovation was threefold. There's the model, which is how do we search and predict a new program. There's search, how do we go down the tree? We did a bunch of this in Doug's class. We looked at different types of search. You can do breadth searches. You can look at ways that you can cut off branches of search so that you can do search more efficiently. And if you accelerate to like AlphaGo, which was one of the biggest achievements where we beat sort of the hardest game that humans knew how to play, it was the same thing. It was, again, There was data, which was a bunch of historical games of alpha, of Go. There was a model, which was an LLM that looks at historical games and then predicts the next move. But then there was search. They used Monte Carlo search. So they combined three things: data, model, and search. I'll get back to the question, but it takes some components. So you've got model, data, and search, and you can combine those three things to do most intelligent innovations that we've seen. And in fact, every major jump in intelligence has made an innovation in at least one of those three areas. RAG is one of those innovations. RAG is about searching the data and connecting it to the model. And so that's why RAG is so exciting. And the unique thing about RAG is that now a business can have an AI system that knows everything about that business. That's the difference. LLM or GPT, it can't do that. It just knows what's on the web. But if you connect it to all the data at Apple, then you can know everything about Apple. It's a good moment for an aside, which is that young people tend to be overly critical of people who are older because they don't understand one simple thing, which is that it's not that when you're 50, your memory is just deteriorated and terrible. It's that when you're 50, your database is very full. If you're having a conversation unlike this one, where we're going back and forth in a Socratic manner, in that case, every single message that comes into my brain from the other person, I have to process, I'm 34, I have to process 34 years of data when I respond. If you're only 15, you only have to process, and really the first 10 years of that data are not, those are more growth and experiential data. They're not actually functional conversational data. So if you're 15, you really only process like 5 years of functional data in order to produce a response. And RAG is the same. So if you throw in 1 billion documents for a major enterprise, then the likelihood of being able to produce the right response goes down. It's not that it's not a sophisticated system, it's that the search problem is very challenging. And so the biggest problems that we see in practice are that a company either has a problem with the LLM, the model itself is not very good at producing answers, or the database is so full that the search is really poor, or the data itself is extremely messy and full of errors. And it's almost always one of those three errors. We have yet today seen a major use case used broadly for a general purpose artificial intelligence system from any enterprise that beat 70% in terms of accuracy responses, and every single time it was due to one of those reasons. So back to your answer, every single enterprise is built differently. Every single enterprise has different problems, and so giving you one explanation of why everyone's sort of struggling or why their system's working or isn't is hard, but that general framework is applicable to all of them.
Thank you so much. So I'm so tickled by whenever we start talking about RAG because I remember back in the day when we were trying to develop these systems and would always be just running up against context length, right? So you're super excited about being able to ask questions and use an LLM to help you with your classwork or maybe a grant you're trying to apply for, and then you get to the end of the context, which back in those days, I mean, it's so funny to say back in the day when it was like a year ago, but back in those days when we were limited to like 4096 or something like that. And I think what was interesting about RAG is that it did introduce the ability for us to add in new documents, but the challenging part was, and I think still is, which documents. So, having to search and then sometimes find like some good documents, some that aren't even relevant, it can really, of course, impact the way that the model is able to answer. So what do you think about the general applicability of RAG? So I think most people would say that vanilla RAG, so just doing search and in a specific way that allows you to get back a particular kind of answer based on similarity. It's a little bit of a challenge. So what are the other kinds of RAG that you see most often as you're trying to deliver a solution?
Yeah. So we can do either question. We can do the types of RAG, or we can do failure modes and retrieval and how to resolve those failure modes.
Whatever sounds best to you.
Okay, I think let's do failure modes and retrieval.
Okay, that sounds good.
Yeah, I think there's a never-ending amount of ideas and types of RAG.
Yes.
There's graph RAG, and then there's just classical RAG, and now people are using regular databases. And I think it's kind of never-ending because the field hasn't figured itself out yet. Yep. So let's pause on that one. We can come back to it. The retrieval side is you can actually do some things that work in most systems. So let's go back to this detection side. So if you use, for example, our platform, it's ignore the business side. Let's just focus on the algorithm. You've got a way now to say for a given response that it was a high probability or low probability of being the right response for a prompt in a context. maybe we're curious why. So let's take a branch, we'll talk about how we actually do that, and then we'll come back and we'll talk about how you use that to solve problems in retrieval, to make RAG actually grab the right document. So that's where we'll get to. First, let's figure out how do we actually produce that probability. So I'll give you 5 algorithms. And what we do actually is we combine many more than 5 into this weighted ensemble that we learn. And we learn it for each person. It doesn't require fine tuning. It's pretty interesting, but let's just focus on the types of algorithms that we, by nature of the way that we've built this, will always best. So there's LLM as a judge. It's actually one of the simplest, but it's the one most talked about because people understand it. In practice, it doesn't work that well, but you can use it and it will surprise you and interest you. But if you actually build it for enterprises, you'll notice it doesn't work that well. That's why no LLM as a judge company today is like worth billions and billions of dollars. But there's a lot of hype and excitement, and people will raise a lot of money, and we wish them the best. So LLM as a judge. You ask something, you say, hey, look, here's my given response for my given prompt, and then you just say, do I think that's right, yes or no? And if it says yes, then the judge has approved it, and if it says no, it doesn't. Another thing you can do is when you ask ChatGPT, hey, write me a game plan for how I should talk to my boss about this thing. And then you can say, hey, do you think that was a good answer? Okay, explain why it was a good answer. And as it's doing that, sometimes it will actually say, hey, look, I don't think that was a good answer. And people build these as postscripts. It costs a lot of LLMs. You have to pay the tokens for every one. It's not that accurate, but people do that. People also do these in-the-loop chain reasoning things where they'll have some supervisor system, and then they'll have like a teacher-student. So you'll have a question you want to ask, which is like, what's the 3rd month alphabetically? And then the teacher will say, all right, student, let's think about this. And so the teacher will ask questions using another LLM that generates the teacher's prompts. The teacher then asks another LLM, which is the student LLM, to answer this. The student LLM provides an answer, the teacher guides them, and this back and forth conversation can produce more reliable responses. The downside of that one is, again, you pay for every single interaction. It's very expensive, and it's extremely high latency, and sometimes they confuse each other. So it's not that accurate, but it's a method. Another method is you take an LLM and you split it up, and just so we're on the same page, these are ways to make responses more accurate. Okay, and it's a way to be able to estimate how likely is it that that response is the right response for that prompt and context. So that's what we're trying to solve here. Let's do 2 more algorithms. So another algorithm is you take that LLM you're asking, and then you take some smaller, cheaper version of it, and you ask the same question 25 times. You might even run that question through another LLM that says change one word but keep the same meaning, and run that through 25 LLMs too. And people do that too. Another thing people do is they'll run an LLM 64 times, do the exact same thing, and then just take the most common answer. People do that too. Elon Musk did that, and that's how he got Grok 3 to be on the same benchmarks. What's the downside? 64 times the pollution for planet Earth. But hey, it gets you your marketing. So that's a real thing. That's actually how it was done. Grok 3 was benchmarked that way. You can look into it. If you want to look deeper, it's called Consensus 64, and it's how it was actually benchmarked. If you were just to compare one single run of Grok 3 versus OpenAI or something, it performs much, much worse. It's not even close. But they have a lot of servers. They have the most GPUs in the world, and maybe they'll get better. But that's another thing you can do. Even another thing you can do is you can take the token predicted output probabilities of the response from the model and say, look, this is the probability of the next word, the probability of the next word, and then multiply all those, you get a joint probability, and that tells you how likely that sequence is the right response for the given input. Anyway, so that was a lot, right? I just listed so many algorithms. If you want to go deeper, it's called aleatoric uncertainty and epistemic uncertainty, where epistemic uncertainty measures the uncertainty of the intrinsic model itself. Basically, how good is an LLM at all at answering these types of questions? And aleatoric uncertainty is how confusing is this prompt. And I'll give you an example. If you said, he went there when he went here, when he went over there and handed him this, how do you know how many he's there are, how many people, and who got what? So that is a high aleatoric uncertainty statement, and so giving a response to that that's highly accurate is unlikely. And so by simply the nature of the prompt itself, you know it has a low probability. Now, I'm speaking very technically, and it's kind of boring, but like the reality is if you combine all of those, you can actually build a system that tells you if any AI is right or wrong without actually having to have a test set at all. And there's no data scientist needed. And so what we ended up doing is using just that probability, we can have all of the issues, not all of them, but like 80% with high accuracy, detected automatically with no human in the loop. And so then we have a platform where all the issues are detected from major enterprises. Those are sent then to internal people like customer support reps. And so now no data science is needed. No machine learning research team is needed. No ML is needed. And you have a platform where you can just take all of the things that are wrong in the system and have someone provide the right answer who doesn't know anything about ML. And now a customer support rep who, in some places, my mom's one, she gets paid like 20K. You can have someone who gets paid 20K, hopefully more. That's the idea here. But someone without a college degree in AI or knows anything about ML directly improve a major enterprise's AI system. These are the most funded and expensive systems right now in the economy, with the most ability to provide value and remove laborious work that people don't want to do that's not actually helpful for the business. And you can get someone without technical expertise to do that using this kind of system. So that's the power of it. Now let's go specific into the retrieval process. So how do you use all of that to be able to improve retrieval? Take every doc and now make the query be like this. Here's the original prompt, here's the doc, here's the proposed response, and is it a high trustworthiness score for that response and that doc and that prompt? And then you can use that as your ranking system instead of just the cosine similarity, which is what is used today. And that in itself will already give you a bump. You can do some other little fancy things, like use within each one, you can say, is this doc actually relevant or not? And then with high trustworthiness or not. So all of these are just tricks that give you more and more guardrails effectively. And if it doesn't pass those guardrails, then you say, hey, look, system failed, escalate to a person. Hope that helps.
No, I think that was awesome. So I'm also curious to know, okay, so with RAG, okay, so what do you think about RAG, especially versus the very long context models now? So of course, like for very large enterprises that have tons and tons of documents, there will always be a need to do this RAG search until the context length gets to be like a bazillion, dillion, and infinite, like one company is saying. But so we know that Gemini has like 2 million context length, which is so nice. And we put so many documents in it, and we put videos in it, and it's amazing. So for people who can leverage this 2 million context sort of model, like what do we think about RAG, or what do you think about RAG in the context of that?
Yeah, that's a really good question. That one's yet to be fully determined. So I think we've got a few worlds that are possible. So one world that's possible is that long context windows end up completely eliminating RAG when RAG is used as a single turn system. So quick show of hands, single turn, do we know what that is versus multi-turn? Okay, great. Well, let's talk about it. So
The world is our oyster.
that's great, yeah. So if you go to, does anybody know what Gong is? Okay. Gong is a sales enablement software that allows, if you have a sales team, it allows you to record every single conversation, and then it analyzes the transcript of all those conversations to help you find product market fit. Super useful. There's a lot of other ones that are cheaper than Gong. I think Gong works the best. I think it's the most expensive. That system, for example, has an AI assistant on their website, if you go to help.gong.io, that exists today. And if you ask it a question, it will actually generate the help documentation for you in real time. Now, most companies, if you go to their help documentation, it's static pages that are just loaded, and that's all done by people. But imagine if you had millions of documents and you didn't want to always have to keep up with them. All the documents in that company were just always there, always being updated by the company, and an AI system could on the fly just generate your documentation for you. Well, we don't have to imagine that. People are building that. It's called Chat with My Docs, and it's something that we help support too. It's a really, really good idea. It's a future that I think makes a lot of sense. However, they don't work. And so you have great companies. Gong's a great company. But if you were to actually use that system, you'll notice right away it fails much worse than 70% of the time. It's like 20% accurate. And they're actually a really good company. The fact that they even did it is impressive. Most people are too scared to do it, but they're very ambitious, and they went ahead and released this. So that's cool. You can try it out. So what's single turn versus multi-turn? So single turn is you say, hey, how do I find the number of calls where I talked the most? You type that in, it gives you this document that's generated, and that's it, you're done. That's single turn. Multi-turn is, let me ask a question about this, and then it say, hey, can you provide more evidence about this? And then you say, let me ask a question about that. And then you can say, hey, I want more of that. And a multi-turn system will then analyze that prompt, identify that that is actually kibble for your dog, and then replace that in the prompt when it searches in the database. It'll say, I want more kibble for my dog. And it will actually do that for you in the back end. That's how the system's working. So it's analyzing everything, finding what the query should have been with all those words replaced, and it does that at every single step. So that's multi-turn. Okay, so if we get back to this long context window versus RAG. So RAG is very, very good for multi-turn. For single turn, if you can bring in all the context and just ask it once and it never has to do anything again, why not? And so I think we'll see that for these multi-turn situations, that if the long context actually work, that's yet to be determined. Then we can just switch away from RAG and we'll go to that. You still have to do search, by the way. So you have to search the context and put it in. And so there is some enterprise search combined with long context, but you don't need the full system. If you're doing this multi-turn scenario, you have to access documents at each turn, and I think you do need more complex infrastructure. The reality is the way it'll probably work out is there will be a combination.
Yeah, absolutely. Yeah, I definitely agree. I remember when the paper came out, or I don't know, at this point people are blending papers with blog posts with whatever for their releases of their studies of their models, but I remember when that paper came out about the effective context length as opposed to the one that's being offered, and it being like such a small component, or just like a small like length as compared to 2 million tokens, which is just, I mean, out of this world. I definitely agree. I think that together it's like some elements of RAG and more of the way that we kind of structure how the documents are arranged in certain kinds of stores that we keep them in, that will really like help with retrieval and help us to retrieve the things that we want and get them better. What do you think about agents and their usage of RAG? So we sometimes have like one vector store, and that's where we keep our documents with the representation of them. So we have these multiple vector stores or multiple collections in a single vector store, and with agents, they could choose between them. Do you see differences in performance or what people prefer in industry in terms of being able to retrieve the right vector store?
Yeah, agents are interesting. So quick, let's check in. So quick show of hands. Who here has used Operator by OpenAI? Cool. All right, so we've got 3 of us. So we had to fork over $200 a month to try that out. And that, for me, this is what I think the money I earn is for. It's for experiences, to try new things, to learn new things. So I paid for it immediately. And it said in the description, it said, you can use it to order food. And then there were some examples, sandwich, burrito. So the first thing I did with it is I said, help me order a burrito. And it then gave me a bunch of places and then said, I'll call the burrito place for you. And nothing happened after that. So I don't know what was going on there. So then I was like, hey, did you actually call? And it was like, yes. And then we did that for a little while, and nothing ever happened. So then I tried again. I said, okay, well, let me try to order a sandwich. And it gave me some places, showed me some things on maps. And then I even tried calling them myself and then verifying with them, because it suggested. So we had this whole back and forth. 2 hours later, I had no burrito. I was so hungry that I stopped using the system. And that was my experience with Operator. So I think that's just the reality of where things are. I think it's trying to retrieve. I think it failed on the retrieval. I think the LLM failed. The nice thing about that particular system is that it didn't have any database. So it only has 2 modes of failure instead of 3, so it's more likely to work. I think they knew that too. What you haven't seen yet is an Operator release that's also connected to a massive database. That's for people. And there's a reason for that. It's not that it's just like working out the way it is. It's harder. You've got now error in data, error in search, and error in model. And this is a very beautiful way to think about these problems, because when you break it down so simply, it's just 3 components, you realize every intelligent system can be broken down this way, and you'll notice why things are done, why the products exist that exist, and what their problems are and where they're coming from. But yeah, so with agents and RAG, I think the biggest issue is just the LLM is trying to do things that I think it really needs to be highly constrained. So even ordering a burrito, there's a lot of complexity in that task. And it's most likely that people here have tried to order food and failed with a human. I'm sure we've all experienced that, where it just doesn't quite go well. And so it can totally happen to an AI system. And then is it the AI system's fault? So that's also difficult for us to measure. And this enters the world of what's called observability and evaluation. How do you actually evaluate if the AI system is good or not? Should it outperform your own ability to order a burrito yourself? So that's actually not fully answered question. maybe the last thing to think about when it comes to agents is if you do find like a really, really narrow sliver. So it's the data is always of this form, the search is always the same type of search over a small space, and the model only has to do one sort of very similar task. We can give an example. You have a customer support query that comes in, and all the agent has to do is just route the query to the person, which is not that much more than software. But all it's going to do is it's going to give you slightly better embeddings. It's going to sort of map, instead of a direct mapping, it'll use in some embedded layer. And then it might even like say a little extra stuff like, hey, bring in a manager flag. What is yet to be fully realized is a system that works better than if-else statements, like you were saying early. When you narrow the scope that much, a human can actually build if-else statements. And so the reward, sort of the pain and value trade-off here is, can I get the agent to build that system faster than an engineer would? And so you're really changing the dynamics of like, let me simplify the problem so much, and then if the agent can build a solution or do the solution faster than my engineering team can build if-else statements, then it is still of value. But that's the reality of where we are in terms of reliability.
I love the way you were just talking about that. So in the summer, we had this project with our AI Law Lab and Kat Moon and Mark Williams. And so what it was it was built, the system that we were building was meant to help people that don't really have access to lawyers still access the law. And so, everyone goes through certain things in life, like they need to handle healthcare, advanced directives, like when they're getting older. And some people are unable to do that because, one, they can do a Google search, but maybe the way that the results are phrased to them is super hard to understand, or they need to do something special, and so they need to go to a lawyer. And so the question became, after we just kind of sidestepped all the legal issues, that's for them at the law school to talk about and work with. But the question became, is it better to offer this AI system, this AI agent, the AI whatever, that is sometimes wrong, or just leave these people out in the cold to try to do it themselves? And so I think it's just interesting to consider that as we are building these systems, because some people don't have access to even like this sometimes wrong AI agent. And so, what are your thoughts on that? Like, what are your thoughts about how we think about like these AI systems when sometimes people don't have access to these foundational things that they need?
I don't want to play the position of how to determine one's personal path, or like what's right or wrong is. First of all, I'm of no moral obligation to answer that, but also how could I? I think we just want to try to empower as much as you can. I think giving people access to things that don't work and letting them know they don't work is good. I think that a capitalist economy, by its nature, is not in the best position to do that. But I also think a capitalist economy, by its nature, is in a great position for innovation. And so we have to sort of embrace the beast in the sense that by having a capitalist economy, innovation in the performance of these systems is going up. That exact model is what has funded my company. And if without that, we would not be innovating as much. And so you wouldn't even have access to a future world where you could use a better version of that product that's more accurate. So what we have to do in the meantime is that I think there's a responsibility that is not being paid much attention to, is instead of being all around the hype of how everything's much better, like DeepSeek is not much better. I think I understand what happened there, but it's an amazing thing that has happened with social media and marketing around a model that is not more performant than anything else and costs $100 million to train. It's more performant than not the other best models, the frontier models. And so you have this sort of weird marketing circumstantial thing that's happening. There's also a lot of investor money that's getting lost. That investor money needs to pay the LPs who provide the funding to those investment firms. And because of that, there's a lot of layers between the end consumer and the creators. The creators genuinely want to build AI systems that help people, and the end consumers genuinely want to use AI systems that help them. But there are a lot of layers in between that are funding that process, that are incentivized by nature of their work to make sure that these consumers use things as much as possible and pay for them. And that's the reality of a capitalist economy, and that's going to lead to some of these systems not being acknowledged of just how poor they actually work. It'll always be about how it works better and how it's so amazing, it's the best model ever, and look at all the things it can do. But when you actually try the systems and you really try to rely on them for things that you need, they fail on you. And it's surreptitious. That's the tricky thing. Like if you tried to plan a board meeting and have it write your notes, and then there will be that one line.
Yep.
I think a really good reminder at this time is like, if you give an argument to someone and you give 100 links in the chain, one of my advisors at MIT was Patrick Winston. He told me this. And it's a really good thing. He would always say, look, if you explain an argument and you give a chain of reasoning, if you gave only 3 links and they were all completely solid and strong, then you will be trusted and what you have to share will be appreciated. If you give 10 and they're strong, it will be similarly appreciated, maybe a little more, but it's marginal difference. If you give 100, which means that you gave 99 strong links, but there was one of them that was very weak, it's all anyone can pay attention to.
The one.
And that's a big problem with LLMs right now. You write the document, the legal document using an LLM, and the whole world will notice where it hallucinated something terrible, even though the other 99% was of value. And that's why we can't use these systems, but that's not in the fine print anywhere yet.
I think that's so interesting. I remember I remember this meme one time, which is like it was so inelegant compared to what you just said. But I was looking at this meme, and it had this teacher who had written like the times tables. So 1 times 9, 2 times 9, blah, 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 and they wrote it all the way down. Everything was perfect except for this one that they had just miswritten, or on purpose or whatever. And the students, like, they just really didn't care at all about the ones that they had written right. They only focused on that wrong one. And so I think what you're saying, especially how that same idea applies to LLMs, is so true. Some people will see like that one wrong thing in the LLM and then you say LLMs aren't for me, forgetting that like it did, like as long as you treat it as something that does make mistakes, as you're saying, then you use the parts of it that are correct and then improve upon it as needed. And so yeah, being an instructor in the era of generative AI is definitely interesting. For that same reason, being able to communicate to students that it's not just like the LLM is helpful, but you have to allow it to help you. You are the person that is submitting the homework or creating the project, and it's your responsibility to look at what the LLM is saying. So I absolutely love that point. So another question about the usage of LLMs that I get all the time is about when people are trying to use these systems to do RAG. Sorry. Okay. Cool. So we need to exit the building. There's like this alarm going off outside, and so don't know what it's about, but apparently it doesn't really want to hear about AI agents. Okay. So, but
all right. Yeah. Be safe.
Thank you so much for coming, and please feel free to ask us any questions as we're on our way out.
Hello, everyone. We have a small, intimate crowd, so if you all want to scoot forward, you're more than welcome. Thank you all for joining me on this fine afternoon. I know that this is, I believe, one of the last sessions of the day, so thank you for your attendance. I really appreciate that. So I'm going to go ahead and get started. My name is Matt Estes, and I actually work at Vanderbilt University with the People, Culture, and Belonging team, which is our HR function for staff here at Vanderbilt University. I have a kind of a unique background. I have more of a background in media arts, so think about UX, UI as kind of a background, and I'm actually in the learning and development space. I've been in the learning and development space for about 20 years. Predominantly in the healthcare space, building out clinical education, systems education, soft skills education, and anywhere in between. And now I am applying my craft here at Vanderbilt to build out education for staff. So I'm here to talk to you about how we can actually use AI in our day-to-day work lives, or potentially in our out-of-work lives, to create innovative ideas. So I'm going to talk to you today about some of those ideas, how I've done it, and actually give you some use cases and get into one of the systems that I've used where I've had some moderate success on building some prototypes. So today I really want to explore some of the tech fast-paced landscape, right? I've come in to Vanderbilt from the business world. I understand the demand of the business world, sometimes what people are asking for. I've dipped my toes in the entrepreneurial space, so I understand the rigors and the demand from a speed to market from an entrepreneurial space. So I'm going to talk a little bit about some of that high speed in a tech landscape. I'm going to talk about how AI can help transform and develop some of these concepts and bring them to life. And I'm going to demo a couple of products for you that we've built as prototypes, just to show you that it's not just at face value, something like Figma or something like that, where a UX or UX designer has created something visually appealing, but when you give it to a programmer or coder, they're like, have a lot of questions, right? So I'm going to actually dive in under the hood and show you about that. We're going to talk about some effective prompting techniques when it comes to some of these app-based developments. And again, show you another product that we're working actually with Dr. Chiro Bell on in one of her classes. And then leave you with some key tips and takeaways for you to go out there and apply some of these skills and tools in your own personal life. So I want to throw this out to y'all just to understand where you're at and what you're doing, so I know the audience that I'm speaking to. Just by a show of hands, who in here is doing code development, app development-ish? Who is more of like a business analyst? Okay, great. And then who is anybody in here doing UX or UI design? Any experiential design? As a coder, you kind of have to, right? This day and age, you can't be one or the other. You have to do a little bit of both. So as we get into what I'm going to talk about today and some of the products that are out there on the market that you can go ahead and use, I want to show you as well that I'm not going to take it too seriously. So I'm going to start with a little meme video that I think kind of illuminates what we're going to talk about, but then also some of the struggles.
I got my cursor, I got my V0, I got my Replit. I'm going to be better now. Make the blue box stay in the frame. Please. Now, the blue box is still, now it worked. Now the red box is not in the, please, please, please make the boxes stay in the frame. I'll give you AWS credits, whatever you want. Don't make me call them out, but you are a senior expert. You are a senior expert. It worked. I forgot the yellow boxes.
So as we get into this today, I'm not coming here saying that this is a perfect science, that this is going to be absolute. What I'm showing that we are in a space now where we can rapidly prototype, come up with ideas that are a little deeper than, again, just the static experience on a page. We can actually build out some experiences to get a little breadth to those experiences for people to then take to the next level. So let's first talk about kind of the landscape that we live in right now. There's a lot of high market demands and speed, right? Who in this audience has had a deadline that landed on their lap that you felt was entirely unrealistic? Whether it was an email, a presentation, developing something, right? We all have, right? And I'm sure as you've heard over the past 2 days and you know in your personal lives, AI is here to hopefully help expedite or create some efficiencies in our work, right? If you were here earlier and we were listening to the panel before, there was a lot of discussion around call centers and ways that we could drive efficiencies in call centers, right? If you're putting together slide decks, there's efficiencies to put in the slide decks. It's never a perfect science, but it's helping us drive some efficiencies that's going to help meet those demands of a very high-speed marketplace. Who in this audience has to wear many hats in their job? I think all of us, right? And all of a sudden, you get something that lands on your lap that you're like, oh my gosh, I didn't know I had to do this. And then what do? We go research, we put it in ChatGPT, tell me about this. Maybe still use Google here and there, watch a YouTube video, find a funny one, laugh at that, and then go back to work, right? So we know that this environment that's being created in our workforce is compounding and compounding and compounding, right? So Moore's law, when it applies to AI, we know is expedited, and that's bleeding into the workforce from the high demands that we're now asking of our employees. So again, as we work through some of these tools that I'm going to share with you today, we can again look at how they can expedite your workflow. They can help you create something from what's in here to a rough prototype and a snap of the fingers and help you meet that high demand of a high-speed marketplace. So we know that AI is really changing everything, right? I did read an interesting article today where the CEO of Hugging Face called out the CEO of Anthropic and basically was stating, you know, we're not going to be where you say we're going to be. And the challenge with that is because everybody is looking at AI in a linear fashion, right? They're looking at it the way that things are today. We have to take a different view of the ways that we're applying AI to have some of those breakthrough revolutionary ideas. I kind of equate it that Henry Ford was successful because he made a great car, but not everybody's Henry Ford. Cars are popular because we learned how to drive them. We learned how to use them for transport. It went out to the marketplace and people came up with really good ideas on how to use the car, not because they were an engineer and could build the car. So we, as consumers of AI, have to think of ways that we can leverage it in our workplace to drive transformation, right? We still have to bring that human in the loop. We hear that probably constantly in our talk. Check the code. Oh my gosh, why does the fingers have dangly spaghetti strings on their hands, right? We know that as we're creating things with AI, we still have to QA it, make sure that it's appropriate, and we still have to stay in that loop. It's very, 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 very crucial, especially at this juncture, because we don't want to put out something that's wrong, incorrect. It's going to put egg on our face, and we're not going to feel real happy or confident. It's not going to build confidence in the people we're partnering with. It's not going to put in confidence in ourselves. So we still have to stay in the loop when it comes to a lot of the things we're generating and creating with AI, whether it's from a prompt, an image, a graphic, a video, a snippet of code. So when I talk to you today, what are some of the rapid development tools that we can take advantage of? So the one that we're going to focus on today is the integrated development environments, or IDEs. So that's basically what Replit is. Replit is also available for you if you want to hard code. It can service as a terminal, and you can deploy things through it. It can sync to your databases. You can link API integrations through it. You can use it like a traditional terminal to create and sync out to databases. However, when we get into it today, we have ways that you can use it to have that idea from here to ready to share in, again, a matter of moments. We know too, for those of you that are coders, how many times do you use an LLM to test some of your code or proof some of your code? All the time, right? So we know that this is getting better and better and better. We know that different models are going to service different types of code or different interactions or different prompts, and that we're going to continue to evolve and understand how LLM-powered assistance is going to help, right? We know too that with those LLM systems and platforms that some of them are tailored for various other usages, and you won't use those, as opposed to some are better for coding. Which one are you using to QA your code now? Claude, yep. 3.5, yep. So we know that, again, Claude is great at that, and a lot of people are QAing their codes within Claude. We have also rapid prototyping tools, right? So even Figma has started to integrate some AI into their properties. So if you're looking for quick integration, you can still use other platforms to create UI, UX experiences. We know that there's other automated ways of testing code within systems. A lot of system generators and code platforms have some type of QA system built into it, where you can hit, what is it, like the little starry things now is now the ubiquitous symbol for AI. It lives in a lot of the platforms that we're using, and you can go ahead and QA and test things, whether it's traditional words on a piece of paper or in a document, or it's code in those systems. We now have instant deployment platforms and pipelines. So again, in Replit, we'll show you how today we can go from concept to delivery and deployment in a matter of moments, where you can send out. So you can then go into wherever you have your domain registered, and you can also sync that within the system, and now you could have a website for QA and testing that's live out for the entire public. Don't share it widely until you're certainly ready to share that, but you could go instantaneously out to market with some of those sites. And then we have the still trying to find their space, the no-code editors. And again, back earlier, where Replit is certainly you have to code, you do have the ability to start without coding and prompting, and we'll get to that point and show you that. So how does AI transform some of this prototyping that we're doing? Again, it's going to do code generation. It's going to take an idea that we had and develop all the code, and we can show that to you. It can create databases. I'll show you on one of our examples where you actually have to log in and it's storing my information. Now again, this is for prototyping. We're not saying that now we're ready to deploy and go onto an app store or create a SaaS and sell it out to the market. But what we can do is then go to a coding team. If I had to get investors, I could showcase this to investors and show them the entire details of the program. And we will get into some of these examples, and I think the level of complexity is pretty deep as far as a prototype and example to showcase some of that. We have rapid ideation and iteration, right? So just like in the meme example, he was trying to put certain colors into certain boxes. Just like you have a prompt in ChatGPT and you're helping out with a paper or an email, and you have to go back and you have to continuously ask where, sorry about that. Sorry, somebody was calling me on my Skype. I should have blocked that. So we will go back. So you have that rapid ideation and iteration within there. Just as if you're creating an email, you have the ability to go ahead and ask for another prompt. Hey, move the image to the left, move the image to the right. Give me a table, give me an icon. And these systems have system-generated iconography, imagery, if you don't want to load things into the platform, into a database like you would with a website. You have debugging assistants. So you could go ahead and modify code in these systems, and then it's going to tell you if that code was correct, incorrect, give you error messages. And within these systems, guess what? The systems don't get it right all the time. They debug themselves. You can say, this feature is not working. Can you please check to see why this isn't working, right? And it's going to go ahead and it's going to do that, and it's going to say, hey, this is what the issue was. You then have rapid UI enhancement. Who's ever worked on a site or an app and somebody goes, I want the color blue instead of red, right? I want the icon to be this color or this shape. And you're like, oh my gosh, I spent up all night creating this and it's so beautiful. And then all of a sudden they want to change this. Well, guess what? You can, through AI, now make some of those simplistic changes, again, in the prototyping space. I want to illuminate that again. That's where I'm comfortable with saying this is in the prototyping space, right? All right, so the first example that I want to showcase to you is a concept that we came up. I mentioned earlier, I'm in the learning and development space, and the first idea we had is, wow, wouldn't it be great if you had an environment where people could create their own e-learning to share and take and be a part of, right? Who's ever been asked to take a training and you're like, oh my gosh, this isn't quite the mark, right? So we wanted to keep it simplistic. We wanted to focus on things that are kind of relevant, so feedback, communication skills, email writing, things like that. We're not saying how do you solve complex math problems, but we wanted to try to see, hey, how is this possible? Can we have a self-generated learning platform to allow people to go ahead and create some of those learnings? So I'm going to escape out of this, and I'll actually come up into the system. So first, again, we're not getting paid. The platform we used is called Replit that we used to create this. There are other platforms besides Replit out there that can do similar things. So as you can see here, you have a traditional prompting queue where you would go ahead and you would start to describe the app you're looking to create. When you're using this, they ask you, don't say, hey, code this in Python. They say, just describe the app. And it's going to generate, and you're going to iterate, and you're going to iterate. So as for our first example of what we're trying to do is, again, this is our example that we said called NanoPath, that we are trying to build learning experiences, right? Here's a traditional login page. This is something you would see out in the marketplace. This took us less than an hour to create, all through prompting. So again, you could go in here and you could pretend register. It does sync to a database, so as you return, you will go ahead and enter your same login credentials. So here, mine are saved in my Google, and I just kept it simple because I don't want any security concerns, and it's not publishing it out. So we did take security in mind. But again, once we log in, we come to our landing page where we have previous examples of learnings that we created. So here's a feedback. All of this is created through AI in this platform, in this working prototype. So let me walk through what we did in this experience, and then we can talk for a moment of how this was created. So here, wouldn't this be great if this was out in the real market? You came in, what do you want to learn about? I want to learn about difficult conversations. And I want to know how to have a difficult conversation. So now I'm going to continue. And what we've done is we've created this experience again in Replit. We did use API integrations to an LLM, so it actually is taking this information in this prompt and it's creating it. So now it's synced out to our ChatGPT account, and it created this learning experience. So I'm just gonna pause here, right? Our coders that are in the room, how long would this take to create? Just this simple concept. Couple weeks? Again, moments. So here, now we have this. This is just saying, hey, are these learning objectives okay? Is this something that you would want to learn? These look great. So now what is it going to do? It's going to take a moment and it's going to validate and it's going to actually create a learning experience for us. Again, this is just a prototype. I don't plan on putting this out anywhere, but what it's doing is it's now creating this entire learning experience, and all of this was created, again, in just utilizing AI prompts to create an AI system, to create learning created with AI. That's pretty meta. So it will take a moment, and as it's syncing, I'm just going to pause there too. Is there any questions as we kind of go through this? Yeah.
When we're prompting something like Replit, are we able to instead, if we are working with an already started project, prompt it for a function or a piece of a project and give it certain parameters that we can then slot into that existing project?
You can create so are you asking like if you needed a certain feature for an app and that's what you wanted to create and then integrate that feature into the app?
Yes.
As far as I understand, you could, because you have the source code. You could leverage that source code, test it in Replit, and then put it into whatever database that you have to then sync into that source code. And again, theoretically, it should work, right? So now it's gone ahead and it's created this course. So now I'm going to go ahead and view my course. So here's difficult conversations, and I have it currently just creating AI-generated informations. And here we go. We have an entire course. I prompted it in my prompt when I created it to develop a quiz. Here's all my content, how it applies. And guess what else I had it to do? Create an AI assistant to have a conversation about the learning topic that I created. So I can say, yeah, show me a scenario. And since it's prompted to read what we created, the topic being difficult conversations, it should think for a moment. And again, because this is not a deployed platform, so it's going to take a moment, it should come back with a scenario based on difficult conversations. So there you go. Imagine you're a project manager of a tech company, and there you go. And then it allows me to respond. So me, in the business side of the house, if I walk into a coding team and says, this is the idea I have, can you help me get it? Would you be a lot happier to show you this than just some Figma drawings and say I have an idea? Right? And that's the whole intent behind this. We talked a little bit about earlier about the speed to market. Like, oh my goodness, like look at the relevance that this has. This is way more impactful. So let me come back into my presentation. And we can talk about NanoPath. So again, all we did was have an idea, and then we iterated on our prompt. It kept creating it. We gave it another feature request. We'll get into some of the best prompting with these types of platforms. Don't come in and say, give it a prompt this long with all the features. Just like you would in app development, you would build feature by feature. Get your MVP, then you iterate, you iterate, you iterate. So now I'm going to show you something that we're very proud to demo. And again, this is a real example. The first one was more of let's see if what we can do and test the limits. And again, it's pretty meta to have AI create an AI learning platform with AI and an AI agent. So it's a concentric circle over and over in there. So we had an ask to create a job matching platform. We partnered with a company called The Precisionist. We had some conversations with the Friz Center here on campus. And we had an ask and a concept to create a platform that would link and sync to a job search bank, but it would be focused for neurodiverse job seekers that potentially are coming from the military, or people that are coming into the workforce from incarceration. We found that the environment is very important, especially to those three segments. And we wanted to create a way for them to search for jobs that is more focused on the environmental fit. Is it loud? Is it quiet? And again, there's no assumptions either way of what they're looking for on how we could create an environment where then it would search a job bank. I think we did a look today, and just on LinkedIn, and obviously LinkedIn is huge, I think there was like 15,000 jobs. So even if you came to a modest-sized organization, you might have 300-400 jobs. And yes, you might know, I want to go in IT, I want to go into marketing, I want to go into this. But even there might be a multitude of jobs depending on the size of the company. So the ask was how do we then search that job base and find jobs based on a questionnaire that would be relevant to my environmental search? So we came up with this working prototype. We got in conversation with Dr. Trudeau-Bell. We had conversations with her, and she said, oh my goodness, this would be a great test case for the folks going through my master's degree program on RAG, right? Ideal fit, because what is a job bait? It's compartmentalized data that now you could use RAG to search within and create a platform that could mine those and then come back with a job fit based on environmental search. So if I was to go in and stand up, if you were the class, hey everyone, I have an idea, this is what it is, there would be a lot of head scratching, can you tell me what you mean? I'm not quite sure I understand. So to Replit we went and we created a working prototype which we showed to the class, and it was revolutionary on the ways that they could understand the ask and what we're trying to get to. And then guess what? They're going to use their big brains and their understanding of RAG to take and do something that I couldn't do, but it couldn't have been done if it wasn't for the prototype. So I'm going to come into this now, and I'll go ahead and showcase the prototype to you now. So here we go. Another prototype, something we would see out on the web. One day we will hopefully have 154,000 jobs and all of these great numbers. We wanted to give it as unique of a feel or a real of a feel as possible. So the way that this works, again, this is a working prototype. So we presented this to the class. So now we come in and we have questionnaires. We worked with this group called the Precisionist to help us come up with questions that are relevant to people who are neurodiverse, that could potentially then identify the ideal fit and environment that those folks are looking into. So I won't belabor the point by reading all the questions, but they would answer these 5 questions. And then we're going to see the results. So while this is thinking, what it's going to do is we first used AI, and you'll see the work environment analysis. That is AI generated based on the responses. If I was to take that questionnaire again, my work environment analysis would be different if I answered it different questions. So now me as an end user could come in and validate, yeah, that sounds exactly like the environment that I'm seeking. Now, what phase 2 will be is to work with Dr. Bell and have her students attach all those great jobs that it will now mine and provide realistic or real jobs that it will search to. Right now, this is just example jobs. These are not real jobs. However, it illuminates the point of what we're trying to do with the project in a greater way than has ever been done before, again, with traditional static Figma examples. So what this has done is it's providing a matching score, and then again, in a real world, this would then link out to the job bank that we're partnering with to provide those jobs that are relevant to the environment that I am seeking based on the questions I responded to. So again, another real use case of how we used Replit to go to speed to market from idea to share with a group in a greater way. So I'm going to pause there again. Any questions? What do we think? Do we think that this could really help out in your spaces to have something up here and go to market a lot quicker? Or maybe you're sitting there going, like in the example video where he has an idea and he knows he's gonna be a billionaire, right? So it can help in work. It could help, hey, I have a free Saturday and I have a really good idea and I just want to build something out. I recently was part of an amazing program through the Wondery called the Ideators Program. These were not the ones that I went through that program with. It was another concept. However, right, part of that was to do customer segment interviews. So now I could take real prototypes to a customer segment and say, hey, could you play around with this? And I'm not a coder. Do the buttons work? Does the responses, are they accurate? Right? And now I've wasted $0 other than my monthly subscription with Replit to create a working prototype. So from R&D dollars, you can really drive down the cost too, whether it's inside or outside of the workplace. So I'm going to come back and we can move into some other topics. So we talked a little bit about the best ways to prompt within Replit. You need to be very, very specific when you're first starting and you're creating something. You can't say create an app that does something, right? Be a little more granular. I need an app that shows meeting notes from all the meetings I attend synced to my calendar, right? Iterate gradually. Don't say, only on Tuesdays when it's raining outside and sync to a weather app. Slow down, take a deep breath, and think about how would this user functionality work, and then prompt it as such. Test it. You'll get opportunities to provide and test. If you find something isn't working, figure out why it's not working. Don't try to sell the farm on the first prompt. Create something small, build upon that. Or you might say, hey, I need a landing page for a site. And then guess what? Then you start to build, okay, then I need a portal for users and customers to come into, and I need a marketing page, and I need a video page to show all of our content marketing videos. Okay, well, you wouldn't go and build that site all in one fell swoop. You'd build it page by page by page. So build your apps and test with your apps, app feature by feature by feature, and you'll have a lot more success. So you can also provide it in the context in which you're trying to do. I am trying to solve X. How can I do this? And it will provide back feedback, and it will continue to work with you to create what you're looking for. Because you may not know either. I need to have a login feature that syncs with SSO, but I'm not sure what SSO I'm syncing to. Well, it might give you some examples on how you could build out that feature for testing purposes in a prototype space. So I like to say, and I like to use this as an example, again, if I was to go to Greece, I would want somebody that is from Greece to service as my translator, not somebody that has watched a couple of Duolingo courses online, right? This, by no way of the imagination, is going to allow a layperson off the street that has no coding experience to be able to come in and create the world, right? I have modest understanding of the platform, the system, how things integrate, how to apply and find a API key to enter it in. There are some things that you need to upskill yourself on should you use some of these platforms. However, you don't need to be a Python savant, You can have an understanding of what Python is. Guess what? The more you know, you could see and modify some of those code segments as well. You can also lift those code segments and then put them out into an LLM. The other thing that I really see value in this is I have a 10-year-old son. We play all the time. If I was to send him here and say, hey, what app would you like to build? He could type it in. Then he could look at the code. Then he can start to understand the entire dichotomy of app development, coding, database integrations, all from just playing in a sandbox where he came up with the idea. So yes, this does have novice power, but it also has more power should you be the person that lived in Greece for 25 years as opposed to the person that learned it on the plane on Duolingo over to Greece, right? So use your human strengths, understand the nuance, and then use it as a collaborative tool, right? You're going to probably know more if you're a really good coder than some of the aspects of this AI-generated code. Hey, this is great, but I would have done it like this. Okay, well, you have the opportunity and the environment to go ahead and make those modifications. So use it as a collaboration tool as well. So you're still going to see some AI hallucinations. I am telling you right now, make sure you check all of the security concerns that you may have before you go live. Don't hit an API integration with your bank account, right? Be smart. Don't sit there and tie it back to a company's PHI, right? Use fictitious data, set up a sandbox environment, protect yourself. So that for the example of, for the Wayfinder app that we are looking to do, we pulled jobs off that are live, but we're not going to sync it to a live database. We put them into an Excel sheet, we got those over to Dr. Bell, and then they're going to house them into an AWS server, and then they'll go ahead and mine and access that fictitious data. So be aware of the security parameters. Make sure that you're not doing everything. And then again, there could potentially be integration issues. If you're looking to integrate with other platforms, databases, this again is not a surefire way to have a full shovel-ready project ready to go in the matter of moments. I'm utilizing it in the case of prototyping and having something that's more of a real-world example than we have ever had be able to have the opportunity before. So how do we go from prototype to production, right? So you have to have an initial concept, know what you're going into. Sure, you could go around and play, but there is a cost associated with any of these platforms, not just Replit, but any of these platforms. So, and guess what? There's also cents on the dollar for the amount of data that you're putting in there, too. So if you start to upload a bunch of images and photos, well, guess what? And then you're deploying that, you're going to have usage charges on top of your monthly subscription. So go in with an initial concept and think about how you're going to operate within that. Build out the working prototype. Build it out in the environment. You have the environment to go ahead and play in before you deploy it out. Once you deploy it out, you're going to be able to share it with friends, colleagues, and that's going to be great, but build that working prototype and test internally before you do that. You want to make sure that features are complete. You don't want to send out a prototype that people have to put in their mind's eye and not see. As you could see, I built out the entire feature to sync to a database where it had all the jobs. Although those were not real, the feature was there. You could see the intent of what we were trying to do. QA your work. Make sure that you are aligned with what you're creating. Test it. Make sure that you're testing it on multiple machines. All the simplistic and all the probably the baseline things that you're doing, whether you're coding with an AI tool or a non-AI tool. And then you can really start to focus on being production ready, sharing that out. So when I say production ready, it's more so to share with a coding and development team to help you get this ready to go to market, not to replace our amazing coders and developers. So again, we talked a lot about speed to market. ideas, concepts. So we really found out that this was 2 to 4 times faster than any development. Again, we didn't build out in robust platforms, but you heard that we built it in a couple days, the initial prompt a few minutes, and the gentleman in the front stated it would probably take a few weeks. So you can see again, the timeline for development is going to shrink, which again, we talked about earlier, the rapid environment that we live in now, you have the ability to be faster, leveraging AI for efficiencies. So again, we talked and said, who's had those things land on their lap? Imagine if a boss came in now, or a colleague came in now and says, I need a prototype of an app that does this. Do you think you could have it? And you're ready for them to say 2 months from now, and they say 2 days from now, you can say, gotcha, I got it, we got this, right? We have a client meeting. Okay, well, we can build a prototype. Let's get it done. Let's focus on that. Again, prototype, not ready for market, prototype. We found out that there's a reduction in cost, right? For our coder friends, if somebody came to you and said, would you build out one of these for me? And even if you gave me the family friends discount, it would cost a little bit of money to build out some of those, correct? We don't have to get into your hourly wage, but we understand that those are going to cost money. I just shared with you earlier, we built these prototypes for a $20 a month subscription fee and some modest charges for the data usage and storage. So that's really, really, really reduced cost, especially on if it's a flyer and you just want to see if there's a market for what you're trying to create. That's really, really, really powerful. And the last two is the market entry. You can really reduce that time. We have it at 0. We know that there's going to be a little bit of time, but to go from concept to market, now if I come to one of our development folks with a 80% solution, that's going to drive their time. It's going to drive their cost down to get it ready for market. And now from what may take a year from concept, development, iteration, ideation, over the course of that year, you're now going to market at a much faster rate and able, again, obviously that's time, money, cost, all savings there. So last, I'm going to challenge y'all, go out and find a platform that you like. There's others out there. I encourage you to use, I've used Replit. I've had great success. You saw real case examples. This is not me saying, oh, I found a cool tool, and then you're like, okay, show me, and it's like, oh, it's not ready yet. Well, we showed you 2 use cases examples that I think are pretty impressive to show that the complexity of a prototype is way more than just a prototype. It's a pretty close, ready to go to market prototype with some fine tuning and QA on some of that code, setting up security and all of those other things that we know that we have to get ready for before we launch it out to the world. But we went from nothing to concept to idea and ready now to share with developers to get ready to go to market. So go out and build something real, test it, play with it. Again, I know that we all probably have concepts or ideas. It's like, oh my gosh, if I only had the time, I would build this great app. Okay, well now you could use that as your prototype or your concept or your initial area that you want to explore and build it. You can do that right now. Practice prompting. You're going to have some success. You're going to have some not success. We know that you're going to find some things that work. You're going to find like the gentleman in the meme video where he's ready to give AWS credits and call Sam Altman just because something wouldn't go into the box. You will have fits and starts, and some things that you think are simple may not come out the way you want, and some things that you think are complex are going to work the first time, and you're going to be very shocked. So practice prompting, see what works. And then again, start with a tool. There's a couple of tools out there. You can do your research. You can find out what those tools are. Again, as we shared today, we utilize Replit, and we found that it worked for the example, as I was saying earlier with Dr. Bell, on some of the great examples that we shared. So find a tool that fits for you. And again, it might be a multitude of tools. You might create something in Replit, take and lift the code out, put it in and QA it in an LLM, put it in another platform. You might use a multitude of tools to even do your content creation. You could create a video or something in AI because you know you don't have a video production crew, but you need something that resembles what you want. Well, guess what? You're in Replit. You can upload those videos, those images directly in through that prompt engine, and that will store in their localized database, and it will showcase that in the user experience that you're looking to build. So if you're now saying, hey, I want to build an adventure company and we want to do kayaking. Okay, well, if you have a crew to go out and film you doing some kayaking, or you could go into Midjourney or some other platform and create a small video of kayakers, and then you could utilize that. Well, guess what? You're still at very low cost, and you have realistic, or at least in the vein of what you're trying to market, video content, image content, graphics, logos, etc. So that is my time for you today. I'm going to open it up for questions. Don't be quiet. Not one question. Who's going to go be a billionaire now? Well, thank you very much. Again, my name is Matt Estes. I am with People, Culture, and Belonging. I am here. I actually reside in Maryland, but you can find me if you are here at Vanderbilt and certainly reach out if you have any questions that come up. And happy to share any more information, again, from the development and business side of the house. So thank you all for having me.